Hello, everyone. Can you hear me? We're good? Day two? We're good? Live and clear? Awesome. Please let me know in the chat if you can hear me. All right. I'm Wayne Sutton, Community Manager at Observable. Welcome to day two of Observable Insight. Thanks for joining. We have an exciting day lined up of content. We're going to be hearing from Melody, our CEO and co-founder shortly. Also, our co-founder and CTO, Mike Bostock. Today is going to be an amazing day. And I also want to say thank you all for yesterday. Thank you all for those who attended, for the great energy, the chat, the questions to our speakers, and all while just being fun who you are and just being awesome humans in the chat. Want to go over a few logistics this morning. First, I want to say feel free to use the chat throughout the day as you're doing. Use the Q&A option throughout the day to ask our speakers questions. And also be mindful of our community code of conduct. You can find it in the chat. It'll be posted shortly. And also in the chat, events like this, we have thousands of people registered, asking questions. We know we get, a few opportunities to shine in life. Let's be mindful of the self-promotion or some of the, what we say, sometimes the quiet voices in the chat room. So, let's make sure everyone has the opportunity to participate throughout the day. As well, we'll be live tweeting the event. You can follow us on Twitter at ObservableHQ with the hashtag Observable Insight. If you didn't know, and you should know because you registered, you saw the text on the website, but the theme of Observable Insight is come see what your data can show. So that's what's going to happen throughout the day. We have members from the Observable team answering your questions. They have at Observable in their name. I see Clint from Observable, Cam from Observable, Amanda's here, Paul's here, Courtney's here, Hannah's here. You see them in the chat, so feel free to engage with them as well. Now, without further ado, I'd like to pass the mic, and welcome to the stage to our CEO and co-founder, Melody Meckfessel.
Hi, Wayne. How are you? Good. It's great to see everyone in the chat. Thank you so much for being here. I just want to say welcome to the first Observable Insight Conference. We're in day two, and we have over 1,000 people that are joined yesterday and joining today, and even more people are signed up to join us to hear the sessions today. So if you're not familiar with Observable, we are a collaborative web-based SaaS platform for data practitioners and the decision makers they work with. We bring the data, the context, the logic all together in one place to accelerate the insights that we find in our data, to ask questions together, and to find those aha moments that lead us to better decisions. Observable has been designed to empower people to collaborate and to share our insights with the world. As a community, we're building a place together to explore, to analyze, to communicate with data. And Observable's mission is to help everyone make sense of the world with data together. And that's inclusive of data analysts, data scientists, developers building data apps, stakeholders, professors, students, hobbyists, data viz practitioners. We're all welcome, and we all have something to learn from each other and something to share with the world. So I want to say welcome to everyone. I want to say welcome and thank you to all of the users who continue to be committed to Observable, to making it a better place. Thank you for your suggestions. Yesterday was incredible just to hear the ideas and the questions and the suggestions that were coming up. Thank you for your hard work and generosity to share what you know and to share your perspective with us so that we can make Observable better for you and for everyone else. I also want to say welcome and thank you to all of the folks that are kind of pushing the boundaries of what's possible in visualization. I think yesterday's session revealed the creativity, the insights, the ahas that will lead us all to be inspired to continue this work and to continue to make it better. And I also want to say thank you to everyone who is collaborating with data. Yesterday, really the speakers modeled this, and you're going to see more of that today. How do we build on each other's work? How do we make suggestions? How do we model being curious about the data and being curious together? And I also just want to say thank you so much to the speakers yesterday, and welcome and thank you in advance to the speakers today. We have some incredible sessions that are going to happen. Today, you're going to continue hearing and being able to participate in kind of 4 categories of topics. So there are community talks. These are places to learn best practices and see how the community is using Observable to find insights and to collaborate with data. You're going to see data in action. So you're going to experience how the community uses Observable to build data apps, to create dashboards, visualization, charts. There's a lot of kind of education and sharing of data analysis techniques and insights in those sessions. You'll hear a little bit about our customer stories. Today, you're going to hear from the Marshall Project. You're going to hear from UC Berkeley. You're going to hear from some other organizations that are using Observable to work in private and to get a little bit of kind of behind the scenes insights. And then you're going to see a lot of continued demos, new features. Actually, right after I stop talking, there's going to be a great session by Mike Bostock, CTO and co-founder of Observable, sharing what he knows about all the various features and the best ways to use them. So I hope you have a great day today. Thank you so much for being here. Thank you for all the questions and comments you're raising in the chat, the support you're providing for each other, and I hope everyone has a great day. Thanks so much for being here.
All right, everyone. Thank you, Melanie, for that introduction. And we're excited about this talk coming from Mike Bostock. Observable can do that. And we know a lot of you have been tuning in and been ready to hear see what Mike's going to say, what Mike is going to say, and see what Observable can do. And without further ado, let's go to Mike Bostock, co-founder and CTO of Observable.
Hi everyone, I thought today I would give a quick tour of some of the more hidden features of Observable. It'll be a little bit of a whirlwind. I've got a lot of stuff that I'm going to try to cram into the following 20 minutes. But hopefully you'll learn a couple things that help you be productive in notebooks, or at any rate, give you an appreciation of all the work that goes into the design and building of the Observable interface. So without further ado, I thought I'd talk about inserting cells. It's one of the more common things that we do in notebooks, creating a new block of content. You're probably familiar with this plus button here. It's the most popular way of creating a new cell. It brings up the Add Cell menu, shows you the types of cells that you can insert, as well as a number of handy different snippets down here if you want to do something that's common in notebooks, such as creating a table. Now, what you may not know is that when you click on this, you don't have to just scroll and then click on what you want. You can also start typing to filter it. So for example, if I just wanted a table, I can type table, and the 4 items that match tables will show up. And I can also use the arrow keys to move my selection between these 4 choices, say if I wanted to mark down table. Another thing that you can do here is that we support acronyms. So for example, if you wanted a stacked area chart, you can type SAC and get your stacked area chart. So if there's a particular snippet that you find useful, you can just memorize the acronym for that, maybe hit up or down arrow if it's not exactly what you wanted something else. But it's a very quick way of creating, using this menu to create new cells in the notebook. Now, if you just want a JavaScript cell, you can also double-click this plus button and bypass that menu entirely. An even faster way of creating a new cell is to use keyboard shortcuts. Now, you may have noticed in the bottom left corner of the screen here, I have a keystroke recorder so you can see what I'm typing. Now, Command Enter is basically when you have a cell focused and you hit Command Enter. It's basically the same as clicking on that plus button. It'll bring up the menu. If you hit Command Shift Enter, it's like clicking on the plus button that's above. It again brings up the Add Cell menu. Now you can type table or create whatever it is that you want. An even faster way of creating a new cell, if you want a cell of the same type that you are currently working with, is the split operator. which is Option Enter or Shift Option Enter. So here you can see I'm in a markdown cell, and when I hit Option Enter, I get another markdown cell, and I can bypass that menu entirely. Option Shift Enter is typically used at the start of a cell to insert a new cell before, whereas Option Enter is used at the end of a cell to insert a new cell after. Now, as you might guess, there is also a way to merge cells. That's down here. You can either shift click this button, you get a nice little indicator that those cells are now going to be merged together. Or you can Option Delete, which will merge with the cell after you. You can Option Control D to merge with the cell after you, and Option Delete to merge with the cell before you. Now, another feature that I love about splitting cells, 1, 2, 3, is that if you have multiple carets, which you can get by command clicking, you can split multiple times. So here I get 6 different cells that got inserted. So for example, if you have, some text that you're copying in from Google Docs into a notebook or whatever, you can paste it all into one cell, and then you can hit Option Enter after creating a bunch of carets and get nice separate cells for you to move around and to comment on and that sort of thing. Duplicating is another very useful way of creating new cells. As you might guess, it creates a copy of the cell that you're working with. So if I type foo here and I copy it a few different times, you can see now I have 4 of them. When you duplicate a cell, it isn't initially evaluated. You can see that by the blue play button here, but I can click on that, or I can hit Shift Enter in order to run the cell. Another thing that I like about duplicating, if I have a JavaScript cell, is that it will automatically rename the cell so that you don't get an error with the duplicate definition. So here I have foo, and now I have foo1 and foo2. So a very handy way of creating a copy of code that you're currently working with, say if you want to try, a different implementation or something like that. I'll delete these things now to clean up. And that was a little preview of selection mode. Okay, so selection mode is this blue ring. It's like another focus layer inside of notebooks. So in addition to having the editor focused here, like when I'm typing text, I can hit Escape and I get this blue ring. And what that means is now I can move this blue ring, that's my selection focus, up and down the notebook using the arrow keys. You can also use J and K if you're familiar with the same shortcuts from Gmail or VI. And in this mode, I have a whole new set of keyboard shortcuts that I can use. So I can use Command Enter like before to activate this Add Cell menu, but I can also simply type O, does exactly the same thing. And then Shift O will click on that plus button that's before the cell that I have selection focused. Enter will take me back into the editor. So if you want to move around the notebook pretty quickly, you can hit Escape, you can hit up twice, and then you can hit Enter to jump back down into that cell again. And there are also keyboard shortcuts for splitting cells, although in this case, by splitting, I mean inserting a new cell of the same type after, or a new cell of the same type before. So this is a markdown cell, and hitting Option Enter would give me a new markdown cell that's below, and Option Shift Enter would give me a new markdown cell above the current cell that I'm working with. There are also keyboard shortcuts for duplicating, so Option Shift Down will duplicate below, and Option Shift Up will duplicate it above. And we'll dive into selection mode a little bit more on the next slide. But one last thing that I wanted to showcase is that you can copy cells in selection mode. So again, if I select this and I Command C and I Command V it, now I have a copy of this cell that just appeared below. And that works across notebooks as well, a handy way of creating a copy of a whole bunch of content inside of a notebook. So we'll dive into that now in a little bit more detail. Okay, so cell selection mode. Again, whirlwind tour of all of these amazing features of the observable interface. So J and K, I have these blue rings that I'm moving around to change which cell I have focused. And again, Enter sort of moves me down in the focus stack into the text editor. Escape moves me back up into selection focus. Hitting Escape again will clear my selection focus so that I have a nice clean screen. So if you're in a cell and you just want it to go away, you just smash escape twice, and then you're back to a nice clean interface for reading. Now, what else can we do in cell selection mode? Well, one thing, as you might guess, is we can select cells. So we can do that using the X key, and now I can have little check boxes that appear here. So I can have more than one cell that is selected. That's the lighter blue rings, in addition to this dark blue ring, which is the selection focus. Now, another way that you can get into this mode that might be more convenient sometimes is you can command click. That's holding down the command key and clicking in the gutter. And then you get these checkboxes that appear. It's exactly the same thing. It's just a way of selecting cells. Once you have these cells selected, you can do all sorts of interesting things. So for example, I can use those duplicate shortcuts, or I can use move shortcuts. So Option Shift down will create duplicates. Option Shift up will create duplicates. Now I have like way too many copies of these things. So I'll go back and select them again, and I'm hitting Shift J to select the current cell and the one below it, and then J to skip over, and then I hit D to delete all the stuff that I have selected. Another thing you can do is you can hit P or you can hit dot to toggle the pinned or unpinned state of these cells. And as you already saw, I can use Option up and Option down to move cells around. Oh yeah, you can also run cells. So for example, you're probably familiar with Shift Enter for reevaluating a cell. Same thing as clicking on a play button here. But what if you want to reevaluate more than one cell at once? Okay, so here I can evaluate this cell again, and you can see nothing changes because foo and bar have not been reevaluated. But if I select both of them, then bar will be reevaluated as well as foo bar. And likewise, if I select both foo and bar, you can see that all three of these cells are being reevaluated because foo bar is downstream of both foo and bar. Another cool thing, so you probably have seen the mini map here, which helps you understand the topology or how data flows through the notebook. This cell foo bar here references both foo and bar, so they're shown as upstream. They're inputs to this cell. If I click on foo, it's showing that foo bar is downstream because, again, foo bar references foo. Now, in cell selection mode, you can actually make topological selections using this data flow. Okay, so if I have foo bar selected and I hit Shift left arrow, it's going to select the cells that are upstream. Which is, again, handy for copy pasting. So if I wanted to take this foo bar cell, copy it into another notebook, normally if I just copied foo bar, it would break because I don't have cells that define foo and bar. But if I copy foo and bar using the Shift left arrow to select all the upstream cells, I get all the cells that I need, I can copy them into my notebook, and I am off to the races. All right, moving on. Jump to definition. Okay, so as you might guess, navigating between different cells in the notebook is a very common task, and the faster you can do it, sort of the easier it is, the faster, the more productive that you can be when editing notebooks. One of the best features for jumping around quickly in a notebook is, when you're already in the code, is to jump to the definition of something. So again, I have this very trivial JavaScript example of adding two numbers, 1 plus 2. And you can see in the foo bar cell here that both foo and bar are underlined. That means that they are reactive references. They're references to other cells in the notebook. And if I hit Command J, I will jump to definition. So I had the caret inside of bar here, and Command J will jump to the definition of bar. Whereas if I have the caret inside of foo, it will jump to the definition of foo. Now what happens if you said, okay, well now I know how foo is defined, and now I want to go back to where I was before. Going back is a very common task, so Command Shift J does exactly that. So you can jump to something with Command J and jump back to Command Shift J. Now Command J and Command Shift J sound like they're pairs, but actually Command Shift J jumping back can be used in all sorts of situations. So for example, if I kind of just tab through this notebook here, Command Shift J will rewind my focus. So it just reverses it pops a entry off of the focus stack to take you back to wherever you were, whether you did that by clicking in the gutter or by tabbing and using selection modes or whatever it is. So very handy way of jumping around through the notebook. All right, files. Again, whirlwind tour. So files, oftentimes we are using file attachments inside of notebooks. One of the more convenient ways of adding a file is the Command-Shift-U keyboard shortcut. It's down here in the toolbar as well. It will tell you what that shortcut is. If I pick a file here, such as Barley, you'll see that it gets inserted into my JavaScript. Now, you may not know that in different modes, you get different behavior. So now I'm in a Markdown cell rather than a JavaScript cell, and I will insert that again. And now you can see that I get a link to this file, say if you wanted to let somebody download a file attachment. Whereas in the JavaScript cell, I got an actual code that will load the file and show me the contents of that file. Now, we saw the cell menu before, so I can hit Command-Enter to bring up that cell menu, and then I can type F or FA to get file attachment, and it's exactly the same as Command-Shift-U. Drag and drop, that's another good way of introducing a file. So let's say I have a Markdown cell here, and I wanted to put a screenshot of me in the cell. So I'm going to take a screenshot. Let me just try that again. Didn't do it. Okay, wait for that to go away. Okay, now we just drag. Okay, got the thumbs up. And now I'm going to drag this over here. So I opened up the files pane, and now I can drag onto this area. You can see it says upload files. And then what I can do is a couple things. So I can copy this usage code into my Markdown. That doesn't help me so much because it's JavaScript code. But if I interpolate it like this, then I get a thumbs up of me in the notebook. Let's hide that because I don't really want to look at myself anymore. Very good. So you can also click this plus button here, and that will insert the cell into the notebook in this case, as a JavaScript cell. All right, let's get my smile away. Okay, so copy paste. Yeah, that's another way to introduce content into the notebook. So if I go to the Finder here and I open up a file, let's say I have penguins. Did you know that you can just Command-C to copy a file? So I'll Command-C from the Finder, and I will go into JavaScript, and then I will Command-V, and I got my penguins file just copied from the Finder into my notebook. That also works with images. So if I open up this screenshot and let's see, select this region here and copy it. And then I go back into a Markdown cell, hello, and I paste that in. Now I have my own head pasted into Markdown here. All right, very good. So that's a few ways to upload files into your notebook. Okay, libraries. Oftentimes we're writing JavaScript inside of our observable notebooks, and there are lots of open source libraries that we might want to use. Observable has a number of built-in recommended libraries. They are listed here on this recommended libraries page. So if you want to use one of these, you don't have to do anything at all. You can just type the name and start using it. So for example, I can type D3 and I get D3 version 7.6.1. I can type plot and I get plot. Inputs, Arcaro, AQ. There's all sorts of these built-in libraries that you can use out of the box. Now, another thing that you can do, probably you may be familiar with this already, is that there's a require built-in in the standard library. And this is for using the now deprecated or outdated asynchronous module definition, or AMD format. So this is how you would do that. You would say D3 equals require the name of the library and then at a semver range in order to load it. But this will only work with NPM modules that use this asynchronous module definition or universal module definition format. A lot of modules do not use this. They don't kind of work out of the box with require. But fortunately, you have a few other ways that you can get libraries into the notebook. So one of the more recent ways is using ES modules. So this is now the modern standard for how to package up and distribute JavaScript. There is a CDN called Skypack, which gives you access to these ES modules inside of notebooks using the dynamic import statement. You don't have to use Skypack. There is also JSDeliver or esm.run. It's the same thing. Provides this type of syntax for loading an ES module. So if you try to use a notebook, or sorry, if you try to use a module or package inside of a notebook and it doesn't work using require, try one of these ES module methods. They tend to be more reliable for modern packages. Now, if none of those work, another thing that you can do is you can attach a file to your notebook that has a local module, or sorry, if you've built an ES module of the library that you want to use, you can attach it as a file. In this case, I have hello.js, and I'll show you what that looks like just so you can see it. It's just an export function, hello world. And so again, I'm using a dynamic import statement, but I am awaiting the URL of that file so that I can pass that URL to the dynamic import and then load it. That gives me a module object. So if I wanted to get that hello function that is inside of the hello module, I would type hello.hello. You could also pull that out into a separate cell if you wanted to. Hello world equals hello.hello, and then type hello world. Same basic idea. This can also be used with local files. Now this means that every time you go visit the notebook, you have to choose that file again. But here I'm using it using inputs.file. It's just another way of loading the same file as a JavaScript or ECMAScript module. Okay, URL parameters. URL parameters are a way to kind of pass options or parameters to your notebooks to change behavior. It's very handy to sort of preset the value of an input, like in this example, or to have different views, like if you have a dashboard and you want to link to a particular range, a time range, or if you want to filter the data in some particular way and you want to be able to send a link to somebody, you can do that by putting it into the query string as a parameter, and then accessing those URL parameters using the URL search params class, which is one of the JavaScript built-ins, part of the standard JavaScript web APIs. So in this case, I'm pulling out a param called collection, but I could add something like, let's say, foo instead, and you can see that this is null. But if I add, foo equals hello, and I reload it, now I can see hello here. And as you can see, you could set that as the default for one of your text inputs. It's just a nice way of making a URL or making a notebook linkable in a particular state without having to create a whole copy of that notebook. All right, here's an interesting one. This is a cell that has a bunch of CSV data in it, and it's showing you the contents of that CSV file. So it's parsing this CSV file and showing you the objects that have been extracted out of that. How does that work? Because Observable does not have a CSV cell type. And the answer is that this is actually a tech cell that I have overridden the definition of tech. So normally when you have a tech cell, if I comment this out, you can see it is now being rendered as LaTeX. And the way that works is when you write a tech cell, it is equivalent to using a tag template literal. So this is E equals MC squared. But what we can do is we can change the behavior of tech.block inside of the notebook. So here I've redefined tech.block to extract that string and call D3 CSV parse. And that allows me to change the behavior of this cell mode tech inside of a notebook to do whatever I want with it, which is kind of a neat hack. I think it would be cool to have user space cell modes. Maybe we'll do that in the future so that people can add new cell modes to their notebooks without having to override the behavior of existing cell modes. But I just wanted to showcase that that is in fact already possible. Custom database clients. So here's another thing that you can do. Now you may be familiar with database clients inside of and SQL cells inside of Observable. So for example, I can, what did I want to do? Let's just roll with this example as it is. So here I have, instead of a SQL cell, I have a SQL cell that I'm using GraphQL. So Observable does not have built-in support yet for GraphQL. But in this case, I wanted to talk to the SpaceX API to get information on recent launches. And I've done that by changing the behavior of the database client that is behind this cell. Okay, so this is a GraphQL query for getting information on these recent launches. And you can see it as a JavaScript object down here below if you prefer. The way that this works is I have written a GraphQL database client that takes a URL endpoint here. And all it does is it takes the arguments that would normally be passed to this SQL tagged template literal, and it translates it into a fetch where I'm posting to this endpoint and then pulling out the object response so that it can be displayed as a table. So when we talk about databases inside of Observable notebooks, it's really just kind of a convenience wrapper where you can implement those databases however you want. So in addition to all of the built-in database types that we support, like Postgres and MySQL and BigQuery, there is a whole specification for how to write your own custom database client if you want to connect it to anything else. And there have been some really great community database clients. For example, DuckDB has a database client that's great for working with in-memory data inside of Observable. Okay, the very last feature on this whirlwind tour is debugging. Now, sometimes when you're writing code, it doesn't do exactly what you expect. And you may not be aware that you can actually leverage all of your browser's developers tools to make that job easier. The main way that you do that in Observable is using the debugger statement. So if I open up my dev tools here, which I will do, I don't even remember where that is in the menu. So I'm just going to do Command Option J. Now you can see nothing's happened yet, but as soon as I run this cell again, it's going to bring open the JavaScript debugger. So now I can see the values of X and Y. I can step into the code and do all sorts of things. All right, well, that's it for today. I hope you enjoyed this whirlwind tour of all of these hidden features of the Observable interface. If you'd like to see more tips like this in the future, please let me know. Or if there are other improvements or suggestions that you might have for the Observable interface or keyboard shortcuts or whatever, we'd love to hear all of that too. So thanks so much for listening.
Mike, that was awesome. Hey. Yeah. So after you watch, we're going to take some questions for the audience and get your questions ready. But after you watch your talk, how do you feel about it after seeing your demo?
I mean, I think the main thing it makes me think about is kind of like the depth of the interface, like how many different ways there are to do the same thing. Like initially when I was starting this, I was like, oh, I'll show the 4 ways of inserting a cell. And then I was like, oh, wait, actually there's 6 ways. And then I was like, no, wait, it's actually 8, maybe 10, and I'm still not sure I've counted all of them because there's like so many different ways of doing it. And, I think the reason for that is that people spend a lot of time in notebooks. And we want that to be an efficient experience, like the more fluid it is, the faster that you can do those common tasks, the more effortless it feels, the more joy it feels. Like you can get a sense like when you're struggling with a UI that like it kind of discourages you from being creative, from doing the work. And so, the reason that there are so many of these like little things in Observable is we've all kind of spent so much time in the product, and we've heard from other users spending so much time in the product. And we keep trying to find like new ways to optimize and accelerate these like common tasks that you're doing in the notebook. And I don't know, I was just adding a new keyboard shortcut yesterday for this feature we haven't launched yet. And it's like, it's so great, like just having that like all at your fingertips feels like a superpower.
Oh, awesome. Well, I'm sure there's others probably say you have a superpower, so we appreciate you doing that. Let's jump into some questions. We have a couple questions from the chat. I'm gonna start one from Fran Barton. how do we find out which libraries are built in Observable? I'm sure there's a useful page somewhere, but I'm lazy and I'm quite new to it. So how do I find new libraries?
Yeah, I posted the link. There's a page called Recommended Libraries. I won't read out the URL, but it's in the chat. And basically, we have the standard library, which is kind of all the built-in stuff that Observable maintains. But we know that there's a lot of open source libraries that people love to use as well. And to make that as convenient as possible, we've just built those into the standard library. So if you reference D3, or if you reference plot, or if you reference AQ for Arcaro, they all get loaded automatically. And one of the cool things about that feature is if you don't reference the libraries, they don't get loaded. So it's not like we're loading like 24 libraries on every notebook. They're all done lazily based on whether or not you actually use it. And it also takes care of version pinning under the hood for you.
Nice. Thanks. Aaron, who's one of our ambassadors, has a question, and he saw the tab interface for sales. He was like, is that out already?
Oh yeah. So sorry, that's my bad. We have an experimental UI that I was using, and I recorded my videos with it on. So don't get too distracted or too tied to that, because I don't think that's going to be coming out.
Yeah.
But we are constantly, experimenting with new user interfaces for Observable. And one of the things that's really important is that we kind of put it into production and we try it out in real notebooks. I think one of the things that we found is, you have an idea ahead of time of how well a UI will work, or what you're trying to accomplish with a UI, but you don't really know until you put it out there and you actually start writing notebooks in it and you see your existing notebooks with that UI. It gives you a much better sense of really how it's going to feel under that new approach. And sometimes, we make changes based on that because we see things that aren't working as well as we expect, or we get new ideas of a different way that we could do it. It would be better.
Yeah. Agreed. Next question. There was a question about was that JavaScript and Markdown from Christopher earlier. I don't think it was, but yeah, not sure the right time, the right part of your talk.
Yeah. So all of our cells support JavaScript interpolation. So I mentioned tagged template literals or template literals. That's a JavaScript concept. We could link to that in the chat if you want to learn more about that. But basically, it's the $ curly braces. So whatever cell type you're in, if you're in Markdown, if you're in HTML, if you're in SQL, you can do $ curly brace and then write a little bit of JavaScript and then close the curly brace. So that's a really powerful feature as well. So for example, if you have, you're writing Markdown and, you're writing about, some analysis that you're doing and you want to reference a number that you're computing directly from the database, rather than, typing out that number, like hard coding it, you can interpolate a JavaScript value dynamically into your Markdown. And that number can even be, dynamic. Like if you have interaction on your page where you're dragging a slider, when you do this interpolation or this embedded expression using the $ curly brace, that will update. It'll update the Markdown whenever that value changes.
Awesome. Thanks for that. There was a question about, can we create our own tag types like text?
Yeah, so I mentioned that one. I mean, you can't right now. You can only override the behavior of the existing built-in ones. And I feel like tech is probably the most niche of the existing cell modes. So that's kind of what people gravitate towards overriding. They're not always writing mathematical expressions in their notebooks, but it is super useful if you do need to do that. We might support it in the future. I think we just have to kind of figure out what the semantics for that would be. Like how you would declare that you're making a new cell mode, because currently the UI needs to know like these are the 5 cell modes that we support, or the 6 cell modes, or whatever. So there's not a way to sort of register a new type dynamically. But maybe we could figure out a way to do that. Yeah, that would be interesting. Or we could say, like, I don't know. I don't want to spitball ideas right here, but I think there are some ways that we could make that work. Yeah.
Yeah. Nice. Another question from Lucas. Is the URL parameters trick automatically built to override input cells? Do we have to handle it via JavaScript?
Yeah, so that's all done through JavaScript. There isn't any kind of special support for that right now with the inputs. So if you wanted to do it as kind of the default value for an input, you kind of have to tie those two things together, where you'd first use the URL search params to parse the location.search, and then you would set the value option on the input, which sets the initial value of the input. We could definitely add like built-in support to the inputs, maybe as like a convenience option where it would automatically pull the value from the parameters directly. That's a nice idea if somebody wants to file a feature request to the inputs repo.
Yeah. Someone from the team can drop the repo feedback and feature requests in the chat. That'd be great. Thanks for the question, Lucas. This question. Let's jump to talk about some other program languages a little bit. Do you see JavaScript replacing vectorized languages like R and Python?
I don't think it's replacing it. I mean, I think, like nothing ever replaces anything. Like it's always just increasing the number of languages that we have, and they all do end up getting used together. And so I think, these languages are each have their own strengths. They're good at different things. And in particular, I think the thing that JavaScript is best at is being on the web, like sharing interactive presentations, interfaces, applications, doing stuff dynamically inside the web browser. It's the native language of the web. It's what all the browsers speak. So if you want to run code in the client, that is the natural choice. That said, I do think WebAssembly has a lot of momentum behind it and is bringing in other languages. So being able to use PyDie, for example, like the Python WebAssembly project is pretty exciting. You can use NumPy and you can use Matplotlib within a browser using WebAssembly. The GraphViz implementation that we use, so we also have a dot tag template literal for doing sort of diagram layouts. It's really handy syntax for making node link diagrams, state machine diagrams, that sort of stuff. Use it all the time. That is done using Emscripten to compile it into WebAssembly, because I think GraphViz is originally written in C++. So there is a potential for lots of these other languages to work well in the browser. And I do see us continuing to explore that in the future. But I wouldn't necessarily look at it as kind of replacing those languages. I see people using hybrid workflows where they do different stuff in different languages and different environments. So for example, if you're doing a lot of, machine learning model training or very expensive offline data crunching, you're not going to want to run that in the browser. That doesn't make sense to do it interactively. You're going to want to schedule that up as a process that runs asynchronously, and then maybe you consume those results into the browser, using an API, using snapshots or something like that. And so in that case, again, you might be using lots of different languages to combine into your workflow.
Yeah, agreed. Just want to say to everyone asking questions that we're going to share all the resources that Mike's talking about and all the other speakers after the event. So be on the lookout for that. But let's jump into.
Can I add one more thing on the languages stuff that I just thought of? Like, I think one of the things that helps is kind of similar concepts in different languages. Like there are reasons to use different languages, like why you might want to stay in Python or you might want to stay in R. But I think one of the things that also helps is knowing like what the equivalents are in JavaScript. So for example, I think one of the reasons why we were so motivated to build Plot is that we wanted people to have, a really good high level visualization library, something similar to like ggplot2 that they might use in R, or Matplotlib that they might use in Python. Have that really like convenient, like quick way to make a visualization inside of the browser. And of course there is Vega Lite and other sort of web-based high-level grammars for doing visualization as well. But I think it's important to kind of increase the visibility of these approaches so that people don't assume that like just because you're doing it in JavaScript means that you have to write like hundreds of lines of JavaScript and D3 and all that stuff. Like there are lots of really great tools for doing exploratory data analysis in JavaScript, and that functionality keeps growing and improving over time. I mentioned DuckDB in the talk already, but I think that's another example of people, being able to run, SQL in memory, doing really rich data transformation and analysis in the browser.
Awesome. No, agreed. Let's take one more question from John. Any possibility of an IDE style documentation and suggestions inline in the cell?
So I assume that's referring to like IntelliSense and like better hints and that sort of stuff. And yes, in fact, we just launched last week some of that. So for the JavaScript built-ins, like using the date API, or what is it, like the date formatting, like has all of these like different arguments. Like there's a good example of it, like showing you what the valid values are for all of the different fields that you can format when you're doing localized formatting of dates. So we just added that. That's using the TypeScript server underneath the hood. So the same kind of functionality that you get in VS Code for showing you type hints. The thing that we need to continue to build on is more type definitions, more documentation for the APIs that people commonly use, and more type inference on the code that you're writing inside of Observable. So for example, we're working on JSDoc and type hints for plot, so that if you're using the plot API, you'll get those same hints, observable inputs. And ideally, we'd like to get to the point where you can write components inside of Observable and surface those as hints using the same framework. That'll require more smarts in doing code analysis. Maybe one day we'll have TypeScript cells in Observable. Not committing to it here, but I think we all use TypeScript internally, and it's really great. So I could see that happening.
Awesome. Well, Mike, thanks for the tips. Thanks for showing everyone what Observable can do. Thanks for answering the questions from the community. And thank you all for the questions as well. So we appreciate it, and we see you in the chat.
Yeah, thanks, Wayne. Thanks, everyone.
Yeah. Awesome. Well, that was amazing. It was also always good to hear from Mike Bostock. And thank you all for your great questions. We really appreciate it. And thank the Observable team for also chiming in and answering the questions, putting the links in the chat. Things are going well. It's day 2, Observable Insight. Come see what your data can show. That's the theme of the day. And now we're going to switch gears a little bit. Now we're going to talk about happiness. Not just any type of happiness. We'll talk about the happiest notebooks on earth from Alison Hill, our next speaker at Observable Insight.
Hello. I'm so excited to be here at the second day of the Observable Insight conference and to talk with you all about what I believe are the happiest notebooks on earth. So hello, my name is Alison Hill and I'm the Director of Knowledge at Voltron Data. Previous to that, I was a data scientist and professional educator at our studio, nay Posit. And I was also the product manager for data science communication at our studio, which means I worked closely with the developers who worked on maintaining the R Markdown ecosystem and on developing the second generation of the R Markdown ecosystem, which is called Quarto. So today I'm excited to talk to you all about some of my reflections from being a notebook user first, a notebook educator second, and a notebook product manager third. So I'll start going back in time. Once upon a time to 2018, there was a JupyterCon talk called I Don't Like Notebooks. And I watched this talk with great interest. You can see the link to YouTube at the bottom. And I really enjoyed the author and his arguments for why he doesn't like notebooks. It was really intriguing to me, especially as a person who had only really used notebooks in the R Markdown ecosystem. I found it fascinating to hear some of the complaints and use cases for notebooks from Joel. So here is a selection of them, and these are pulled from one of my colleagues' blog posts, UA, who wrote a really great blog post that I encourage everyone to read called The First Notebook War. So here were some of Joel's complaints: hidden state and out of order execution. Notebooks are difficult for beginners. Notebooks encourage bad habits. Notebooks discourage modularity and testing. Jupyter's autocomplete seems to be awkward. Notebooks encourage bad processes. Notebooks hinder reproducible and extensible science, which is a yikes. Notebooks make it hard to copy and paste into Slack GitHub issues. Errors will always halt execution. Notebooks make it easy to teach poorly. and notebooks make it hard to teach well. So as a bystander, when I first saw this talk, I was really fascinated, and I really enjoyed Iwei's blog post because it really broke down some of the differences that existed between the tools that Joel was struggling with and the tools that I had happily not been struggling with for many years. And then later on, there was a follow-up talk in a land far, far away by Jeremy Howard, who actually did like notebooks. So his talk was titled, I Like Notebooks. And this was also a really interesting talk. Again, the link to the YouTube video is down below here. But Joel and Jeremy both had really interesting takes on Jupyter Notebooks in general. And Jeremy really came from a place of talking about one of the tools that he's been working on developing called NBDev, which I encourage you to read a little bit more about if you're curious. But meanwhile, while all this was going on, I had just been working in R Markdown for a long time and really enjoying it. So I had become a product manager. I'd been knitting notebooks to my heart's desire for many years, previous to joining RStudio and then as an RStudio employee. And I even did a search on my own GitHub for the different file extensions that I could have been using just to see how many files I had created in my time of using GitHub. And keep in mind, these are just the ones that I'd created, not ones people had shared with me. So 607 total in my GitHub. So that tells you that I was a pretty prolific notebook maker, and also I was a pretty prolific notebook collaborator as well. So in this talk, I really wanted to share some reflections I have from being, again, a notebook author, a notebook educator, a notebook collaborator, and then a product manager who heard a lot of the complaints, a lot of the pain of notebook users, and also was a really good sounding board for all the features that people were requesting. So I think part of the problem with the two talks that I started with, the I like notebooks and I don't like notebooks, is that we're still talking about tools and features. And we're still mainly talking with engineers. And in the world of Walt Disney, there was this idea of an Imagineer. And I've always really liked thinking about this. So Walt Disney created this creative team of artists and engineers who designed the theme parks. And this was really all about having those complements and having different people looking at the same problem in different ways. And I think that this is a really good thing for us to also do with notebooks, to think about how we can bring more creative people who work with data, people who work with other mediums, to be able to help us improve the notebook experience for users, because engineers may not be the best users of notebooks. They may not enjoy them, or they may not have many use cases for them, but I can tell you as a user that they are very useful. So there's this quote from Walt Disney that I'll read out loud. We keep moving forward, opening up new doors and doing new things because we're curious. And curiosity keeps leading us down new paths. We're always exploring and experimenting. We call Imagineering the blending of creative imagination with technical know-how. So this is exactly what I hope to do in this talk today, is to kind of blend some creative imagination with the technical know-how. So I'll start with some basic definitions of notebooks. So Mike, who spoke earlier, his definition in one of his notebooks is an interactive, editable document defined by code. It's a computer program, but one that's designed to be easier to read and write by humans. And I completely agree with this definition. It's a great definition. And that's exactly what we want, is something readable and writable by humans. Martin Fowler calls it a computational notebook as an environment for writing a prose document that allows the author to embed code, which can be easily executed with the results also incorporated into the document. So these are just basic definitions of notebook. And here's just a basic version of a notebook. So this is the kind of notebook that I would typically work with. This happens to be a Corto source file. So this is what I would typically look at when I was opening up a file and had written a little bit of code. You can see that it starts off with a block between two dashes. That's called the YAML, or the metadata block. And that has some stuff about the document, like the title, the author, the date. Then you can see that there's some text below that. So air quality is a markdown header, and then there's a sentence there. And then that's where a code chunk starts. So there's the 3 backticks and then the R in curly braces. That tells you that our code is coming up. And then that's some code that creates a ggplot graphic in this kind of notebook. So maybe instead of thinking about features and benefits of a tool, I think it's really helpful to frame out why make a notebook in the first place. And my favorite description of this is I'm copying and pasting literally from R for Data Science by Hadley Wickham and colleagues. So the first reason to make a notebook that Hadley outlines is for communicating to decision makers who want to focus on conclusions, not the code behind the analysis. So the idea is that you want to be able to make something that is low code or no code, but high insight. The second reason is for collaborating with other data scientists. That can include yourself, who are interested in both your conclusions and how you reached them. So these are the people who would actually want to look at your code, including you. And as an environment in which to do data science, as a modern day lab notebook where you can capture not only what you did, but also what you were thinking. And so I think these are the three different use cases for me that I've seen using notebooks. And I think they're actually really powerful use cases. And I found notebooks extremely useful for these use cases above and beyond what I could have done without a notebook. And in some ways, I think the best rationale for notebooks is that if they didn't exist, you would want to invent them anyways. And Imagineer certainly would, because you would be really struggling with how to get your words and your code together in the same file and to be able to keep track of them together and keep them in sync. However, after having taught notebooks for many, many years, I've realized that there's a lot more complexities under the hood than I initially let on. So part of it was my naivete. I didn't have the vocabulary to be able to talk about these different elements. And I also wasn't completely aware of them because I was in my kind of bubble at the time of just using our Markdown. But now that I've been a product manager and I've gotten to know a lot of different notebook tools, I can now see that there's a lot of different facets that a user needs to consider when they're picking up a new tool, and that tool makers need to think about if they're thinking about developing a new framework or a new platform. There's a lot of different moving pieces that have to do with notebooks. And I think this is part of what can also just lead to a really heterogeneous landscape in terms of user experiences. So the first element is an authoring framework. And this is how you write your code and your text. So we talked about a notebook has code and text, readable by humans, writable by humans. And how you write that code and text is your authoring framework. So Jupyter is one, Quarto is one that I've mentioned, and Observable is one. Then you've got language engines and Markdown flavors. Now, these are two choices that are usually made for you by the authoring framework. So the authoring framework tends to give you some options. And I'll show you some examples in a second of what I mean. But usually these are not things that you can just choose out of thin air. They're things that are chosen for you, but you have options that are available to you from your authoring framework. But these define what you write. Oftentimes, you'll have a file format, and this is the thing that you save locally on your computer and the thing that you would version control. You'll also have a local editor. This is where you write locally. So this usually involves taking a source file and having some kind of software that gives you a user interface, a UI, for being able to write. You also could have a platform editor. Increasingly, this is a really exciting space with working with notebooks. So this is really where like the magic happens in my mind. This is where you can have sharing plus a user interface plus a whole lot of other things. There's some really interesting Google Docs-like experiences. There's some great experiences with being able to kind of scaffold templating and pipelines of documents. So the platform editor is really kind of just scratching the surface at sharing and a user interface. So I thought I'd put together some examples to show how all of those different choices can lead to these different experiences. So for example, here in this first row, we have a Jupyter authoring framework. You can see that there's 3 language engines that are associated with it. You've got a few Markdown flavors, 1 file format that's supported, a local editor, and these are just some of the options. These are not meant to be comprehensive in any way. And then there's some platform options like Jupyter Hub, Google Colab, Notable, things like that. Quarto is another authoring framework that I've talked about so far, and that one has several different language engine choices. You'll see that Observable JS is one of them, as is Python, R, and Julia. It has 1 Markdown flavor-ish. All of these cells could really kind of have asterisks next to them, but I'm trying to simplify. So usually the Markdown flavor is Pandoc, and I have a little plus there because Quarto adds a lot of stuff on top of Pandoc's Markdown. And you can see the file formats, local editor, platform editor. our Markdown, which is really kind of the first generation of what Corto is turning into. So Corto is kind of taking the learnings that came out from years of development of our Markdown and our Markdown ecosystem. And Corto is kind of the second generation of that, but I'm leaving our Markdown in here for posterity. So you can see that it was mainly designed for R, although you could, asterisk there, use over 62 knitted language engines. And then finally, Observable. So Observable is an authoring framework. The language engine is JavaScript-ish. You've got a Markdown flavor that's GitHub and file format supported JavaScript. There's no local editor, but you do have your platform, which is also observable. And just to clarify, since there is some disagreement about what the word notebook still means, so a notebook by any other name, Jupyter notebooks are notebooks, Jupyter is the product, observable notebooks are notebooks, observable is the product. Corto and our Markdown notebooks are a little bit different. They're plain text documents, and they have two modes. One is notebook mode. So some people, when they hear me talking about notebooks and talking about our Markdown, they think that I mean the notebook mode. But in this talk, I'm really talking more about notebooks in general, because I feel that calling something in our Markdown document doesn't quite emphasize the fact that it's an executable computational document. So I'm going to call them all notebooks, even though I'm not talking about the notebook mode here. I typically would use my R Markdown documents in batch mode locally. But just to clarify for those R users out there who are saying, Alison, the notebook mode stinks. You're correct. The notebook mode stinks, but I'm still going to call them notebooks here. So part of the inspiration for this talk for me today came from a Twitter thread that I saw about Walt Disney World. And so that's why I ended up calling it the happiest notebooks on earth. So this was a great Twitter thread that talked about the 4 key principles around kind of great storytelling and how Walt Disney World sets up its guests so that they can have the best experience when they're there. And when I read through this thread, I thought, wow, there's so many parallels between the things that they talk about, these principles, and the things that I think are actually really important for notebook users and the kinds of tooling that I want notebook users to have access to. So in this talk, I'll kind of walk you through those 4 key principles and how they dovetail with some of the features that are currently available in notebook authoring frameworks and ones that I'd love to see available in authoring frameworks based on my own experiences teaching, using, and hearing a lot from users. I used to joke that I was a pretty good complaint box. So I've heard a lot of feature requests and a lot of pain points. So the first principle is called suspended reality. The second one is multisensory experience. Third is details matter. And the fourth is make it shareable. So principle number 1, suspended reality. This is a really interesting factoid about Walt Disney World that I did not know. So I guess Walt Disney found it jarring to see characters out of place around the Magic Kingdom. It breaks the suspension of reality. And so they built this thing called the Utilidor system, which is a system of some of the world's largest utility tunnels underneath the park. And this is how all of the characters go from one place to another. This is where they take their breaks. This is how they move around the kingdom. They don't walk around, so you're not going to see Mickey Mouse on a little break, sitting outside taking a rest. They go down to the Utilidor system, and that's how they move around. So it's an intricate web of tunnels that lie underneath the park, and they enable the characters to navigate without ever appearing out of world or duplicative. And I think this is a perfect analogy for what a really, really positive, wonderful notebook experience is for an author. So I think of this as notebook utilidors. So in my mind, the best utilidors aren't as much magic as they are plain text logic. So if I'm able to do any of these things, I'd like to be able to do it in plain text, please, even if I could do it in some kind of UI way. So the first one is configuration settings. So this is pretty common among notebook tools, especially. You can usually have a YAML, which is a key value set of pairs that helps you define the metadata. So if you remember that example Corto document that I shared, it had a name and a date. The key was on the left and the value was on the right. And these are ways that you can kind of structure your documents, but also add metadata to kind of keep them organized and use that metadata throughout your workflows. So I find using configuration settings extremely helpful, and I love being able to define my own variables for this. This has really changed the way that I use notebooks. And I think a lot of users in our Markdown system especially really enjoy being able to define their own variables and then be able to make conditional code that runs based on the values of those variables. Another thing that I think can kind of make this tunnel system work underneath the user experience of the readers who are going to be reading your notebook is to be able to outsource a script or a document. So a lot of times we'll build up these really intricate, awful, gnarly scripts for being able to get the data into a form that you could actually visualize or make a table of, something like that. And so once you've built that up, the nature of notebooks is that they're so iterative that you'd like to kind of move it out. You'd like to keep your notebook kind of pure once you've got the code working and be able to outsource it. So being able to just say like, hey, now here's the script over here. This is the data wrangling script. That can really make a document a lot cleaner and a lot easier to maintain for the author. Also being able to reuse code chunks in different places. I've linked here to some documents that you can see about how the Nidar engine allows us to do that in our Markdown ecosystem and the Quarto ecosystem. And again, conditional evaluation of code. So being able to say, okay, this code only runs when the value in my metadata is this. So maybe I set my reader up to be my boss versus my my intern, and maybe there's different code that runs or different things that I show them based on who they are. This is a really powerful tool for making my notebook work for me. And if you click on the example link, that actually takes you to a paper that I wrote with Alison Horst and Kristen Gorman on the Palmer Penguins data set. I'm one of the co-authors on that package. And so we recently published a paper in the R Journal that actually used a lot of these tools for building utilitors around our code to be able to make that paper happen. So check it out and you'll see a lot of the examples of things that I just talked about. The principle number 2, multi-sensory experience. This one is hugely important to me because I'm a big believer in touch and vision when you're exploring a new document. At Walt Disney World, the multi-sensory experience actually has to do with smell. So Disney built this system called the Smellitizer system. It's a system that blows air across scented substances to make the air smell a certain ideally good way. And the idea is that these scents provide a more immersive and memorable experience for the guests. Now, I'm not telling you to make your notebook smell. In fact, I'm hoping that it won't. But I do think that there are certain notebook smells, and in coding, sometimes there's this idea of code smells and feels. So there's this idea that like by looking at somebody's code, you kind of get a sense of the smell of it, and maybe you kind of get the sense that something's not quite right there, or that it needs to be refactored, or that it's not well organized, something like that. I think notebooks have the exact same thing. So I think notebooks can have a smell. So I want you to do this little thought experiment with me. Have you ever seen a notebook with no meaningful headings, or worse, maybe cute or very peppy ones? I'm definitely guilty of this. But headings, you only have so much space to show your users how to get around. Use your headings wisely. No meaningful heading hierarchy. So a lot of times I'll see deeply nested headings or randomly sort of placed headings that don't really make much sense to me as a reader, and it makes it more difficult for me to navigate that file. No navigation in general. I find a table of contents extremely helpful for this. No description of the data. I am definitely guilty of this. I have taught classes before where I didn't throw in a description of the data and my students essentially revolted. So it's really, really important, no matter what you think of the complexity of the data set, it's really important to describe it for people if you're basing anything off of that data. And then there's also this idea of like no logical order to a notebook. So there's definitely a beginning, a middle, and end for the person who's hopping into it and reading your notebook. So you want to give them that. There's definitely some notebooks that I've jumped into where I couldn't tell heads or tails from where I was supposed to start or end and what I was supposed to get out of it. So these are kind of notebook smells that I think definitely lose the reader. And notebooks do have a scent. And this is actually related to the idea in user research of information scent. So information scent usually is applied to thinking about web pages. So here's a quote from the NN group, the Nielsen-Norman group. Information foraging explains how users behave on the web and why they click certain links and not others. Information scent can be used to analyze how people assess a link in the page context surrounding the link to judge what's on the other end of the link. And I think this has a lot to do with how a user forages for information in your notebooks. They're looking around, they're trying to figure out, where am I supposed to click? What am I supposed to look at next? And sometimes the notebook isn't structured in a way that helps that person forage for the information that they need. So here are some things that I think can make your notebook smell like a good notebook. Adding a clickable table of contents, and I hope your tool provides that. I put a little push pin there because I really love having a sticky table of contents, maybe one that's to the left or to the right, so that as you're exploring, if you get pretty far down, you can get right back up to the intro really quickly. Add useful headings, really focus on what those headings should be, and ideally you'd have a tool that would help you write useful headings. I typically aim for H2 and H3 levels only in my markdown headings. I think anything more deeply nested than that is really hard to keep track of as a reader, but also as an author. I also really encourage people to use sentence case for their headings. It's known to be easier on readers. I tend to also limit myself to 5 or 6 H2 sections max if you can. And this kind of goes back to the utilidors concept. If you have flexibility to be able to kind of take your code from up here and kind of push it down into a utilidor down there and maybe outsource it to somewhere else or have it run, but not have it be clogging up your notebook environment, that's actually a really ideal setup. Have topic sentences. This can help your reader because everybody is skimming and not reading. Describing your data, I usually use the 5 W's, 1 H, so who, what, when, where, why, and how. And try to lay things out in a logical order. And I know that this is easier said than done, but I have 2 tips. One is to think about what's the beginning, middle, and end, and structure it that way. That's a really nice framework for somebody to be able to figure out what you're trying to communicate to them. And then the piece of advice that I always give my students and people who are working with me who are developing notebooks is that the logical order is often not times the chronological order. So if you start off by saying, this is the first thing I did, here's the second thing I did, or first this happened, then we did this, that's usually like the path that is most confusing. A logical order usually assumes that you need to take a few steps back and say, where did we end up? And then now, how can we reconstruct the path to make sure that the person that's reading this figures out how we got there? And yes, you may have had many, many forking paths along the way, but the point is to prune those down and make it easier for the reader. So principle number 3, details matter. So Walt Disney definitely understood that when a single detail is wrong, you lose the whole experience. And so their solution was to reduce the chances of losing the magic. For example, you cannot buy gum in the park. It's an official no-fly zone, so there's no noise pollution. And you're always within 30 steps of a trash can. So that keeps things clean and nice. And I think something similar for notebooks should be happening, especially on the tool creator side or on the framework creator side. I think easy things should be easy. And these are things that I think are easy from my experience. They may not always be easy with whatever framework you're using. I think styling should be easy. Styling is an easy win for users, and it's something that everybody wants. Authors want to be able to use fonts and colors. Sometimes they have to for their own style brand guidelines. Sometimes they need to for accessibility reasons. Maybe there's accessibility guidelines that they need to adhere to that are more strict than things that you have cared about in the past. But readers also want fonts and colors too. Everyone wants this. So I feel like this is an easy win to give people fonts and colors to customize. Easy layouts. This was one of the top requests that we consistently got from users in the R Markdown ecosystem. And basically the solution is to give people the ability to make basic grids with rows and columns. In many cases, most people were happy with 2 side-by-side columns so that you could have either text and a picture next to each other or text and code next to each other. And pretty happy with 50-50 split there, but a lot of people would also like to have the option of having a narrow side and a wide side, a narrow column and a wide column, that kind of thing. Being able to lay things out flexibly in that way can really improve the user experience and the reader experience. Easy show and hide code and results in the output. This is something that I've really felt is lacking in other tools that I've used since using R Markdown. But the ability to be able to say, hey, these code chunks aren't really relevant here, or they don't really need to be shown. I'm going to kind of mute them, turn them off, hide them. An easy run from the top mode, so the ability to, with one button, click from the top and run everything in a fresh environment that's not all clogged up by my local work. And an easy way to skip or freeze a code chunk. So this is especially useful if we're thinking about the use case for getting help with troubleshooting or doing your own troubleshooting, is being able to say, like, stop right here. This is the error that I got, and I need to be able to share it with somebody. So being able to skip or freeze that kind of thing is really helpful. Now, if easy things are easy, hard things should also be possible. Version control is really important. And this has to do with being able to export and download source files. So being able to have a file that you can actually know that's where your work went into, this gives people the confidence to be able to use your tool. It means they actually trust your tool more because they're able to take it on their own. They're able to feel like it's more portable because they have spent a lot of time and energy making that file what it is today. And if it's just trapped on your platform, that's a really difficult place to be psychologically if you've put a lot of time and effort into that. I know this as a previous SaaS user. It's also nice to be able to give people the flexibility to save all plots as image files. So something that's super helpful if you're ever looking at different kinds of plots or looking at different color palettes, and you need to be able to compare and contrast them really quickly, especially with somebody else. It's sort of like the eye chart test where you're like, do you like this one or this one? Do you like this one or this one? Do you like this scatter plot or this scatter plot? These are really hard things to compare when you're scrolling linearly through a notebook. So they're really nice to be able to put either side by side if you give people that layout, or just to be able to let them all plop into a directory so they can thumb through them on their own. And especially if they have only offline access to be able to do that. Being able to extract all of my code into a script is also a really nice feature. This is something that's in the R Markdown ecosystem, and this is something that I've heard from a number of users was extremely helpful. We have this ability to be able to say, okay, there's this notebook, it has all this narrative, but like, ignore all the blah, blah, blah. I just want all the code. I want to be able to get it all out. There's the ability in R Markdown and in Quarto documents to be able to purl a document and be able to pull out all of the code and nothing else. And this is really freeing for our users because it makes them feel like the time and effort they put into the code is not wasted because it's stuck in that notebook. Also, caring about reproducible environments. This is something where most people haven't felt this pain before, and unless you're like, already a software developer, so you're really conscious of it. So it's really nice to go ahead and think through how you would manage and do that in a nice, healthy way so that you can help your users fall into the pit of success, because they will need it at some point if they're working with other people. So principle number 4, make it shareable. Now this sounds easy, but it's definitely another one that's easier said than done. We've made things a lot more shareable in terms of HTML outputs. Those are pretty easy to share nowadays, but some of the other stuff is a little bit harder. In Walt Disney World, they actually make it so that you can't take a bad picture. So the concrete is dyed red, a brainchild of Disney and Kodak, and that creates more vivid photos. So not the like grungy kind of gray concrete, but bright red. It also makes the green grass appear greener. And Cinderella's castle faces south, meaning the sun is never directly behind it. It's almost impossible to take a bad photo of yourself in front of that castle. So they really make it not just something that is easy to share, but something that you want to share. Now, I think a notebook is actually a snapshot in time. This is my definition of a notebook, because one of my friends, TJ Marr, tweeted at me, what the heck is a notebook supposed to be anyway? And my answer is it's a snapshot of a data-based creative process that leads you somewhere new and somewhere next. And I think a notebook is that exactly. And I know in my life, typically I've only shared the notebooks that are perfect. So when they're final, if I was working on it, then I would hone it, I would curate it and make it perfect, and then I would share it. I don't know that that's the healthiest thing to do though. I think it would be really, really helpful for tool developers and framework developers to think about making it easier for people to be able to share outtakes, bloopers, and the in-between things. So being able to quickly share incomplete thoughts, even with errors in code. So don't make a gate that means that my code has to run in order for me to be able to publish it or share it. Be able to time travel to different versions with the output so that I can compare this week's version to last week's version. Maybe I changed some code and the plot looks very different. I need to be able to go back and forth and do that. I would typically do this manually when I was working with our Markdown. I would just save the different versions of my output files with the dates, but that served me well. It seems like there's a better way. Also being able to stash bits of code out of sight with utilidors. So if I need to quickly share something with my boss or my manager or an intern, being able to say like, here's all this other stuff, ignore all that stuff, here's where you should look. And that brings me to annotate easily what to look at and what not to look at. I would love the ability to be able to mark different code chunks with sort of like a red, yellow, green light to be able to say like, these are ones that you should look at. These are ones that are like work in progress, don't worry about, but these are ones that are totally ready for other people's eyes. I think that would really make it easier for people to collaborate more effectively and feel a little bit less scared about sharing those in-between things. Because how many times have we shared some in-between thing and then you've gotten feedback that, oh, this thought isn't complete or this code won't work. And you're like, right. Yeah, I know. I was trying to not wait until it was perfect to share with you. And that's hard for me. So I always think of this quote from Mary Poppins: "We're on the brink of adventure, children. Don't spoil it with questions." And I think actually with notebooks, that's exactly what you want to do. I think you want to be able to ask questions and get answers earlier rather than later and not wait until the final moments to be able to share your stuff. So in summary, I think notebooks are incredibly useful. They may be my emotional support notebooks because I obviously have a lot, but I have a few reasons why I think notebooks are very useful. I think they're useful to record my code and thought process, useful to get feedback from others, useful to get help getting unstuck, useful to help others get unstuck, useful to teach with. I taught with them for years, useful to learn with. My students always loved them. Useful to collaborate with. I've written several research papers and worked on several projects with code, including website projects with other people using notebooks. Useful to publish work for my career. I think in some ways, some of my published work has actually changed my career in meaningful ways. Useful to debug with. See the Reprex package in R, stands for reproducible examples. And useful to iterate on code with. So thank you for joining me today. In summary, I talked about 4 key principles that I think notebook users should be able to follow with the tools that we make for them. Those were suspended reality, using utilidors to save their sanity in their code, a multi-sensory experience, being able to have good navigation and organizational tools to make notebooks smell better to everyone. Details matter. Easy things should be easy and hard things should be possible. And making it shareable, especially things that don't work and things that aren't done. So thank you for your time. I really appreciate it. And I look forward to hearing what questions you have.
Hi, Alison.
Can you hear me okay?
Yes, hear you loud and clear.
Awesome. Hi, nice to see you.
Nice to see you. Nice to see you again. It's been a month.
Yeah, it's been a while now.
That presentation was amazing. People love your tips. They love the how you humanize the love story of notebooks. So it's cool.
I'm obviously a fan. It comes from a place of love, right?
Okay,
Only when you truly love something can you critique it.
That's true. Awesome. Let's jump into a couple questions from the community. Someone, Martin has asked, like, do you have a blog post on all of this? And we can share later.
I should make a notebook of my ideas for notebooks.
Yes.
Yeah, that should be forthcoming. I'll leave a teaser there.
Awesome. Next question. Wait, no, yeah, cool.
It popped up and then it went away.
Yeah, all good. Someone says that, I think it's Lena, said, I agree with being able to export content as a script. What about importing the script? Thoughts on that?
Yeah, I actually I think that is incredibly important too, and that for me fell under like the utilitors aspect because in the ecosystem that I'm used to working in, you're going through different phases in notebook development, right? So at first you're just kind of like trying to get it into a place where you can like grab onto it, like you want to be able to have rows and columns that make sense and give you kind of handlebars so that you can move things around and plot it. And so I think, when you're in that stage, you might be, building up some pretty gnarly scripts. And then once you're done with that, maybe your notebook evolves into more of like, okay, now I'm moving on to the next phase, but I can still use the same notebook. And it's nice to be able to plop all that ugly wrangling code now into a like, okay, I know this works and this gets me to the place where I need the notebook now to start. And so I think you're kind of just like constantly shifting your baseline. And scripts I think are really nice for then saying like, okay, after I've done the iterative interactive kind of troubleshooting here and code writing, then I can outsource it. So for me, it's like kind of building that tunnel underneath a little bit more. Like now the notebook is the ride, right? And then
Yeah.
you've got like the stuff underneath that nobody else needs to see. Like you can, if you understand code, it's all available. The source is there, but nobody needs to see that to consume it. So I definitely think that's really important.
Awesome. Agreed and agreed. Jump to Aaron questions. Let me see. Let me think about this. Well, thank you for
Which one are
including
you at?
observable.
Oh yeah.
Look at Aaron's question. So, thank
Oh,
you for including observable in your notebook list. We appreciate that. Observable insight. And Aaron was just giving us some love. He's just saying that there's a lot of those metrics and those practices are in
mm-hmm.
observable. I'm just curious, like. Just
Yeah.
follow up with the next question of Martin is like, we would love it if you would have, your list of your blog posts on Observable. So, let us know if you do
Yeah.
decide to do that. We're here to support you.
Thank you. Thank you. I appreciate that.
Yeah.
I
All
think that
right.
sounds like
So
an awesome, fun project.
I agree. We agree. I agree. We agree. Yeah. Let's jump into one more question from the community. It says, all the presentations looks cool. Um, it uses Jupyter to do visualization. Is it correct that Observable is a platform to host notebooks that can be written in Java on JavaScript? Or why someone use Observable over Jupyter notebooks? I'm gonna be a little biased over that, because we have amazing notebooks. Mike shared earlier in the presentation all the tips and tricks you can do on Observable. I'm curious about your opinion.
Yeah. I mean, I think Mike's answer actually to is JavaScript going to replace R, Python, these vectorized languages, because R and Python obviously have their own kind of notebook ecosystems in the Jupyter ecosystem, and for R in the R Markdown / Quarto ecosystem. And I think Mike's absolutely right that it's not like an or statement. I think it's going to be an and I think it really depends on where you are and the different processes that you're in, and especially for me, who you're having to collaborate with. Who needs to be able to consume it, who's the final user of this, who needs to be able to read it, understand it, and who needs to be able to join me in working on it. So I think Observable seems like a place where a lot of people are especially enjoying like the data visualization experience, and especially being able to really quickly and easily make like interactive visualizations. And that is something where if you're in a Jupyter notebook or a Quarto notebook or any of those things, sometimes those interactive visualizations can really be tricky. There's a lot of dependencies, JavaScript dependencies, and so when you go to deploy those, a lot of times I've run into some severe headaches trying to get that. So I think different tools for different things, and it really depends on who you're trying to optimize for.
Awesome. One more question, and thank you. Great answer. We're not, no, I'm gonna say, send us the coffee bill in the mail. Send the coffee bill in the mail, but great answer.
All those poor R developers that make those JavaScript dependencies. They're just.
Awesome. The last question. Do you have thoughts on keeping live notebooks happy? Those that depend on APIs for data, snapshots of data.
I think this is actually really hard, and this is something that I've kind of gone back and forth on with myself. I think you get to a certain point where a notebook is kind of just like a document version of a dashboard, where you're trying to kind of pull from automated data source and kind of run at like, some kind of recurring schedule or something like that. My own use case for notebooks hasn't been with that kind of data, so I don't know that I have any great tips for that. Although I do think that it's nice to be able to, like, in terms of features, things that you can build in, it's nice to be able to have ways of checking those things, right? Feeling like, if it's running and it's not a happy one, like, how do you take its temp? Like, how do you figure that out rather than just waking up and getting that horrible recurring email that, like, hey, this thing has failed and it won't render. And, your report that comes out weekly to your boss, didn't get sent and they noticed right away. Something like that. I feel like those things are really helpful. But I do think that notebooks in general are a little bit best suited, I think, to being based on snapshots of data, because I feel like they're snapshots in your thought process too. I feel like those things match with each other. And I think we could let up on notebooks a little bit for making them feel like they need to keep up with a live data source. That's a little tricky.
Yeah, agreed. Well, Alison, great talk, great answers.
Thank you.
We appreciate you. Thank you for your presentation. Thanks for joining us.
Thank you for the invite. This has been a great conference. I love being a part of it. Thank you.
Yep. Cool. Awesome. Great. Okay. Let's take a deep breath. Count of 3. 1, 2, 3. We're going to transition a little bit. The great Bruce Lee said, empty your mind, be formless, shapeless like water. You put water in a cup, it becomes a cup. But in this case, this may sound cheesy, I don't know, but we're going to run with it. If you put water in a notebook, it's going to become a data visualization. So next up, we'd like to bring a presentation from Olivia. You talk about Waterlines.
Hi everyone, my name's Olivia Vane. I'm a data visualization designer and JavaScript engineer based in London. I work at the Economist newspaper in their data journalism team where I build interactives. But today, I'm going to be talking about a personal project I did last year on Observable, all about drawing waterlines. Waterlines is an old technique for showing water in maps, these radiating blue ripples. I'm going to talk about a collection of notebooks I made showing how you can recreate this effect with code. It's a project spanning design, history, coding, and maths. I'm going to walk you through what's in each notebook. We're going to have a look at some beautiful maps, and I'm going to share some reflections I have working on this project. This isn't going to be a technical walkthrough, but if you do want to get into the code, I encourage you to dig into the notebooks. It's all there. Before I get started, I wanted to quickly share some background about me. I make interactive data graphics at The Economist. We cover all kinds of topics in global current affairs. I thought you might enjoy to see some of my data explorations and prototypes on Observable, which make their way into the paper in a more polished form. This one on the slide is for our Glass Ceiling Index, which is an annual measure of the role and influence of women in the workplace in various countries. And I was exploring how we might show the change in ranking over the past few years for different countries. You can see on the right the final graphic we settled on. Or more recently, for a long read about how US states are diverging on policy ideology, we plotted states horizontally by voting record and vertically by policy ideology, animated in this scroller. You can see the states drifting apart over time as they become more ideologically polarized. But it started out with some notebook exploration of the data using inputs that you can see there on the right. Before I was working in journalism, though, my background is actually in the digital humanities. I worked on visualizing large cultural data sets like digitized collections of paintings, photographs, artifacts, maps, and newspapers. Things that not everyone immediately thinks of as data sets, but that you can analyze and explore with data methods too. And the project I'm talking about today definitely has an historical element. So, waterlines. Where did this all begin? It all started with this image. From early on in the coronavirus pandemic, the news was filled with data graphics describing infections, deaths, and later vaccinations. Graphs and maps were everywhere. But this also stimulated people to dig up examples of how pandemics in the past have been visually described. This was one of the images shared online. It's a French map. It was made in 1884, and it shows the status of a cholera pandemic raging in Europe at the time. The spread of cholera is shown in red. It's got arrow paths. I love that the arrows have feather flights, like a bow and arrow, and the red dots look almost like a spreading rash. But what really caught my attention was those amazing ripples radiating out from the land. I just thought, wow, I hadn't seen this kind of design before, and it gives the image such a force. And this brings up 2 points that I'm going to return to later. Firstly, that historical materials can be an amazing source of inspiration. Data graphics have such a long, rich history, and examples like this one can spark ideas and suggest different ways of doing things. The other point is that what really drew me to this image was the aesthetic effect. It seems like a really obvious point. Aesthetics are powerful in data visualization, but I think especially when you're first starting out in data graphics, there's such a lot of emphasis on graphics that are efficient, that are minimal, that are functional. And of course, these qualities are very valuable, but you can almost forget about beauty or visual impact. And in a world where mountains of new images are being shared online every day, an image that really grabs people is a powerful thing. That third bullet point I'm going to come to later. I do think these so-called waterlines are very beautiful. They were a style of drawing water on maps that was very popular in Western maps in the 19th century. This image here is from an Ordnance Survey map made in 1896, and it shows the Isles of Scilly in Britain. That's Scilly, S-C-I-L-L-Y, not S-I-L-L-Y. They're off the southwest coast of Great Britain. A lot of the graphics that feature in these notebooks are of Britain or Ireland or other islands off the British coast, of which there are many. Very handy, coming from a very islandy geography, making these notebooks. So this project really started with a curiosity. Can you draw waterlines with code? Can you add them to interactive maps on the web? And since the whole idea of them is that they look like moving water, like ripples or waves, can you make them move with code, like real water? I made 4 notebooks exploring the topic, with lots of code examples and graphics. For notebook number 1, I looked at all the different ways that you can draw water in a map. Waterlines isn't the only style you'll find looking at history. What other shapes and textures do we see looking back? I collected together lots of examples from historical maps, and it's such a diversity. Some of these images are from maps digitized by libraries. Some are actually from map sellers online. There's everything here from mountainous waves, snaking squiggles, stripy zigzags, and I'm sure there's lots more that I didn't get to. Something I really love in Observable is that you can just write some custom HTML to display content exactly as you want, incredibly easily as part of the notebook. I just customized the display of these images so it's a gallery. You can mouse over and see the full map, and all of the tiles are hyperlinked to where they came from. Most of the examples that I found are Western maps, but I was really keen to see if I could dig up a wider selection of examples from different cartographic traditions too. I found a few, though I'm sure there are lots more someone more expert than me could produce. This is a map showing China at the height of the Qing dynasty, where the land, rather than the sea, is blue. All the waves line up in orderly ridges. This one is a reconstruction of a much older map, a world map compiled by the Arab geographer Muhammad al-Idrisi in 1154, commissioned by King Roger II of Sicily. You might find the geography a bit more familiar flipping this upside down. The sea almost looks like it's knitted. I think there's such a range of possible inspiration here if people want to get ideas for unusual textures to add to their map designs. In the second notebook, I focus in on waterlines and show how you can draw them using JavaScript. There are two different approaches I step through in this notebook. Either you can do it by drawing strokes or outlines on the shape. You draw strokes bigger and bigger on your land shape and clip out the interiors, just leaving the radiating ripples. Or the second method, you can make new path data using a buffer operation. So you generate new geographic data describing new paths offset further and further out from the coast. And there are pros and cons to each approach. This image, which is generated in the notebook, you'll notice is a mashup of that earlier map I showed of the Isles of Scilly from 1896, with the blue water lines drawn with code on top. You can make some crazy things, playing around with the curve settings, or if you choose a really distorting map projection, your water lines end up splaying out as well. Returning to my earlier slide, you could characterize this collection of notebooks as a computational essay, a web document exploring ideas which mixes text, images, custom HTML, live code, and input controls so a reader can play with the processes as part of the explanation. You can have all these kinds of elements together in the same place. Certainly, there are examples of computational essays from before Observable, and you can make them elsewhere, but it becomes a lot easier and quicker in the notebook format. It's one of the things I really like about working in notebooks. You can have everything in the same place. And if you're exploring or explaining graphical ideas, that's really amazing. In the final two notebooks, I show how you can animate waterlines so that they move like real water. Either using vector graphics, this requires morphing between polygon shapes. You can see the animation running here. This is the vector graphics one. And we have to delve into why transitioning between SVG paths is more complicated than expected. This isn't the desirable result. In the very last notebook, I make a waterline animation with raster graphics. In this one, I'm generating each animation frame by tweaking the waterline positions, frame by frame. Again, this image is a mix of old and new. We're actually in the Scottish Outer Hebrides. The grayscale land is from another late 19th century Ordnance Survey map. So that is the Waterlines collection of notebooks. If you want to get into the code and reuse any of this, do go check out the notebooks. It's really fun to see where other people pick this up, like the couple of examples on the slide. I want to leave you with a few closing thoughts, which really are reflections I have from the project. Get inspired by history. The spark for this project was a beautiful old French map. One of the things I really enjoyed about working on this was not just looking at lots of amazing old map images, but also working historical imagery into the graphics I was making. There are so many attractive and inventive historical data visualizations and maps, and it can be a great source of inspiration for new work. If you're interested in that kind of thing, the David Rumsey map collection is a great place to start. It's an amazing resource, and it's not just maps on there. There's lots of data visualizations more generally, and lots of other libraries have materials digitized online too. Don't forget about the power of aesthetics. Waterlines are essentially decoration. When these maps were being made in the 19th century, they were printed using copperplate. So you had to engrave all of those lines by hand on a metal plate for the printing. The engravers who could make waterlines were more expensive because waterlines are really hard to engrave well. They're so delicate. So map makers, like the Ordnance Survey in Britain, were paying over and above for this decoration, which tells us they really thought it was worth it. We need effective, functional information graphics, but the look and feel of an image is important too. Don't forget that. Visuals that people find really compelling can make an audience stop and take notice. And finally, I'd love to see more computational essays. One of the things I really enjoyed about making these notebooks was I could explore and explain ideas with text knitted together with live code, images, input controls, everything together in the same place. If you want to explore graphical ideas, it's pretty ideal. And there are a growing number of computational essays I've seen on the platform, like this design history notebook about baseline grids and the Bauhaus from Gabriele Gianadoli. Just let that run a little bit longer. Or this recent one about Euclidean rhythms from Torben Jansen. Observable even has a whole collection of explorables. Computational essays existed before Observable, and you can make them with other tools, but they are so easy to create with notebooks. I really hope to see more. That brings me to the end of the talk. Thank you for listening.
Awesome. Olivia, that was amazing. That was awesome. And I do want to say thank you. Just to say thank you. And thank you also for being one of our ambassadors. That the work you did is just inspirational and people love it.
Well, thank you for having me.
You're welcome. I'm curious, if you were to start that today, like start from scratch today, based on what you've done before, what you just showed, would you do anything differently?
Oh, I think that I probably would start doing it the raster graphics way first. I think probably a lot of us who sort of started getting into data graphics through learning D3 and were sort of learning JavaScript through D3, that SVG vector graphics is still often the kind of the first tool that I reach for. And it's not always the sort of most suitable one for the task. Sometimes raster is easier. So definitely, I think after making these, like I wish I started, I hadn't started with the SVG, but you learn these lessons.
True. Awesome. Let's jump into some questions from the community right quick. And one question is, were waterlines ever used to indicate water depth as well as, or were they only aesthetical?
There definitely are maps which show you the water depth. It's, I'm probably going to say this wrong, bathymetric maps showing you the depth. And I mean, it all kind of looks like contours. They look a bit similar, but the water lines that this project has all been about have been more kind of the decorative aesthetic kind. And what's really nice is that there are all of these different variables that you can tweak, which slightly change how they end up looking. So, how far apart they are, or how thick you draw them, and whether the thickness of the lines kind of tapers out, or they kind of fade out as they get further away. So there's a lot of kind of levers that you can pull to make these water lines look quite different. But sort of this project, I was looking more at the kind of decorative stuff.
Got it. Thank you. Another question from the community is: they would love to learn more about your humanitarian background, and how does that inform your data work now?
So I sort of started out in data visualization through doing a PhD in data visualization design for cultural heritage data sets, so mainly kind of digitized museum collections. So loads of museums have been digitizing their collections. They create these enormous data sets, and then it's then very difficult to make sense of it because they have huge holdings. And so my PhD was really focusing on designing timelines of these big cultural heritage data sets, and I was interested in what are the kinds of historical narratives that you can see when you create data visualizations of these kinds of data sets. But yeah, a lot of the things I was making was kind of exhibition focused. It was tools for the general public to explore museum collections. So yeah, a lot of it was it was pulling out stories. It was presenting to the public, which is sort of very helpful now. Now that I work as a data journalist, it's kind of similar things. And then before I was working at The Economist, I worked on a really big digital humanities research project, which was happening between the British Library and the Alan Turing Institute in the UK, which is our national data science and AI research institute. And that was looking at really large kind of industrial revolution data sets, and I ended up looking at a lot of maps. So it was really, I was sort of doing lots of work with historical maps at work, and I think it was from sort of seeing all of these materials, it it was from there I probably had this sort of inspiration of wanting to go off and create these notebooks.
Awesome. Thanks for sharing your story. Let's say two more questions. Does the historical record on waterlines suggest they were made to communicate the navigators that the shorelines were shallower than the open sea?
So there's very, very little historical research about them. I think basically because they're decorative, and so historians just haven't really been interested in them. So I found there was maybe 2 papers that I found, but basically no one has wanted to write about them because they're decorative. So the communicating about shallowness, I didn't see anything about that. I think they are more a kind of just a visual communication, that this is ripples and water, and if you're not using color in your map, then it's a really kind of obvious way to mark out which bit is the water.
Got it. Thank you. All right, let's jump to the last question. It's from Misha. It says, absolutely fascinating what you showed. So I wonder what ideas you may have had about taking the work further, perhaps into the economist world. What about showing water flows? Let's say looking at people's reaction to extreme weather events this way.
We do a lot of mapping. We do. I haven't yet had the opportunity to use this Waterlines code. There was a project that we did, which was a historical focused one with maps, and we did consider reusing this, which would have been exciting, but it didn't work out in the end. But we'll see. Yeah, but perhaps there will be an opportunity where I can include it, which would be really fun.
Awesome. Well, let me see. Let me check. Thank you. And hopefully you continue to do that work. All right, great. Just checking on something right quick. I just want to say thank you again. Your presentation, your Waterlines was inspiring. I remember when you first shared it on Twitter, your notebooks on Observable, and everybody was blown away. So thank you for presenting. Thank you for being an ambassador. Thank you for participating in the community. And if you have time, I'm not sure if you do, there's a couple more questions we didn't get to. So if you have time, maybe you can chime in on the other end and ask some questions. And really appreciate you being at Observable Insight today.
Oh, thank you.
All right. Awesome. Ooh, you all coming in great with great questions. I'm like, well, that's a great question. That's a great question. That's a great question. Hopefully, Olivia can jump in over there, ask some questions over in the chat. But moving along, we have seen, we have Welcome for Melanie. We've had observable tips from Mike Bostock. We've seen the love of notebooks. We had a visualization on water. Now we're going to talk about some advanced reporting from our very own Ian Johnson at Observable, a data viz developer. And if you don't know, Ian is awesome. So Ian, the stage is yours.
All right, thanks, Wayne. I'm excited to do this session. I'm going to see how much of a little dashboard we can make live from scratch in the next 30 minutes. Part of what I love about using Observable is just how quickly you can develop and do data analysis. So I think this is going to be some fun. Before I get started, I'm showing this notebook on the screen here. It's pretty much empty. I think we could put it in the chat so it's live. You know, you can open it in your browser, follow along as I make edits to it. There is one link in here, which is basically a tutorial series that covers most of what I'm going to show. So if you know, spoiler alert, if you go here, you'll see kind of what we're going to try to build. So if you want to kind of be surprised and follow along, that may be more fun. However, if I go too fast and you want to, you know, pick apart what's happening, you can always come back to this series and see the details. And we're going to use a data set, this Google merchandise sales data, which we've prepared from, it's open data from Google Analytics. It's basically the real sales data from the Google merchandise store for a 3-month period, I think a couple years ago, that they open sourced. And we'll take a look at it. I'm just going to import it from this notebook, which we'll put it here. And what that's going to do is create a database, a DuckDB database, which you probably heard about in earlier sessions today, yesterday. Something that I'm personally very excited about for working with data in the browser. And when we have that, we're able to do something like create a data table and select our database here. And then we can select from the tables included in this SQL database. So to give you a sense of what we're gonna, you know, dashboard today, this data has a bunch of items. So things like, you know, cups, water bottles, merchandise you could buy, hoodies from the Google store if you go to like store.google.com or whatever. And it has, you know, the price of the item, some categories, maybe variants like the size, a large hoodie versus small hoodie, they're separate, and the names of the item. The other really important data here, though, is the events. So this is what you would get from Google Analytics, and it's, you know, very representative of any kind of e-commerce, a lot of kinds of analysis you might do. So I'm hoping that, you know, in building this quickly, you kind of have ideas that you can take to your own data. So this has some important stuff. I mean, one thing you'll note is that there's this item ID, right? That's just a number. So each of these events is something happened, right? So someone made a purchase, someone added the item to their cart, and we know whether it was mobile, desktop, user, we know what item, although we'd have to join that, which we're gonna do. And there's also a session ID, which is something, you know, that's gonna be key for us today. So basically, you know, you can see that this person added a bunch of stuff to their cart in the same session. They, you know, logged on, did that. And we also have, of course, when it happened. So this data table cell is really convenient. It shows, you know, lets us poke around the data. We could do more stuff like filter it. You know, maybe actually, let me do that. I'll filter because I really am only interested in purchases. Because the thing I want to ask today of this data is which items were purchased together, you know, most often, or if I care about a single item, can I see what other items were purchased with it? So we're going to want our purchase events, right? Now, there's a couple of ways we could make the next step, right? We're going to need to make a SQL query to join together this this table, the events with the items. And I just see that Joyce asked, where's the code that creates the table? There is not code that creates a table. We added it from the create cell menu. So this is a special cell type. However, something I'm a very big fan of, and I'm going to duplicate this cell. I love this duplicate button down here. And I'm going to show you that you can convert this table into code. And it's going to tell you, it's going to sort of irreversibly convert it into SQL code. So now we have SQL that is what's behind this table, right? And you'll see that it's got the filter that we put. So this is like the purchases. This is very generated SQL, like it's very precise. I like to sometimes simplify it a little bit, like maybe I'll just select star from events, and I don't need a shortcut necessarily, like some of these things you can just, if I run that, I of course broke events.date. Oh, there we go. Still no SQL. So now we have the SQL query. It gives us all the purchases. This is just like the data table that we saw up here, but now we can do some more advanced querying, right? And one thing we want to do is we want to join against the items, right? So we want to get the item information that matches the item ID here from the items table. So we'll select everything from events and we'll join items on, and we'll say events.item ID equals items.id. And then we will probably keep that. All right, so then now we see that we get new columns here. We have the name of the item and category and price and all that. So these are our purchases. And one thing I also like to do is name my cell. I'm hitting Shift Enter, by the way, to run the cell. It's a shortcut for hitting this button. And if I go here, I make a JavaScript cell and I say purchases, I get an array of all my purchases. So now we've got this joined together. That's great. We kind of have all the information we might need about our purchases, but we want to do, we want to go a little further. We're going to make a sort of more advanced SQL query, and then we're going to jump into making some interactive inputs and data visualizations. So bear with me for, I guess, a few more minutes while we do that. All right, so I like this query. This is helpful. A thing that I do all the time is if I have something working, I just duplicate that cell and then I work on that. I like to kind of, as long as I'm figuring stuff out, keep what worked around, because you never know when you need to go back and look at that. So this, I'm also going to go ahead and presumptuously change the name to co-occurrences. It's not co-occurrences yet, but we're going to turn it into that. So the trick to this is that we're going to select all the purchases and then join it against itself, so that we can get, every item joined with every other item, but we're going to join on the session IDs being the same. And so let me show you what that means. First, we're going to have to do this sort of, I think this is called a CTE, where you basically say with, purchased items as, and I don't have this memorized. I'm fully comfortable admitting that I'm cheating by looking at some code I wrote before. Everyone should do that. So purchase items is now something we can select from. So if I select star from purchased items, then I'm just going to get back the same thing that I had before. And what we're going to want to do, though, is not select star. We're going to want two items, right? We're going to want item A and item B, because we want to have them if they're in the same section. And where are they going to come from? They're going to come from purchased items. I'm going to get rid of this now. But we're going to call that A, and then we're going to join purchased items B. So we're creating two tables, A and B, which are both referencing the same actual table. But the trick is that we're going to do it on where the session ID of A is equal to the session ID of B. Now, when we do this, we're going to get quite a few things. Let's try it. Oh, I did something wrong. Oh, yeah. So item A isn't actually a field. We need to say a.name as item A and b.name as item B. So now we're getting, every combination of items that were bought in the same session. And that's good, but you'll see, we're going to look at a single session and see that there may be an issue with this. So let's look at, and I have one picked out here where we can, another cool thing about the CTE thing is that if you have filters that you want to do on the purchased items before you start joining them together, you can do it in there. So let's say that, the session, we're just going to look at a single session. We're going to choose one that's pretty simple. And let me also put this up here so you can see that like this session has 2 purchases, right? And one is a Google large tote and one is a Heather Green speckled tee, some kind of t-shirt, I guess. And so, these 2 items were purchased together, right? And so what we want in our co-occurrences query is to have one row that shows these 2 things together. What we're actually getting is those 2 things together, but also, the speckled tee with the speckled tee, the tote with the tote, and then the opposite direction. So kind of the trick to make this work so you just get the 1 is that you can say where a.name is less than b.name. So that's going to filter it down to just the combination. And so, it's because these are like alphabetically ordered. All right, so now that we have that and we see it works for our single session, I'm going to leave this, I'm going to comment this so that that's there. But I'm going to, I can comment this. So anyone following along, you could, uncomment it. You kind of try to break it down if you're confused about this. And let's see. So that's great. We have these working together. There's 42,000 rows, quite a few items being purchased together. Something that we'd really like to know, though, is like how many times this happens, right? So we're going to go ahead and add a group by, I think we'll just do, what did I do here? A.name, B.name, yeah. And I think we should be able to actually do it. Item A, item B, let's try that. Oh, and then we need to star. And something I'd do out of habit now is that I cast this to an int and save it as the name count. Now we have the number of times it happens. And of course, we could do an order by count descending. So now we have these here. I see a question, why not group by the session ID first? Well, we're joining on the session IDs. So all of these are going to be in the same session. And then we're, I guess it's possible if you group by, you may not need this, but someone should fork this and try it the other way. Let me know. But for now, we have, 17,000 rows where we have, how many times certain items were purchased together, right? And this is pretty cool already. Already we see the top 10, you could expand this, top 25 items that are purchased together. And it's always nice to see a list of things and see the top, but we may want to ask more sophisticated questions of this. And as the analyst making this dashboard, maybe we want to let other people say like, oh, they work in the t-shirt department and they want to know which items get sold with t-shirts most often, that kind of stuff, right? Like you never know what follow-up questions you're going to want. So let's make some interactive interfaces to let people do that. All right, so we have our co-occurrences, we have purchases, co-occurrences, and something that I'm also going to do, by the way, is I'm going to filter this because 17,000's a bit much. We can say having count greater than 5. Maybe this needs to be, yeah. So now we get 1,000 rows, right? 1,200 rows. So that's generally kind of a little more manageable. So clearly there's a long tail of pairs of items that just get bought together once or twice, right? So this shows us like things that at least get bought together 5 times. All right. So let's say we want to look at these co-occurrences in a little nicer way. And one of the things that we have is our inputs library. So if we say, I want a table, if you use this JavaScript table, we can create a view into our data, and we'll give it co-occurrences here, and we'll get, you know, a nice JavaScript table. This has some features that we're gonna get into that lets you customize it, right? So for one thing is you can actually select items from here. So if we know that someone wants to choose one item, let's say, and then see something else about it, we could let them do that. Let me show you also what that looks like. So the table variable has everything. But if I start selecting, then it's just got the things I've selected. Now, I want to let people look at the items purchased together for a given item. So there's a couple ways I could do that. I could let them do a search. So I'm going to say searched on the purchases. And if I then type, you know, T, it's like 2,000 results here. So let's say search, and I can also put this in a table. So now these all show things with T. Something you should know is you can customize this. So I can say the columns, unless I just want the name, price in USD, something like that. So now I'm just seeing like, you know, the names. I could also say I want people to only be able to select one. And then I'm also going to have the initial value be purchases 0. So now it's like automatically selected that one. So I could do something like, well, actually I should say search 0. So now if I do T, it's automatically got this one. But if I change these, the value, oh, I need to save this. Let's say you have selected is that. Then selected becomes whatever I select here. And now I could even do something like filter my co-occurrences. So let's say I do where d.item A equals selected.name, or d.item B is selected name. And so that's giving me two co-occurrences that match this particular t-shirt, you know, and it changes. And I could say, you know, filtered search, I guess like I'll just say searched that. Now if I say searched, we start to build up an interface. And, you know, once you have something, you can start, you know, maybe hiding the code, moving it around, and you start to have a little UI where you could say, okay, you know, search for campus, campus mug, campus bottle. There's no items here. But if you look at this one, there's a lot of things it was bought with, right? So that's a nice little, you know, interactive, yeah. I see the comment, when forget Google stocks when observable merge. Yeah, we need the observable store, and then we can publish the analytics from that. All right, so we have a nice little interface. We can interactively search through, look at the, you know, this table. I think something that is also kind of, you know, quick and easy to do is make this a little bit more readable, because right now you're kind of like, okay, I searched for something, I selected something, and I'm looking at all this text, and I kind of know that I've selected this, so I don't need to see it on both sides. So you can actually customize your table very easily, where, well, there's two ways to do it. You can format columns, but I'm going to make a sort of, instead of the options in my table, actually, I'm going to, duplicate, let's say, if I just map over my search results and I just return the same thing, I'm going to get the same thing. But I could instead return something like the item I want being the item that's not selected, right? So if item A, item B, it could be in either one. So if item A is our selected, then we want to return item B, otherwise return item A. And then I'm going to say count as d.count. And now I get this here, right? So now I can see for this campus mug, it's most often purchased with the Seattle campus mug, 22 times, let's say. So we're actually formatting our table by reshaping our data a little bit, which is kind of cool. All right, so we have that little interface. Now I think we should try to do a visualization, because it's one thing to like look at individual things and maybe you want to drill into something, but a lot of times we use visualization to get a more zoomed out perspective, and maybe that will help us zoom in. So when you have these things together, right, you might have heard of a co-occurrence matrix, something that we can visualize these two things together. So I'm going to show you how to build that up from scratch with plot, which hopefully you're familiar with, and if not, we have a lot of references about. So let's start that. And we probably have a snippet, yes we do, for a cell chart. So this lets us visualize values by category in a grid, and let's take a look at what that means. So well, let me just render this, right? So this is going to draw a rectangle for each value in both axes. This is some weather data looking at, I think, dates and months. But what we want to do is put our co-occurrences in here. And instead of this, we want to say item A, and we want to say here item B, and then we can color them by the counts, right? And one of the cool things is it works technically straight off the bat. So now it's every item, here, and then the color is based on how often it's purchased here. But of course, this is totally unreadable. But the nice thing, I hope you agree about this process, is like how quickly we can sculpt this into something that we want to see. So, maybe one of the first things you notice is the axes are cut off, can't read the labels down here. So we can customize some of the display of our plot. Maybe add some margin on the left, make some room there. Okay, that's not quite enough room. It's probably going to be a lot of room needed there. Maybe we can make this full width as well. And by default, that will stretch to fill the cell. We could, on the x-axis, rotate the ticks. So tick rotate, we do 45, that's 45 degrees. Need a comma. So I'm looking down here. I can't see what I did because I need some margin bottom. It's at 250 as well. Stop forgetting my commas. And if we rotate these by 90, it'll be up and down. All right, we have kind of, these would be readable if there wasn't so many. So maybe what we can do is, instead of rendering everything, we can render some meaningful subset. So thankfully, there is a nice the feature of plot where you can sort items and limit them. So if you want the top 10 of something, right? So then I'm going to say I want to sort the X by, what do I want to do here? I want to sort the X direction by the filled channel, right? So the filled channel is determined by the count. So I'm basically saying put the most purchased things first, and then, in descending order, order them there. At the same time, I'm going to do this at the Y channel. The Y-axis is also going to go, most to least. And actually, to get it to go most to least, we're going to reverse it, because by default, it's in ascending order. So kind of like we did with the SQL query, where you say order descending, that kind of thing, right? And then we're also going to limit it to 20 things, right? So let's do that. And all of a sudden, we can read, right? So we have the top 20 in each direction, and we're using the default color scheme, which is Turbo, which has some, high contrast, good things about it. But a lot of times, you'll probably want to customize your color scheme, which is very easy to do. So we can say scheme, and we'll use greens. So now we can see, the darker the cell, the more the count is. And so we have things like this journal being purchased often with this sticker sheet. You can see that some things, this here no set is purchased a lot with a few other things, right? So this co-occurrence matrix is nice because you start to get things that you might want to look into, like, what's up with this journal being bought with these things. There's a campus bike, I guess, that gets bought in a set with these things. So this will let you ask new questions. But we can do a little more, I think, to make this even more readable. One thing is we could also just give it some more height. Another important thing is to have the some annotation on here. And let's see. Oh, wait, let me pause for a second, because I see there's a question about how the table got generated in the first place. How do you change the fonts, colors, other styling? So the observable input table used somewhere here. This table or this table generates this HTML and CSS. There's several options. Maybe someone can put the link to the inputs table API documentation, which allows you to customize like CSS and that kind of thing, as well as some of its behavior. And Web says, can you get actual counts in the cells instead of colors? I think we can do one better, which is we'll do both. So that's, as I was saying about annotations, it's very important. One, I'd say one way people often want to do annotations is tooltips. So there's the title channel. And for that, we could, we kind of want to include all of this information. So we'll make a custom accessor function, and we'll start composing a string. I could say, this is my tooltip. If I run this and I don't put a comma, we learn one lesson a day is you need commas. You get this sort of like HTML tooltip. If you hover long enough, it never quite works for me. Why is it not working? Which is why, there it is. Which is why I much prefer to, and I've memorized this at this point, import this plugin. Wait, I need to, I like doing it like this. I just import plot from Mike Freeman's plot tooltip plugin. And this is sort of our like prototype tooltip system. And when you do this, you get nice interactive tooltips like that. And so now we can customize this and say something like, d.item A plus item B equals d.count. So now we're going to be able to see something like taskpad, and the here no set is 109, the most, 158 for this top one. But you can go around and kind of drill into these. Now, as was asked, can we put text in here? And the answer is yes. And it's another one of my favorite things about plot is that it's actually very intuitive. We can layer marks. So there's a text mark that's very much like the cell mark here. And what we can do is really just kind of copy this and keep everything, except instead of, we don't need this tooltip. We're not going to need this sort. And instead of the fill, we're going to put the count as the text. And we're going to change this to text. So we're saying draw text for each of the co-occurrences and put the A on the x-axis, the Y on the B on the y-axis, and write text. And now we have counts. And now you might say, great, I can read these over here, but I can't read these dark ones. And thankfully, there is another plugin available called Color Contrast, which I will just paste the import statement here. And the nice thing is, like, you can click on these links to go see these notebooks if you're curious. So if you've been following along on this notebook, everything I'm importing, you can follow that, then going there. So now our text, we can transform. So something, if you're not super familiar with plot yet, is that all these marks, they take some data and then they take some options, right? Some configuration. And that's where we tell it what we want it to do. There's a pattern called transforms, where you can pass these options into a function that does something, transforms the options in some way. And then that will get passed to the mark. So in this case, we'll say color contrast. And so we're essentially calling this function with the options, and that's going to change some stuff. But what we need to do also is tell it that the fill is based on the count. And now it's automatically changed the text to be white whenever the background is dark and black whenever the background is light, using some formulation for those. Based on this high contrast color math that I don't quite fully understand, but don't have to, because this is a nice plugin that I believe Phil wrote. All right, so cool. We have our plot. We can zoom into it. And I mean, one thing we can go ahead and do is, I can, yeah, why not? I'll duplicate it. I said I like to duplicate stuff. I'm going to put it up here, just sort of moving it around. I'm going to put it here. And so now, right, I have these sort of searched items, right? I could also do this visualization only for search things. So now this is going to render this table based on what I've, oops, I need stuff that has actually been used together. But now we can see, the campus mug that we've selected, and these are the top things with it. Yeah, so you can always switch out the data, and if it's interactive, you get something like that. All right, well, that is kind of where I wanted to take it today. I think I'll show the tutorial series goes in a bit more depth. We do some stuff like calculate the percentage when we're searching for stuff, make some custom markdown so that, kind of clean up the interface a little bit. So if I search for campus bike, let's say, this is what you get. And then there's an advanced dashboard, which we cover things like, if I search for a campus here, it actually shows a Forts network where all the orange are things that match the campus and all the blue are things that are purchased together with any of the search results. And we have a kind of smaller component that shows the co-occurrence matrix as well as the table here. And we even can filter it by day. So if you wanted, this is just looking at 1 month of data. This goes, I believe, I forgot, to 31st, so it gets more data, right? And that's actually requerying based on this input. So if you want to know about how to dynamically generate SQL queries we go into that. And so there's 4 parts. There's like a deep dive on the SQL, the interactive filtering, the matrix visualization, and the force layout. And I'll mention the force layout is slightly customized. It shows how to go from like a D3 force layout example, like the chart that is one of the official examples, and then you can customize it. But once you've set it up, then customizing it is like, it uses the exact same configuration, but you can do things like maybe make some nice tooltips, do some other stuff. All right, let me look at the chat. And I see someone asked which tutorial series. So it's actually linked at the top of this notebook. Maybe we can share this notebook one more time in the chat. And then let's see, I'll answer a couple of questions. All right, the most recent is Google Analytics data is typically nested. Can you unnest data with the SQL client? You can unnest data with SQL there's an unnest command in most dialects. However, for this example data set, we unnested it when we prepared it, since we made it like the example data is in Google BigQuery, which you can access directly from a notebook if you have a pro account and you have you've authenticated your own BigQuery client. However, we wanted to make a public data set that you could just play around with quickly in the browser. So we sort of did some processing to make it a little smaller and nicer, and it is flat instead of nested. And then I see some love for the turbo palette, and that's cool. And then the color contrast piece from Misha. Is there any way to easily cluster XY options that clusters high-low co-occurrence items? I don't know about an easy way. I'm sure there are algorithms out there. And if you were to use one to find clusters, then I think it'd be, you could easily specify the order you want your plot to plot the X and Y data in. So that is something that would probably be done more on like as a data processing step before you visualize. And then how does it sort in the second mark block? How does it know to sort in the text, right? Because I only sorted this. So when you do this sort on a mark, it's actually sorting the X and the Y axis for the entire plot, so that this mark, when you're telling it put item A here and put item B here, it's going to put them in the X and Y order that the entire thing is. So you only need to sort once. You only want to sort once, really. Because a whole plot shares scales, right? Like you configure the X globally, the color globally within a plot. So all the marks you use are sharing those scales. All right. And I see this question about heavy processing inside Observable Notebook that's usually offloaded to a server. So, this demo used DuckDB to do SQL in the browser. But if you have a pro account where you have a database client, we support connecting to several popular and powerful database servers. So then you could write a SQL query that could query against however much data is in your database, and it will return the data, and you can deal with it in the browser. So if you want to do some of these grouping by and filtering in your database first, then you can send over a manageable amount of data to the browser. And then if you want to offload it to the backend, I think that the way that often happens, people we work with will have an API. So, you kind of think about like your data. If you have some heavy data processing, you would do that either on a database or behind an API, and then your notebook could easily talk to those and get what it needs and then render that, is my short answer to that question. And with that, I'm only 3 minutes over. I don't see more questions. So maybe wrap it up.
Awesome. Thanks, Ian. Thanks for the dashboard. Thanks for building real time. We appreciate it. And thanks for answering the questions. It was great, great dashboard, great demo as you always do in presenting live. So thank you for being at Observable Insight. Now I see you in Slack.
All right. See ya. Thanks, Al.
All right. Yep. Great. All right. As we continue to give you what you need, up next, we have a presentation from Irene. And Irene is going to share Eurovision results of Spanish artists, composers, and lyricists by gender.
Hello, everyone. Thank you for inviting me to this Observable Insight Community Conference. I've been using Observable for more than 2 years now, and it's just wonderful to see how this platform is growing and how this community is getting bigger and bigger. I'm super excited to be here. I'm Irene de la Torre. I'm a data visualization designer. I've worked in news, I've worked with researchers, for example, and I'm currently a digital designer at the Financial Times. A few months ago, I was working at a pharmaceutical company, and I was really missing the most crazy kind of creative visualizations that make visual alphabets and languages to communicate data that intrigue viewers but don't give the information right away. So while I was watching the contest to choose who would go to Eurovision to represent Spain, I thought that actually this would be an interesting topic for a personal project. Now, if you have no idea what Eurovision is, do not worry, I'm going to do a very brief introduction. Basically, Eurovision, it's a European Song Contest where each country sends their representation. You might have heard about it. If you don't live in Europe, you know about it. It's impossible to avoid it. But if you don't, Will Ferrell did a movie a while ago, so you might have heard about it. Or suddenly, if you're following European people in Twitter, you might see weird stuff coming up in Twitter that specific week. It's just a crazy song contest, I would define. This year, the selection of the Spanish representation was rather controversial. Basically, the voting system gave the same importance to the jury than to the audience, but the jury voted strategically so that the favorite of the public wouldn't get selected. It was also rather controversial because the three main favorites, among them the winner, were all female artists singing and communicating different messages about what it meant to be a woman. So one of them spoke about feminism and being a mother, another one about tradition, and then the winner also spoke about, well, living your sexuality freely and being comfortable in your own body, right? When Slomo got chosen, as I said, there was a huge debate around representation and messages. Some might have thought that my description of the winning song is not very accurate, so it was very controversial. But for me, the interesting part was that the conversation focused mostly on the artistical representation, so the message of the lyrics, the dance, the dresses, etc. And for me, I was just wondering who was behind this song, who were composing these lyrics, right? Because a feminist message about being a sexual being in general can have different connotation if it has been written by a man than by a woman, right? So I really wanted to explore who creates these messages and who are the invisible teams behind the winning songs. And I want to point out that my exploration is extremely binary. It's just about men and women. And there should be a bigger conversation, for example, around race, around messages, around diversity, just in general, because if we want our songs to be representations of the country, then we need to be aware about these other topics too. Now, speaking about the limitations of the project, I'll start with speaking about the data. So what did I need to do this project? I needed the historic data from Eurovision. I needed to get the total number of participants and what was the lowest position. This actually changes depending on the year. And I also needed this, the position of Spain each year, so that I could see if they had reached a good position or in the ranking or not. I also needed historic data for Spain, so the names of the singers, the lyricists, and also the composers, just in general, the team behind the songs. As you might see, I also indicated, if the performer is male or female. For this, what I did, I went to Wikipedia, checked all the pages, and if I didn't find their pages, I would go to their social media profiles, especially Instagram with young people, and see if, for example, they define themselves as he, she, or they, all of them, it was either he or she. So, and then there were some people rather unknown from the 70s, 80s, that I just had to check the news. Now, regarding the data, up to 2021, I use SpeechKervet's repository, and 2021 forward, I use EurovisionWorld.com. And I would like to thank both of them because they are great resources if you're doing anything around Eurovision. They have a lot of information and a lot of data. Once I had all the data, I started doing sketches with plot. Everything that you're seeing here is just observable notebooks. The charts look a little bit strange because I've zoomed in quite a lot so that you can see them. And I chose plot because it's just extremely flexible and dynamic. I could just do the craziest ideas really, really fast. And also to just, in general, check the shape of the data. I had different goals. The first one, differentiate the gender of the artist. As you are seeing, the orange represents female and the purple represents male. The very light green, in this case, it says mixed, but it's just indicating groups that had female and male artists in them. I also wanted to highlight that a song is just not only the singer, but also the composers and the lyricists behind, as you can see here. Most of them do have people beyond the artist, right? And most of these team members are actually male. I had a hunch that this would happen, but it was kind of sad to see the plot because there aren't so many female composers participating in Eurovision in general. There are also many singers that have composed their own songs, and I wanted to differentiate them from those who have not. So the stars in this case who are filled are also singers or artists that sang the song and also composed in the song. Finally, I also wanted to see if the size of the team behind a song related to the final position in the competition, if there was some relation. So if the bigger the team, the better ranking. Actually, that is not the case. I can see a slightly trend with bigger teams in the last years, but I don't think that impacts the final result. And then for this specific visual that you're seeing here, I also wanted to play a little bit with the shape of musical notes and compositions. Again, going back to using visual metaphors to explain data and just to give, well, to intrigue the viewer, right? So once I had the design for desktop, I also tried it out with mobile. It's the same representation, but with the axis flipped, and it's vertical. And you will see that the code is rather long, but this is first because I have two views. One of them is reacting to the toggle for aligning at the bottom, and then the other one is showing the ranking. And then also because I need to edit absolutely everything in the styles, absolutely everything on the plot. And this is basically what it's doing. It's just changing the stroke sizes, the colors, the everything. But beyond that, it's just lines. That dot is the symbol of the star, and this one is the beeswarm. I use the beeswarm form for the composers and the lyricists to avoid the dots overlapping each other. But that's it. There's nothing else into it. It's just lines and dots, and knowing what I wanted to do and really understanding where I wanted to position everything. That's it. There's nothing much into it. And using plot really allowed me to play around really fast and kind of figure out what I wanted. Once I knew what I wanted, I redid the plots using D3. I wanted a higher level of control of the visual aspect of the chart. I wanted to include animations. I also wanted to include the tooltip that you're seeing here. And I just thought that with D3, I could really control absolutely everything. For example, the animation, right? How it happens, what is the order, what is supposed to happen when we trigger this behavior and this transition. For each of the add-on plots, etc., I created classes and functions. And that is because I wanted to replicate this notebook that you're seeing here in English, but in Spanish. So what I did is basically I have one notebook in English and another one in Spanish. And the master functions and master classes are in the English notebooks, and I'm just importing them into the Spanish notebook. Something that I realized is that when we are using toggles or inputs in general, or variables in functions in the notebook, when we are importing it into another notebook, it's expecting us to use the same inputs. So in order to avoid this limitation, or to kind of fix it, I learned that you can extend functions, which is something, or actually classes, right? Which is something that I didn't know, and I actually learned by doing this project. So everything that is specific to a language, like the tooltip, or not to the language, but to the notebook. So the Spanish notebook needs specific inputs, which are the toggles, and specific tooltips. Those two things need to go as an extension of the master class, because otherwise it doesn't work. I don't know if it was the best way to do it. It's just how it worked for me, and it actually worked quite well. Once I had the scripts, I used the embed option in Observable. It's something that I have wanted to try for a really long time, and I thought this would be a great opportunity to try that out. Basically, you can embed cells in your page as long as they are named. So you can select all of them. You can select the ones that you are interested on. So for example, third participation, the radius type, the aligning, the component, these are all inputs from Observable. And as you click and select, there's kind of like a code below that you can copy paste. And it's important to bear in mind that you need to include all the scripts and all the cells that influence how your chart is going to behave, right? So for example, in this case, I edited the CSS so much that I had to include it in the iframe, because otherwise it wouldn't look like it should be. Finally, there are different options for embedding your plot into an HTML file. You can do it through an iframe. You can also do it through JavaScript or React. I use JavaScript because I'm very comfortable with it, and I thought it would be the easiest for me. You just copy the code, and then you pasted it in an HTML. For me, I divided the script into the HTML and then into a JavaScript file, just so that I had the scripts were tidier. The only thing to remember is that we are embedding our scripts into divs. So we need to have the same divs that we are calling into the scripts in the HTML files. Observable does this automatically. I just changed the ID so that I could remember a little bit better what everything was. And that's what you're seeing there. So Observable HQ dash chart dash participation, for example. And I think that's really it on this side. something that I'm gonna mention to you around the iframes. So once you have this, imagine that you want to update the data. For example, it happened to me. I had this project prepared prior to the final day of the contest. And then I wanted to update the data once we had the results from 2022. You just update the notebook and that's it. You don't have to do absolutely anything else, which is wonderful because if you have your code in GitHub, you don't need to kind of update anything else. You update the notebook and that's it. It's very, very easy and comfortable. So once I have all of that, this is basically the final result. This is the page in English where I explain a little bit of the contest, the three main or the three favorite ones. The first plot showing artists and rankings with the tooltip. Then the second chart with showing composers and lyricists. These inputs that you're seeing here, the radio buttons and the toggle and the checkbox, they are actually the same inputs as the ones in Observable. Because I embed them through the JavaScript, I could edit their style as I wished. That's why they look like that. And that's it, really. That's the English page. And then this is a Spanish page that behaves very, very similarly, if not the same, as the English one. And I hope you liked the project. I hope you have learned something new from Observable. I hope you're intrigued about Eurovision. Thank you very much for watching me.
Awesome. Thank you, Irene, for that presentation. It was inspiring as like all other presentations throughout the day. And thank you all for staying with us in the chat. And we hope that you enjoy Observable Insight. Come see what your data can show day 2. Thanks for the compliments, Aaron, and sure to pass them along to Irene. Now, we're going to take a quick break. But during this break, we have a special presentation. If you saw him yesterday, he's back for day 2, the one, the only, Visnu.
Hello. All right. I hope you can hear me. Yeah, probably. Gonna assume so. Cool. When you're here before, can look you in the eye, just like an angel. Your skin makes me cry. You float like a feather in a beautiful world. I wish I was special. You're so very special. But I'm a creep. I'm a weirdo. What the hell am I doing here? I don't belong here. I don't care if it hurts. I wanna have control. I want a perfect body. I want a perfect soul. I want you to notice when I'm not around. so very special. I wish I was special, but I'm a creep. I'm a weirdo. What the hell am I doing here? I don't belong here. Whatever makes you happy, whatever you want. You're so very special. I wish I was special, but I'm a creep. I'm a weirdo. What the hell am I doing here? I don't belong here. I don't belong here.
Awesome. That was beautiful. Visnu, thank you. And we know you belong here. And how's everyone doing? Let me know in the chat. Feeling good? You enjoying the day? I see someone said this is very observable and give it a clap. And also give Visnu a round of applause, please. Give Visnu a round of applause in the chat. Use the clap emoji, high five emoji, hand emoji. Give Visnu a round of applause. That was beautiful. Yes, Michael, better now. Agreed. Same, better now. That was peaceful. That was very peaceful and beautiful. All right. I'm gonna take a break. Not take a break, I'm gonna take a breath. Let's take a deep breath. 1, 2, 3. We good? Because now we're gonna go down a journey. We're gonna go down a story. We're gonna hear a story over 5,000 years of a story with the one and only Toph Tucker, software developer at Observable, who's gonna walk us through 5,000 years of graphics. Toph, the stage is yours.
Thank you so much, Wayne. One moment as I share my screen. Can't access the screen. Oh, here. Okay. Aha. Can you see my screen? Just in time. Amazing. My name is Toph Tucker. I work here at Observable. When you go to insert a chart in Excel, you see this big gallery. And all the charts exist side by side here. They're all charts. They're all the same thing. But which came first? In the chat, tell us which came first. And which do you think came last? So I never studied visualization formally, but I learned D3 right after college, and it's been the basis of all my work since. And I always loved when Mike Bostock would put a little citation in one of the graphic examples he put up. It always made me wish I had had a curriculum to go through. So a few years ago, I started collecting those citations and putting them in a giant chronological list, and it got out of hand fast. So I've got about 100 slides to get through in like half an hour. So it's going to be very frantic. The circle on the right shows my progress. The black circle is my progress through the presentation, and the white circle is where I've got to be on track. So I'm a minute behind. I've divided the list of, this is like 100 slides or something, and I've divided it into about 5 rough categories. The first one, stuff doesn't really look like charts yet. It's just, it's like the building blocks, stuff that will lead to charts. beginning to subdivide space or transform space, shrink space, like maps shrink space, most maps shrink space, and otherwise encode information in symbols. And then in the second era, we get to charts that look recognizably modern. They look a lot like what you would do today. And in many ways, they may be unsurpassed, and they make full use of the two-dimensional plane as a abstract graphical surface. Much of that early graphical work is depicting stuff that is naturally or easily quantified, like economic data or measurements of space and time. But then in the late 19th and early 20th century, we get into science expands its domain to quantify more and more aspects of human experience. Psychology becomes increasingly quantified and so expands what can be visualized. And it's also very problematically intertwined in the early 20th century with the pursuit of eugenics. After World War II, we have the dawn of the computer, initially in sort of large industrial, academic, or government contexts, and then increasingly personal. And I've just divided it into 20th century computer and 21st century computer. So first, sign, measures, and maps. This is the fuzziest. But once upon a time, the gods decided to send a flood to destroy mankind, according to a tablet later excavated in Nippur. And it was the ruler of this town of Shurapak on the banks of the Euphrates whom they instructed to build a large boat. And it was in that city that an expedition in 1902 excavated this table of 3 columns, which we believe to be a multiplication table. Later, we have some rulers. The subdivisions on the rulers become increasingly regular over time. This is a very early one with very irregular subdivisions, but we think it's a ruler. And then a Babylonian map of the world showing Babylon split by the Euphrates and surrounded by a few other cities, and then sort of a circumferential ocean. Eratosthenes was a librarian at the Library of Alexandria, and in the 3rd century BC, we believe he compiled a 3-volume book, Geographica, in which he introduced latitude and longitude, subdividing the surface of the Earth into a grid. No copies of the 3-volume text survive, but this guy's also notable because he estimated the circumference of the Earth to be 252,000 stadia, which is off by about 2.4%, which is not bad. From the 5th to 11th century, there's a wide range of family trees of Jesus Christ, network diagrams, early network diagrams. In the Andes, we have the Incan quipu, which encoded information in knots in string. And you could have like a bundle of knots to do accounting. And it may have done a lot more. We're not sure. Nicola Rem has some very early abstract use. He called it latitude and longitude, but he used them abstractly to represent quantities. Subdivision of time is also important, and few had a better calendar than the Mayans, using their excellent base 20 positional number system. One artifact of that is this Aztec sunstone, which is something of an inheritor of the Mayan calendar, showing, interlocking. You got to represent the large and the small at the same time. So there's a lot of different bases and different interlocking periodicities. Peter Ramus was early on the train of attempting to maybe arguably reductively reduce everything about life into comprehensive logical systems, and he had all these elaborate bracketed diagrams. And then we have Descartes. If you have an x coordinate and a y coordinate, You owe it to Descartes, maybe, or we call it the Cartesian coordinate system anyway, because his followers developed it in order to understand his book of geometry. It's not obvious here necessarily yet, but it's nice to remember that the two-dimensional coordinate plane is not God-given, but we imposed a coordinate plane on space. And that brings us to the second era. Those are just sort of building blocks, but none of them really look like charts. And now we have the era of stuff that looks like recognizably modern charts. This one, does this look familiar? This is sort of a wonkier, weirder one. But Descartes, in his theory of gravity, this was 40 years before Newton's Principia, but he partitioned space into these swirling vortices and believed that's how orbits worked. And we'll come back to this later when we get to Voronoi. This now looks like a chart. For the first time, this looks like a chart. We have a one-dimensional axis subdivided with ticks and tick labels, major ticks, minor ticks, showing several different estimates of the distance between Toledo and Rome. Priestley's chart of biography, this is just a small excerpt. It was like hundreds of pages long. But this showed the lifespans of 2,000 eminent people, one-dimensional timeline. The geographic areas of cities, now 2 dimensions here. And then William Playfair did a lot. He was a spy for Britain in the war with France and pioneered the line, bar, area, and pie charts. And in a way, we still can't do better than this. We have a tinted chart, or choropleth. And then this guy was studying a lot of star orbits. You know, this guy was investigating the orbits of stars. It was a printed thing. We are into the era of the printing press now, but in his paper on the stars, he said, I've deposited a couple of diagrams with the Royal Astronomical Society. We believe that those diagrams contained some of the earliest known scatter plots. Presumably, he didn't get the diagrams printed with the rest of it. It was just like manuscript because of the cost of engraving. But they don't survive. Nobody can find any copy of this scatter plot. John Snow, we've been talking a lot about in the coronavirus era, and his map of cases compared to the positions of water pumps. Florence Nightingale's graphics of fatalities in the Crimean War. Now, since the people of Micronesia had been pioneers of seafaring technology for thousands of years, it's hard to know how long these had been in use. But in 1862, a Hawaiian missionary documented one of their methods of navigation, which is these interlocking sticks, curved or straight, representing patterns of ocean swells like a plot of a vector field. Charles Minard, this is a very famous one, partly because of how many different variables it plots, but this is an early flow map. And we'll come back to the idea of showing like branching and merging flows. We'll come back to that in a second. Early radar chart, and then also a two-dimensional subdivision of space. It's not quite a tree map, but we'll come back to that. The Amasilik made three-dimensional maps of the Greenland coastline, carved into wood. This is another case where it's sort of unfair. This whole like idea of putting everything on a chronological timeline, one of the issues with it is that we don't know when the Inuit were carving this. We only know when a European saw it and attributed a date to it. So that concludes Era 2, the explosion of a lot of the basic graphical forms that are still with us. And if you think about what quantities were being charted there, it's things that are a little more naturally or easily quantified. Economic data, areas, deaths. And then science expanded its reach into other aspects of experience. And along with that comes more of a kind of mainstream cultural role for the concepts of quantification and abstraction and backlash against that. We also see more aggregations for the first time and transformations of those aggregations. So the early history of statistics is very troublingly intertwined with eugenics. Francis Galton coined eugenics and pursued it, and to that end developed correlation and regression. And here has an early sort of density plot of the heights of parents versus the heights of children. His disciple, Karl Pearson, introduced the histogram. This one's sort of interesting because it's just like a bar chart. We've seen bar charts before, and bar charts predated this, but there's an underlying aggregation or transformation of that. There's binning. There's a binning transformation, which makes the histogram distinct from the bar chart or column chart. And now we're back to Minar's flow map. I feel like there's a big trend where stuff starts sort of concrete and then gets more abstract. The flow map uses it's a map, so it's using space more concretely, and then Sankey extended that abstractly to show flows of energy through a steam engine. W.E.B. Du Bois and some of his students contributed many remarkable graphics to the 1900 World's Fair, including this one, which I like in part because it folds space in order to show the very large next to the very small, which is a perennial issue in data visualization. Here we have Voronoi. Voronoi's paper that gets him credit for Voronoi diagrams doesn't have any diagrams in it. But a Voronoi diagram is just a partition of space by what point it's closest to. It looks like this in the bottom right. Descartes had it for his vortices. And it's often that like some of the seminal stuff, like it doesn't actually have the graphical application yet, just some of the underlying math. Where earlier color systems had tried to force color onto a perfect sphere or whatever, Munsell rigorously studied the nuances of our perception which don't fit so cleanly onto a shape. Now I have a couple art slides. The first time I presented this, people were like, cut the art. And I'm like, I don't want to cut the art. I'm not a good art historian. I would love to be a better art historian. But Kandinsky, it's interesting to see as the reach of science expands, it also permeates. Art also gets kind of more abstract and geometrical. Kandinsky wrote this book, Point and Line to Plane, about not just the geometrical forms, but about like the emotion, the like feeling of stability of a horizontal line or imbalance and whatever. Man Ray took this photograph of a 3D model of an equation at the Poincaré Institute in Paris. He said, I don't care about the formulas, but I like the sculpture. And then Picasso's bull. Jacques Barzoun later described this. He was talking about kind of the history of science and how observation is tricky. He wrote, a better way of observing consists in overlooking visible details, in neglecting observation, to put it rather strongly, and in viewing objects in geometrical fashion, seeing their quintessence. It's the method used in Picasso's bull. In the series of sketches, he starts lifelike, massive, glossy, beautifully drawn in every part. And then in a dozen or so gradual reductions, he loses one characteristic after another until at the last, he is the bare outline of what he was at first. He is the abstract bull, the bull, so to speak, of science. Borges also riffed on the idea of a map as big as the territory and therefore useless. In 1947, we have a map with an 11-dash line in the South China Sea, later reduced to 9, representing territorial claims, which is a reminder that maps do have some power over territory, and not just a projection from the territory. Mary Eleanor Spear introduced many variations on what she called range bars, showing ranges of data, but notably this one, which later became sort of standardized as the box plot. Maps are generally smaller than the territory. Borges talked about one as big as the territory, but sometimes we also have kind of maps larger than the territory. And this introduced the bubble chamber, which allowed us to see subatomic particles, You have a piston expands the chamber, heating the liquid inside to just below boiling. It's sort of teetering on the brink. And then if a particle goes through, it like tips to one side or the other, so it acts as a magnifying glass of the paths of the particles. And we have Wittgenstein. I don't know what to say about him. Tried reading him. Wittgenstein. Fitz's law says that it's easier to click a button that's bigger and closer, which later became important as the history of graphics merged with the history of later computer interfaces. A little preview. The magical number 7 asserts that in many domains, we can only sort of distinguish 7 gradations of a thing, like 7 different pitches or shades of a color. And Stevens's power law of perception says equal sensation ratios are produced by equal stimulus ratios. Okay, so that's sort of the site. It's like not only are we quantifying more aspects of human experience, but we're also using that to judge the effectiveness of graphics, sort of turning them back on themselves to study the principles by which visualization and perception work. And then we have the computer. The computer. Big deal. When you draw a line chart and want to connect points, different points, if you want to connect them smoothly with some control over them, a very common way to do that today is a Bezier curve, which was actually developed slightly earlier than Bezier at Citroën, as you can see here. Richard Hamming wrote a book on rounding errors and the feedback and stability of errors at a time when it was not obvious that computers offered insight, and it was important to make this point about the purpose. Here we have one of the first computer animated animations. Short film showing a satellite going around the Earth and the rotation of that satellite as it goes. Got to make sure to pause that so it doesn't keep playing on the further slides. So in 1965, the Mariner 4 space probe flew past Mars, and it transmitted image data to NASA, where a machine printed it as numbers onto strips of paper. And rather than wait for the computer-processed image, the scientists taped the strips of paper together and hand-colored them based on the numbers. Charlie Lloyd calls this the bridge between thinking in pictures and thinking in pixels. Jacques Bertin attempted to pull apart the primitive pieces that all graphics have in common. It's like with the dawn of the computer, we also began to systematically break down graphics into their constituent primitive pieces, because once we have a system for breaking them down, we can build a system for building them back up, for specifying them concisely with code. Lou Verlet did some integration math. This is one where it ultimately led to these, you know, those like wiggly wobbly force-directed graphs. A lot of different pieces had to come into place for that, including graph layout algorithms and these techniques for fast integration, fast numerical integration. With the computer, people tried doing higher dimensional stuff. And once you do higher dimensional stuff, you have to ask yourself, can people understand it? Which Shepard and Metzler studied. They studied shape rotation and how well people can identify if two projections of the same shape are in fact the same. Anscombe's quartet is four different data sets with the same mean, variance, and correlation, but that look radically different. So, you know, if you look at them in table form first, it's not obvious necessarily that they have the structure they have, but it's a wonderful testament to the importance of visualizing, because by summary statistics alone, these 4 data sets would look in some ways identical. Then we have this Prim9 system. So here's John Tukey with a keyboard that has 9 dimensions of arrow keys. And so you could rotate and prune and filter in 9 different dimensions. I think he'll show a little rotation here. And you can see some parallax. Show some parallax. Yeah, some parallax as the points rotate past each other and reveal some underlying structure. Love it. Tukey also further developed the box plot and sort of standardized it on showing the interquartile range and so on. The cycle plot shows the same piece of time over time. So like sales of cell phones on every Wednesday, like one Wednesday after the other, which is a sort of interesting abstract transformation of time. And time is so often for so long, time has been so often the independent axis, but it's cool to show. It's like analemmas in astronomy, sort of. This image was calculated using a 1960s punch card IBM 7040 computer and then plotted by hand by this astrophysicist Luminet. So the positions of the points were calculated by a computer, but then they were plotted by hand. Another one of these interesting liminal cases in travail, in transition to the computer era. And I also want to point out, it looks awfully similar to what you'd see in like a movie like Interstellar today, which has a lot more horsepower going into it. 1979 with VisiCalc. This was the introduction of the electronic spreadsheet, which made tables not only a display of data, but also an interface to your data and an interface to a data flow graph. Some algorithms for drawing trees nicely, the sort of thing you could do by hand easily, but once you have computers, you need algorithms for it. The icicle plot showing hierarchies. We'll come back to this one later. It's sort of similar to a tree map or sunburst. And then here's one of these sort of, as quantification took over, it also invited critiques of the role and influence that had on society. Walter Wrong pointed out that I should have marked more clearly when we shifted from the manuscript era to the printing era, but hand-done technical drawings, this is a testament to the tacit knowledge or how hard reproducibility is. But he was making the point that once you had printing, diagrams were much, much more feasible because you didn't have to rely on the reliability of a copyist. Tufte's visual display of quantitative information, in addition to becoming sort of a breakout mainstream success, much more than these other items, also introduced the slope graph. You can have in Cartesian coordinate, you can have a horizontal axis and a vertical axis, but then you sort of run out of space. You can try to do 3-dimensional stuff or whatever, but parallel coordinates just put all the axes next to each other, and then one point is represented by a line among all the axes. Latour died recently, and I've never read him, and I definitely should. R.I.P. Anatoly Fomenko was a geometer who I just want to point out also is an interesting guy because he thinks the Trojan War and the Crusades were the same historical event. He has some beautiful books of illustrations. VisiCalc led to Lotus 123 and then to Excel. And so we're still living sort of in the VisiCalc paradigm of a spreadsheet, but it has issues. Like it runs out at 2 dimensions of data. Excel has like pivot tables sort of like jammed on top of that to try to solve for that. But Lotus Improv in 1990 was an attempt to make the whole spreadsheet sort of like a pivot table, more database aware, more, I don't know, you can see these like columnar formulas and apply them to a whole formula at once. You could see it failed, but maybe it's a precursor to Tableau and such. And then we have the tree map. I was flabbergasted when I realized that the tree map had only been invented in 1991, but Ben Schneiderman devised it here to show recursive hierarchies. Like if you have a computer hard drive, this folder takes up that much space, and then like this file takes up that much space within that, and then the like that's image within that file takes up that much space. So tree maps. The Trellis graphics package looked at the 60-year-old agronomical barley yield data, and just by plotting it as a faceted diagram, they believe they found a mistake where in the Morris region, I think, 1932 had a higher yield than 1931, whereas it was flipped everywhere else. So they thought it must be an error. There's some doubt as to whether it was actually an error, but it was seen as a testament to the power of visualization and faceting in particular. You can draw graphs, dot specification language. Wilkinson built on Bertin and made it more computery. Again, studying how to break apart graphics into concise specifications. Okay, now 21st century. This feels like it's sort of like another dawn of the abstract plane. It's interesting. For the more recent stuff, I have a lot of these papers are about implementations, but I don't have ancient papers about like, figuring out how to make more colored dyes or about improvements in quill and papyrus technology or whatever. I'm sure it had to happen, but it's interesting how you have to have a lot of sort of technological work to make the new medium good enough that it can foster a creative explosion. We have sunburst chart, which is sort of the radial version of the Cartesian icicle plot. And then in 2000, this dissertation, Polaris, is a lovely kind of concise, interesting dissertation, and it grew into the company Tableau. I'm so look up on YouTube sometimes the Tableau user conferences. Maybe one day Observable will have as big a stage, but it's such a like arena rock atmosphere sometimes, and they've got all these like pumping lights and whatever, and it's incredible that this dissertation led to that, and they're so tonally different. Route maps. I really like this paper because if you're in a new city and you ask your friend like, how do you get to the supermarket? Back in the day, they could just draw sort of on a napkin. You take a couple turns, and in a person drawing that napkin map, they do a lot of work to prune irrelevant information, and they're only showing you the streets, the intersections, the turns, the landmarks that really matter. This was an attempt to sort of claw back to that from the comprehensive computerized map space and sort of recapture something we realized we had lost in the transition to computer graphics. Our own Robert Cassara experimented with using the blurriness of something as an encoding channel, which I think is interesting because blurriness has been around forever, but it was not practical. I don't know, maybe it was a lot harder to draw blurriness before computers. So it's a graphical form that the computer might unlock. And then this you might recognize because 5 years later, it became the default wallpaper on the iPhone. This 2002 version of the Blue Marble by Rob Simon and Reto Stockley is interesting because it's not strictly a photograph. It's somewhere between a photograph and a map. It's a composite of 4 months of light data with some tweaks done in Photoshop. If you animate zooming out of Boston and going across the US and zooming into San Francisco, a lot of math has to go into that. This is a paper about that. Brett Victor wrote that information software should be approached as a graphic design project, a great testimony to this, the fusion of the information design and the interface design lineages on the dynamic computer display. Jeff Hare and George Robertson did this paper on animations and the effectiveness of animations, the effectiveness of staggering them, of object constancy, so you can track one point over time. Lee Byron pioneered the stream graph. partly for this 2008 New York Times piece on box office revenues. Also interesting because it's sort of just like a stacked area chart, which we've had for a long time. But it's a little harder to compute, make it smooth and nice. Yeah, I love this one. You can hear the video playing. This combines visualization to play little tones. My friend also pointed out it starts like it sounds like the start of Shimmy Shimmy Ya, the song. Beautiful fusion of senses. And then in 2011 we have D3, Changed My Life. Won't talk about it a lot right now, but it's interesting in that it's not really in the Bertin Wilkinson GG plot. We're about to get a GG plot. It's not really a grammar of graphics. It's more about transformation than representation. And part of that is this great sort of first-class support for updating information, enter and exit selections, and the ability to animate among those. Wrangler lets you sort of transform, like point to an example of something and then blow it out to a systematized rule, sort of example-based data transformation. And then ggplot is very much in the Wilkinson tradition of a grammar of graphics, which is where the GG comes from. And this is a pretty compact specification for that chart. That took a lot of work to be able to, a lot of cultural work over centuries to be able to describe an image like that concisely. The rainbow is a very old thing. So it's always nice to see that we can continue to innovate on it. Similar to Munsell, focusing on attempting more perceptual uniformity and not just cycling through like frequencies of light. Okay, here's audience participation. In the top two, which point jumps out at you? And then in the bottom two, which point jumps out at you? So in the top one, you know, the red point jumps out, and the red point here jumps out a lot faster for me than the circle jumps out among the squares, which is the topic is pre-attentive processing. Zan Armstrong visualized Simpson's paradox using comet charts. Jessica Hullman's team made hypothetical outcome plots, another thing that would not be doable before the computer. It's not like the fanciest animated. It's not you know, it's like just a line moving around, but it's a profound step forward for visualizing distributions. And she's not alone. There's also, you know, a lot of data journalist work in this around these years. Voyager says, why make one chart at a time? Because it's so cheap to make charts that you can make a ton. It's cool. I think with any new technology, you know, you try to use it for everything, and then you scale back. You know, you try to put uranium in your toothpaste or whatever, and then you sort of scale it back. And so in 2016, Archie Say of the New York Times wrote about why they were moving away from doing so much interactivity in some of their news graphics, partly because with every click you have to make, you lose a lot of the audience, and readers just want to scroll. Now, the visualization is based on our ability to see excitations of electromagnetic fields and making analogies to it. But it's not the only field. Electromagnetism is not the only force, and they're not the only waves. And rarely is the analogy in a visualization as profound as analogizing gravity waves to electromagnetic waves, as was finally achieved in 2016. And then finally, we have Vega Light, a lot like ggplot, very grammar of graphics based, but also working interactivity into that grammar and being cross-platform. And I'm going to stop there, partly because Observable started in 2017, and then I joined a couple years later, and I can't risk being accused of a conflict of interest. So I gotta stop 5 years ago. And that was about covering about 58 million seconds per second, a fast speed up. And I just want to point out, you can see kind of early manuscript era, then the printing press makes graphics reproducible. You get more aggregations, statistical stuff, lately a lot more hierarchical representations and things that would have been too computationally intensive to do before the computer. I think that if I can just contrast one thing here, the most striking to me about why it matters to put all these visualizations in a timeline is we can compare the Sankey diagram and the tree map. So if you think about the state of the world in 1898, here's a picture of a torpedo boat steam engine from that time. And if you look at the steam engine, it's like pipes splitting off and branching and merging back into other chambers and things. And then if you look at the pioneering abstract data visualization of that era, it's also kind of like pipes branching off and splitting and like coming together and conserved quantities. And then in 1991, almost 100 years later, you look at the structure of a microprocessor or semiconductor or whatever, at like this Intel processor, and you see these like recursive subdivisions. It's all rectilinear, it's space filling. And then if you look at Ben Schneiderman's tree map, it's also like rectilinear and space filling and recursively subdividing. And so it does seem like the material realities of each time inform the abstract visualizations that time begets. So now you can, next time you click an insert chart button in Excel or whatever your chosen platform is, now you can put them in order. And let me know if, I'm curious if there are any surprises in here for people, but that's it. Are there any questions? Questions?
Toph, that was amazing.
What do you think, Wayne?
Hey, that was amazing. And I'm impressed by the history of how far we come with data visualization, and especially with that synopsis you did at the end, comparing the Intel chip to that early on exploration of data. Mm-hmm. I'm also equally impressed with your research and depth you did to create the presentation. So give yourself a round of applause for doing that.
I can't give myself a round of applause.
You can.
No, I can't. No way. No way. I'll give that. Yeah, I can do that. I can do that.
All right. All right. We have a couple questions in the chat. And
what have we lost?
Yeah.
What have we lost along the way?
Let's go to that. Yeah. David asked, what have we lost?
Yeah, I mean, I think that Manish Agrawala's route map work sort of speaks to that. I think different visualizations are thoughtful in different labor spaces. And if you're drawing every point manually, you can be very thoughtful about every point. But if you draw every point inside a for loop, then it coerces them all into the same behavior. So it's easier to get kind of point by point thoughtfulness and nuance when you're drawing each one of them one by hand. And I mean, Milan Kundera wrote that the essence of the novel is largely ellipsis or condensation, what you omit. And when it's a lot of manual labor to make a chart, you also have to, it encourages emphasizing the salient aspects.
Nice. Thanks for that, Toph. I like Tim's question. It asks, if 2000 start a computer abstract, when does the next phase start?
3000. Just go up by
3,000?
thousands. I don't know.
It's going to
I think it would be hubris to try to break into computer 3 before try to do it in prospect instead of retrospect. I mean, it's also so arbitrary in retrospect. Like I was really just like, I gave this presentation to you and some others, and you guys were like, we need some like, we need to break this into some pieces. We need some rest points in here. But it's pretty arbitrary.
Awesome. Some great questions coming in.
Of all these charts, which is your favorite?
Yeah.
Oh, I don't have favorites. I don't believe in ranking.
Okay. All right. Let's jump to David's question. Wait a minute. No, I think we just asked that.
Thoughts on simulators? Yeah, that's a good.
Yeah.
I don't know. I haven't explored. There's a book, Cognition in the Mind, or something about ship navigation that I've wanted to read. MRI, that's a cool like mechanical way of seeing. It's something like you excite the water and then see how long it takes to settle back down. Is that how MRI works? My doctor friend tried to explain it one time.
Oh, and any potential with the metaverse?
I don't know what that is.
It's okay. It is okay. It is okay. So what surprised you about another question? What surprised you the most about when you put this presentation?
I feel like the contrast of, I think of, so like I have a sense of like basic charts of like line chart and pie chart and whatever being basic. But then I think of kind of like advanced charts, and like a Sankey diagram is an advanced chart. And a tree map is also an advanced chart. But those came about like 100 years apart. The tree map came like 100 years later than the Sankey diagram, and that was just totally shocking to me.
Got it. Awesome.
I was also interested that some of the earliest graphics were network diagrams, like for family trees, which I guess makes sense. And Wiltsey pointed out yesterday that sometimes they were like literally drawing, it looked like a tree. And then a lot of the recent work is also about hierarchies, but this time it's like recursive hierarchies, and hierarchies where each leaf has a quantified value that adds up to a whole.
Got it. Thanks for that. Nicholas asked, they might have missed heat maps tabled with color cells. Do you know which one of those came first? Do you know the first one of those?
Oh, yeah. I mean, Galton's didn't do it as shaded colors, but wrote the numbers in each sort of cell of a two-dimensional space, which I think of as pretty close to a heat map. But then there's the choropleth goes back to 1826. So we had the choropleth long before we had a heat map of abstract data on abstract axes, which is a theme. It's always like concrete stuff before abstract stuff.
Yeah. And the fact that I know you did a presentation, but the fact that it just scrolled off your memory is impressive.
What scrolled off my memory? None of this was, I have an external monitor with a lot of notes.
Got it. So speaking of scrolling, next question from Misha is, only all people want to do scroll point are the observable features which support visualization and animate themselves based on scrolling coming into focus? The idea, self-telling story.
People sometimes talk about scrolly telling as a term for these.
Yes.
And I think it's like quite hard to do on observable in the notebook interface. People sometimes embed observable notebooks and other things. Like this presentation is actually an observable notebook embedded on embedded via the runtime API, largely so that I can get this like scroll behavior of like the progress bar and the time progress bar and the timeline on the left and whatever. So I feel like we've always heard demand for more scrolly telling stuff. I'm sort of torn on it. I really like when things don't move too much when I scroll, but it's certainly effective but it's like the TV-ification of interactivity, because it serializes everything and puts it all on one dimension.
Wow.
Makes it like TV.
For a future observable meetup, I would love to have a debate or conversation between you and Olivia on storytelling. Because she
Yeah,
did a
totally.
lot. Yeah.
Totally.
So, yeah,
Well, I think I was finishing. I have to watch Olivia's talk after this because I was finishing up some things on this, but I would love to. I think it's, the novel, the story that there, serialization. I don't know. Yeah, we'll do that debate. I like it.
Okay.
I like it because I'm a fan of
Debate.
serialization. I think I'm inconsistent. I'm totally inconsistent. I think you caught me in a lie. I love a novel that's serialized.
All right. Awesome. All right, great. One more question. Maybe two more. Thoughts on where you find inspiration for visual metaphors?
Oh man, inspiration. Just muses, little voices, little bicameral. Where to find inspiration? I don't know if I've ever been inspired.
You have been inspired.
Inspired. That's a tall order to be inspired.
You've been inspired, totally.
I've been inspired.
All right. Okay.
I don't know. Just look at a lot of stuff. Just keep looking.
I love it. Just keep looking. All right. Last question before we jump to the next presenter. So let's talk about the future. So when's the Minority Report interface getting here? When are we going to have that?
It seems like we have it in some respects. I haven't tried VR stuff much. I think I'm sort of torn on whether it would actually be a good interface, whether I would want to use that. It would probably be good for like to be, it's like a standing, like Tom Cruise was standing, and that was probably very healthy for blood flow or whatever. We should be standing, and maybe so maybe it would be healthy for blood flow to have more Minority Report style interfaces, but
it's coming.
I guess so. It's interesting to think about like what it offers. I guess the field of view is much larger. Like a screen is the screen right now is about that big in my field of view, which is quite small compared to being immersed in a space. But Brett Victor has a great talk on seeing spaces.
All right. Well, I have a VR headset, and next time you come in office, or let's sync on the office, so you can explore that. Then next time you do a presentation about the future of visualization in VR.
Love it.
All right, cool. Well, awesome. Thank you, Toph.
Thank you, Wayne.
Let's give Toph some claps, some emojis in the chat.
Thank you.
Thank you for the history of visualization. Cool. All right. As we transition to our next speaker, we don't know if you noticed, but we have a little bit of a theme here. We've been talking about 5,000 years of graphics from Toph. We have history, and now we're going to transition to education. And I'm excited about our next speaker. He's one of our ambassadors also, and he's also working with our new community manager for education, Courtney, who's in the chat as well. And David is going to be talking about observable in the university classroom and research lab. David Kirkby is a physics and astronomy professor at UC Irvine. David, welcome to Observable Insight.
Thank you. Okay, so let me try and present here. Chrome tab. All right, great. Okay, so I'm not going to show kind of the normal PowerPoint slides. I tried to do everything in an observable notebook, which I haven't tried to do before, but it was actually really easy just to use the powerful import features to just build a presentation that really has all the interactivity and lets me kind of touch lots of different expose lots of different things. So as Wayne said, so I'm going to talk about how I've been using observable in my classroom and also in my research. So just I'm David Kirkby. Here's a picture of me. I was born and grew up in the United Kingdom, in England. And if we zoom in a bit, we can see where I was actually born. You have to zoom in quite a bit. It's one of the smaller places. There it is, Cambridge. That's where I was born. And I lived a bunch of places in England, most recently in Leeds. I moved to Canada and spent a lot of time in Toronto and a bit of time in Ottawa. My first exposure to Observable was really just for personal projects, nothing to do with my teaching or research. I like, for example, mathematical designs. So one of the first projects that I did was working on a design for a quilt. And this is actually a design based on something called the Penrose tiling, which is cool because it's aperiodic, which means that the tiles never repeat. So actually here we have a slider and we can zoom out, and it doesn't matter whatever scale, however big you make this design never repeats. And so I actually made this quilt. So here's an actual photograph of one of the designs. So I really turned this from software into, I guess it's still software, but more hardware. Another kind of personal hobby is I worry about my blood pressure. So I've been getting blood pressure readings and putting them into Observable to analyze. So one of the things I learned is there's a pretty large spread in your blood pressure, just kind of normal body heart cardiac function. So it's spread, it goes all the way from things which we considered low to stage 1 or even stage 2. The coloring of the points here shows that I definitely have lower blood pressure in the beginning of the day, the black points, and then tends in the middle of the day is when it's highest, and then it's kind of around the middle at the end of the day. But I didn't find any correlation with my heart rate. So it's an interesting point. I'm a professor of physics astronomy at the University of California in Irvine. If you're not from California, you maybe haven't heard of Irvine. So it's kind of between Los Angeles and San Diego. There it is, Irvine, not too far from the border with Mexico, nice and close to the coast. And then I'm also an Observable ambassador, as Wayne mentioned. So what I'm going to do is just give you kind of 2 brief case studies, one focused on teaching and one focused on research, just to give you a flavor of how I've been using Observable in both of those settings. So first, I'm going to give you a quick tour of some interactive materials that I developed for undergraduate course in cosmology, so kind of the physics of the universe. So the fundamental building blocks of the universe, I'm throwing you into the deep end here. This would normally be a 10-week class, but just to kind of give you a flavor of how the students are benefiting from Observable. So the fundamental building blocks of the universe are atoms, dark matter, neutrinos, and photons, which is just a fancy word for light. And although those are not created or destroyed as the universe evolves, the relative importance of them changes quite a lot as the universe expands under the influence of dark energy. So the first thing, whenever we're talking about the universe, the first thing to grapple with is the universe is expanding. So that's kind of represented here. So we see as cosmic time evolves, so here we're spanning about 14 billion years. Any volume in the universe represented by this cube is just smoothly expanding. Okay, so the stuff in the universe is embedded in cubes like this. So we can turn on some stuff. Let me just move this up a bit. So let's turn on some atoms and dark matter. As the universe expands, they're basically just frozen in the expanding universe. Also turn on some neutrinos. They're moving around slowly. And then the photons, there's a lot of those, and they're moving around really fast at the speed of light. Okay, so this is one thing that the students work with, is really being able to just interact with this 3D, well, it's 4-dimensional because it's also, we're representing cosmic time representation of the stuff in the universe. Then what's interesting, though, is to really understand how the stuff in the universe that I talked about is going to shape the past and the future of the universe. We have to solve a set of pretty messy differential equations. You can't even solve them analytically you have to use numerical algorithms. But that's a lot of work, and it's really mostly just math and computer science, and it doesn't give you any insight into what's going on in the universe. And so instead, the way I start my students on this journey is just giving them an interactive way to explore the solutions to these messy differential equations, and that lets them very quickly see the big picture before diving into the details. So the way to really summarize the big picture is with a pie chart like this. So here again, we have a slider that represents time. And so this shows you a snapshot of what the universe is made of today. So it's mostly dark energy. There's also some dark matter. And then there's a relatively small amount, just about 5% of the universe is made of atoms. So atoms, I mean, that's you and me and our cat and your laptop. So pretty much everything that we've ever had any experience with is represented in this tiny little 5%. So in cosmology, we're mostly interested though in the other 95%. But what's fascinating is that if you change this slider, solving those equations tells you that as you go back in the past, really the proportions of things changed dramatically. So at one point it was about the universe was half dark matter. If you go back further in time, then it was almost all dark matter. So that's the era of the universe that we call the dark matter dominated era. So that's about 1.5 billion years after the Big Bang. If you go back even further in time, then what this tells us is that the photons, the light, and the neutrinos were actually dominating the universe. So right after the Big Bang, the universe was really driven by these photons and neutrinos, the things that were moving quickly in that expanding cube. And of course, it's fun to also reset to now and say, well, what's going to happen in the future? So we can also just go forward in time, and we can see that our future is a little bleak, actually. I mean, here I'm talking about 10 billion years in the future, so don't worry. But it's going to be, the universe is going to be completely dominated by dark energy. So the students, without having to grapple with the equations and solving them, can just directly, just by playing with this visualization, which has all of the math built into it, they can really get a feel for what the universe was like in the past, what it's like today, and what its future is going to be. That's just one example of kind of using observable visualizations to really bring this material to life and kind of jump over a lot of the complex math to quickly understand, to get the big picture before diving into the details. So you really have some context for why you're doing it. Okay, so the second case study is, I titled it, Are the Robots Healthy? So this is based on how I've been using Observable in my research. So I've been developing a lot of tools for helping with my research. And in particular, one of the collaborations that I work on is something called the Dark Energy Spectroscopic Instrument. I put a link here in the notebook. We just call it DESI, D-E-S-I. So this is using a telescope at the Kitt Peak National Observatory. So you can see from the map here that it's about 100 miles west of Tucson on this highway. If we zoom in, we can actually see here, this shading shows you this mountain range. So it's actually in this mountain range here. And there, it's right on the summit at the end of this long winding road, which unfortunately a few months ago this whole area was overrun with a large forest fire. And we still haven't recovered from that. We still don't have any internet service on the mountain. So we're actually using Starlink satellites to do all of our observing right now. So my day usually starts by checking on the health of 5,000 robots that we use on the top of this mountain. And each robot's job is to position a single optical fiber and to precisely position it on a distant galaxy. So when the fiber looks through all of the optics of the telescope, it's going to collect the light from a distant galaxy or quasar each night. And so I basically, as soon as I wake up, the first thing I do is check the health of these 5,000 robots. So I've been using Observable to help with that. Here's a picture of what these robots look like. So each one of these is a robot, and they're pointing up towards the sky. And so each one of these will be picking out just one little dot in the sky, a galaxy or a quasar, and to collect its light. Here we're kind of looking at the robots from the side, but if you imagine how the robots look like to the sky, this is kind of roughly what they look like. So they have two tiny motors, and this is an observable kind of a simulation of how they move. So they have you can rotate them like this, and you can also, they have an arm that will extend, and here I can extend this one over here as well. And one of the challenges of these robots is that as they're packed closely enough that they can actually bump into each other. So that's what's happening when this goes red. This is telling you those two robots are actually gonna collide with each other. So that's bad. And can have even more serious collisions over here. They can really jam into each other. And so that's what I'm doing in the mornings, is just checking to see whether that's happening. We have complex software that choreographs the motions of the robots so they don't collide with each other. But it's not perfect because there's networks that we're having to communicate with all five. Each one of these robots is basically an independent computer, and so things don't always work perfectly. So an example of a tool that I was able to build with Observable is this one here. So this is what I look at every morning. So this is showing me the state of all of those robots. So we're looking at it kind of from the sky view. So each one of those little dots is a robot. So this is, there's a lot of information that's packed in here. So there's actually two photographs that are overlaid. So I can turn those on and off. Then we can, there's also a lot of data that's being overlaid. So all the orange circles shows me robots that have problems. And there's one red one. So there's obviously a new problem there that I need to drill down and understand. And so here I can just zoom in on and see exactly what's going on. As we get closer in, we get some more data overlaid. And so this is proven to be a really powerful, Observable is a really powerful framework for building these type of visualizations. I never would have attempted something this ambitious, without having observables and the libraries like D3 that it makes it really easy to use. So that's really been very very helpful. And then we can even simulate looking. I didn't include them here, but there's sliders. You can actually move the robots and see what happens. This, you might be thinking this looks like a pretty awful photograph. Why can't we afford better cameras? But that's because the length of these feature here, this is only about 3 millimeters long. And because of the way the telescope's set up, we have to take this photograph here from about 12 meters away. So it's actually, these things are very tiny little features. They're only hundreds of pixels long in the image. So, okay, so I went very quickly through two examples of one in how I'm using Observable for my teaching, another in how I'm using Observable in my research. If you're interested in more, I have all the notebooks that I'm using are organized in collections, so you're welcome to browse through those. But just I was kind of thinking about, well, what are the common features here? And I think one common feature is that in both cases, I'm exposing Observable, but not to people who really want to use Observable as developers. I think it's important to remember that although Observable as a platform is very useful to a large group of people, there's an even larger group of people who can really benefit from effective visualizations that Observable enables. And so both of my audiences here, the students in my classes and my research collaborators, they're people who are not familiar with JavaScript in general. And they also don't really want to see how something was built or tinker with it, at least initially. Right? I mean, really, the main message when I show the students a pie chart of the universe is, I don't want them to see how the pie chart was built. That's not really the point that I'm trying to get across. And so, the excellent Observable Notebook interface, although it's essential for me, and I wouldn't be able to do these things without that, it's mostly a distraction for these audiences. But I think another really important point about Observable is that it's very flexible and powerful in the ways that you can export and embed things. So generally, what I'm doing is using the export menu to embed styles in a standalone web page. If all the data that it's using is public, so like for my teaching materials, and I'll usually host the website on GitHub.io, the GitHub Pages mechanism. In my research, often the Observable is actually exposing data that's proprietary, so it hasn't been publicly released yet. So in that case, I'll host it on behind a firewall that has access to the data. So those now my research community is people doing cosmology, or more generally astronomers like me, and I think it's clear that they could really benefit a lot from Observable. But I think the main obstacle and the reason there hasn't been much uptake is, first of all, as a community, we're very invested already in the Python Jupyter ecosystem. But also, I think people are largely unaware of what Observable offers. So one of my things I've been doing as an ambassador is to really try and change that. And I developed kind of an astronomy-focused tutorial that I've given now over 100 people have seen. So gradually kind of trying to get the word out. But there really is a problem that the word hasn't really gotten out to a lot of the scientific communities, though. Okay, so I will stop there. If you're interested in diving more into any of the material that I showed, you can see all the imports down here that I used, and I'm happy to take any questions.
Awesome. Thank you, David. And thank you for helping get the word out. We really appreciate it. And great job of being an ambassador. Yeah. And got a couple questions from the community. And thank you all for the questions as well. Let's jump to end the questions first. Do students develop their own observer notebooks over time?
No. So right now, I mean, if I'm teaching a cosmology class, there's no, they would never even see the notebook. They would only see the web pages that I build by importing cells from the notebook. So they're completely insulated from that. I will actually in the spring be teaching a programming class for scientists, and there I'm actually planning to really have the students use the notebook as a environment as a primary part of that. So.
Awesome. Thank you. Again, I think you know this, but let us know if there's anything we do to support you on that as well. Let's jump to the next question from Noble. So what drives change over time is more points of observation? I think, is it more interesting to see the effect and dimensions of the time series and pie chart from what you showed earlier?
Oh yeah. So so what drives change is really it's when the universe expands, you're not changing the number of atoms or dark matter particles in each square cubic meter, but their relative importance is changing. In particular, all the light that was whizzing around, as the universe expands, it becomes redder and redder, what we call redshift, and that means that it loses energy. So its influence, because really it's energy that drives the expansion of the universe. So the universe is not sort of just expanding on its own. It's really, the expansion is driven by the different sources of energy that are in the universe. So yeah, so there's kind of this interesting feedback, and that's why you have to solve some complex differential equations. It's kind of like population models. You have this feedback between the environment and what's in the environment. So
nice. Thanks for that explanation. This question from Nathan. How are you aligning the positions of the vector graphic representations of the robots with the photograph?
Yeah, that's a good question. So it's actually a little complicated. In fact, that's kind of a general problem with the experiment, because we know precisely where things are sort of in millimeters and microns, but then you have to map that to the pixels the photographs, and then also the pixels in the kind of observable representation. But it just takes it's just kind of doing the bookkeeping to keep track of. It's basically using D3 scales, which allow you to, for each one, you can specify a domain and a range. So as long as you get those right, then. But yeah, there are kind of different systems. There's the physical millimeters on the actual instrument. There's angles on the sky, and then there's pixels in these images. So there's a lot to keep track of. But it's fortunately, things like D3 scale make that they take all of the hard work out of it, and you just need to think, what is the domain and what is the range?
Yeah, nice. I like the depth that I like the approach you go around, with all the moving pieces you have with the proprietary data, the notebook, the research, the photography work. It's a lot that you're bringing into a notebook. So it's very complex. Let's just next question from the community. Does it confuse your students if they accidentally expand the code part under the cells? He says, I'm always afraid of confusing people with that, especially if they do not know how to collapse it again.
Right. Yeah. So it definitely would if I allowed them to do that. But that's why that's why I don't send them links to the notebooks themselves. I'll always export the notebook. And it's really, if you haven't tried it, it's really simple. I mean, really just doing the export, it kind of gives you a bit of HTML that you can cut and paste, and then that basically just works. And then if you want to customize things, you have to do a bit of editing. But it's as long as you have somewhere to host the website. And as I said, you can use GitHub. The GitHub pages is always a good starting place. So.
Yeah. I believe you mentioned the embed feature that we have as well. Have you used that often?
Oh yeah, I use it all the time. So whenever I want to, for teaching material, I would always embed things into a separate web page. Yeah.
Nice. Yeah. Another question from the community. Mario asks, are there any publishers using online content or notebooks to complement their textbooks?
I'm not aware of anyone using Observable. Most of all kind of the money in college textbooks are for the large freshman classes. So for example, large freshman physics classes, which my university would have 1,000 students each year. So that there's a market there, and the publishers have they do invest in online materials, but they always seem to be at least 1 or 2 generations behind. So they're still using Java for a lot of stuff, and So I think there is. I mean, Observable would be great for that, but I think they're.
Yeah. Agree. Thanks for that. And similar, connected to that question, is another question for the community. As a scientist, do you see Observable platform having a chance to become an alternative to publishing results? The more usual article in a science journal?
Possibly. I think again, it's a little bit. The problem is that the publishing is really, a lot of it's in the hands of the publishers, and they're kind of invested in other alternatives. I think there's a real opportunity to have much more compelling publications by basically, if all the figures, you could click on them and it would open an Observable notebook, and all of a sudden they would come alive, and you could really see what was going on and try things that weren't, there wasn't space to present in the publication. So I think that could be really exciting. And I think that is happening because the funding agencies that are paying for all the work that goes into these papers are starting to now require that all of the, any plot you put in a paper has to be reproducible. So there has to, people basically have to be able to access all of the data points that went into a plot in a machine readable format. And so I think the natural evolution of that is to really, to have people, I think it'd be great if you could just have a link to an Observable notebook, or maybe something a bit more of a machine, like a file standard like a Vega Lite document or something like that. But
Awesome. No, thanks for sharing. That's some interesting insight on that insight. But yeah, cool. But David, you continue to blow me away with your research and data. This is second or third time I see you present, and it's awesome to see. And good luck with teaching your course with your students, and just thank you for being at Observable Insight today.
Yeah, thanks.
Great. And I see Courtney's in the chat. Reminder that Courtney is our community manager for education. So if you have any questions, feel free to reach out to Courtney and go from there. All right, as we move along throughout the day, and I love the diversity in the talks we have throughout Observable Insight. Now, yesterday we kicked off Harris on freedom of the press. We've had visualizations on dashboards. We talked about history of data viz. We talked about Waterlines. And next, we're going to talk about making it personal, visualizing the current state of access to assisted reproductive techniques in Europe with Observable. From Carmen, it was data visualization at Civio. Next is Carmen.
Hi everyone. Thanks a lot for inviting me to this amazing event. Thanks to the Observable team. My name is Carmen. I'm from Spain, and I really enjoyed all the marathon talks of yesterday. They were super inspiring. I would like to talk about making it personal, and I will be traveling through the creative process of one of my favorite database pieces made in Observable. But just to give a bit of context, I work at Civio, which is a small journalist organization specialized in public data. What we do is monitor authorities through journalism, technology, and advocacy. On the right, you can see some of our favorite projects. In the technology side, we do charts and maps to help journalists tell their stories, but we also do small applications to help people see if they have the right to access to any public subsidy, or so we have these two areas. On the database side, this is our toolkit. I should mention that I don't have a background in computer science or anything related. I study architecture, but I was always in love of database, maps and database. So 3.5 years ago, I decided to study web programming, and I was lucky enough to start working at Civio, where they were using D3 in all their work. So I've been working 1 year using Observable just to prototype a few things, but at some point I decided, that I love it so much that I really wanted to use it from the beginning to the end in many of our projects. I really, I don't know, like I experienced such a jump in my learning process using Observable on a daily basis, like learning so much from the community. So I really love it. The joy of coding appear. Here are some examples of my work that are some articles related to the reading of the Daily Gazette of one of the journalists in my work, and also some other database pieces related to preventing detention in Europe, or the backlog that it was in asylum applications in Europe as well. Sometimes we have this European context. Also some other examples of public procurement, which is one of our favorite areas. So we are publishing articles related to this like frequently. Another series, those charts are part of a series about mental health in Europe, which is one of my favorites as well. Some of them are done in Observable, and others they are done outside Observable. One important thing is that we tend to work in series. So we choose our own topics, and then we go through usually through a European mapping of the situation, and then if we discover something interesting, then we have another article related to that, and we always finish our series studying the Spanish situation, like in detail, what are the differences between the regions and so on. And that's exactly what happened in this topic, in this series about assisted reproduction. We started with Europe, then we moved through movements of people between countries related to the legal restrictions, so as a consequence, and also movement of gametes. So, and then we have like a final piece about Spain, which was more in detail. But let's start from the very beginning. So the journalists were researching information about this topic. Sometimes we need to create our own data sets from scratch, but in this case we found this society that has published this paper and has performed this survey about the situation in Europe that was super, really like complete. So we extract from that research all the tables that were like this, like many tables. So from the different countries, you could see, depending of the technique, because we have two main techniques, like artificial insemination and in vitro. Depending of the technique, you could have between 2 and 5 sub-techniques. And depending of that technique, then you will have access depending of your age, but also depending of your personal situation, whether you are in a heterosexual couple or you are alone, with no relationship, or you are in a female couple. And that was really, really key for us. Like this, depending of you, like really personal situation, if you have the access or not for this, and all the discrimination around this. So our first explorations were really while the journalists were interviewing people. I was super lucky that I was able to be in all the interviews. So I think this is why this is one of my favorites as well, because I was along the whole process and I was shaping the database as long as we were discovering things, not just from the data itself, but also from the interviews with the NGOs and the experts. And in the very beginning, I found this piece that you may know from The Guardian, which is, does the new Congress reflect you? On it, you need to pick your gender, your ethnicity, your age, and it shows whether there are people like you in the Congress or they are not at all. So I really love this project, and I really love how all the projects that are humanizing data, that are not treating data as just numbers, but as people, and that put you in the center, that you could project yourself or see yourself reflected in what you are reading and trying to understand. So that was key for us. I also like it because it was also a way of simplify the data a lot, to filter it from the beginning. And I was, as I say, just thinking about how we could transform all those matrix of data into something that was understandable at a glance and engaging with the audience. I don't know. So I have from the beginning quite clear that I wanted like a personal avatar or so, and that I would love that to be with you like all the way through the visualization, where you will choose your personal situation and your age, and then the different parts of the database. I wanted to have like a clear, quick view through a cartogram because I love them. I like how they are more like diagrams than maps, but they also keep like the geographical patterns on them. And we also needed to interact with this cartogram to pick the different countries, the countries you were living or any other that you are curious about, to display like detailed information about this topic on this, because that was a lot of information to display. So I like this idea of organizing the information, and we also decided to have like a big first part of legislation, so whether it's legal or not in every country, and then another part about public funding, because the economic cost of all those treatments are super high. So that's another big barrier, even if it's legal. I mean, so I started to design the cartograms of the countries that we had, and also thinking about how to, as I say, how to split the information in different steps, which kind of small infographics we will need to, I don't know, to make everything as simple as possible. Here are some of the first really ugly notebooks that I made, trying to read the data sets, the different tables, and just to see if I was able to interact with it. Also, so helping working with the journalists to structure the data in a way that was useful for us. And let me show you, after some iterations, what was our final database. So let me see. This is the article in English. Here you can see an introduction about the different techniques, and then we have like a important part of separate cartogram about what happened with trans people, because they are suffering even more barriers. So we need like to display something like in advance before the big piece, because in many countries they are having troubles. They are not allowed to even go through the different further barriers, and also in many other, there's not even, they don't have a legal status. So it's like a very, very difficult situation for many people. So we did this piece, and then we were explaining about also the age, which was a legal restriction in many countries. And here is the piece. So as I explained before, you will see this like 3 columns, like the avatar, which is following you along the piece. You can click and select your situation. And then we have these cartograms that give you like a first overview of whether you are allowed or not. And when you click on the different countries, you could see like the detailed information, some notes about particular aspect of what's happening here. You also have some selectors. So in this case, you always can go through artificial insemination to in vitro. So for example, if we go to artificial, which is the simpler technique, you could see that if you are a heterosexual couple, things are pretty easy for you in Europe. Just in some countries, you will have some issues with some sub-techniques, but in general. But the situation gets worse if you are a single woman, which you could see how the situation is quite difficult and different in in many countries for both techniques. Things are even worse if you are in a female couple, where in most of the countries we have researched, you are not allowed to go through these techniques. If you go down through the story, then you could see another step, which is your age, and depending on your age, you could see how, let me go further. Yeah, so you could see how the different countries have different limits. For example, let's keep going. The next one, it is the other big block, is public funding. As I say, economic cost of those treatments is super high, so we were really interested on this as well. And here you could see like there's like a much narrower range of your legal age. So let's go a bit here. So this is my case. You have also some dots in some countries. That means that there are some extra restrictions. So, for example, it could be depending of if you have children before or not, or maybe, yes, there is public funding, but there is like a co-payment of 30% or so. I want to mention as well that in some countries, for example, in some cases, you could see that for this topic related to the age, you are allowed, but if you have been banned in previous steps, for example, here in the very beginning, so being for your personal situation, being a female couple, you cannot go through. So the database will show you, okay, with this, but remember that there's something wrong before that is not gonna allow you to access. Just to end with the visualization, there was this last step about the number of cycles, the number of attempts that the government will allow you. So depending of the country, you will have like one cycle or 3 or even unlimited unlimited cycles. So this was the main database, and then we have also more information about the public funding system because they are very different between the different countries. A small cartogram about the number of babies born with assisted reproduction. That Spain, we are in the first place. And then if you are interested, you could read our methodology, which here we will explain everything about the data set that we also updated one by one, many countries. So because this is really changing like very quickly now. So we try to update with our partners in the different countries. We try to update the data set. And we also have, we also release the data, so it's accessible for other journalists. So we encourage other journalists to create their own stories based on our data. Let me go back to the presentation. Yes, I would like to talk a bit about the workflow behind this piece, because as you can imagine, it wasn't that simple. I had already experience creating database in Observable, but in this case, because of the complexity of the data, I really needed something more like in pieces, like components. So I needed an avatar, I needed cartograms, I also needed detail, like small infographics, small elements that will help understand what was going on in detail. So this is our collection of notebooks that are our that we created for the piece. This is how it works. So we have 6 different notebooks, and they all go into a big notebook that I will show you. I think it's easier if you see it. So here is the notebook that has all the small notebooks. Here is the avatar, which is one of them, and the other 5 are here working all together in this cell, which is an HTML cell, and this is just reading all the imports. So if we go, here are some styling and dimensions. Here are all the imports. So for each notebook, I am saying like, okay, so for example, for the cartograms, which is here apart, we have this first piece, and then we have this other. So the data set related to the access in those countries is here in this notebook. So if you change the personal situation, it will change, and the technique. So when we import this in the main one, we are saying, okay, now the language is the one that is speaking here. The personal situation is the one that is saying this avatar, and also with the age and so on. And like that with all the parts. So all the pieces, this piece, and we also have those selectors are the ones that are ruling the piece. Just a quick note about responsive. It works like a Flex. It has some Flex CSS rules, so it was working well in mobile. And this piece is integrated. These 2 parts, the avatar and the main piece, are integrated all together in this other final, like the final one notebook, with something that is simulating the sticky positioning. So here is what you will see already in the article, and it's based on this implementation made by Fabian, which it was super kind to help me when I was having some troubles with the functionality. And this is exactly what I want. It was really good enough, and also it was working with iframes later on. So let me go back. I don't know if you have any that. Well, something that maybe I should mention is that. Let me find myself. For example, the subtechniques notebooks are using, I wanted to, in those cases, I wanted to design the SVG part as an static illustrator because I thought it made more sense. Then I'm following this notebook by Mike, is manipulating the SVG after importing it as a file attachment. So what I did is create those the shapes, not the text, because the text depends of the dictionary, but the shapes are made in Illustrator with in a way that they have an ID of what they represent, and then I'm following that Mike reference. I'm using them, manipulating them, and even you could animate some parts or whatever you want. I thought it was maybe useful for the community that are more that come from the design side, so you could still mix techniques and find your own ways of doing things. So let me go back to the presentation and just finish with the last part, which is the internationalization process. because usually we work with, as I said before, with partners from different countries, and we always want to publish our pieces in their languages as well. So in this case, we did it in 5 languages. The way we found for doing this in a very simple way, let me show you better, is we follow the embedding process of Observable with the JavaScript runtime. And then what we do is we create an index HTML, a repository where we copy paste what is there. And what we do is this repository creates an URL, and we put parameters, URL parameters in the URL to override some cells. So, for example, the languages in our notebook, it was always a cell called language selector. But when we call this URL, we say language equals Greece or something. So then it's overwriting, it's redefining the language selector cell, and it's showing the content in Greek in this case. So this is a super useful way of having just one notebook with different parameters, and then when you embed your pieces, you could override things, the language, the colors, even, I don't know, some things about the data set. So it's quite flexible. I really encourage you to see the advanced embedding techniques which are here in of the documentation of Observable. The last part is that I create some code snippets for the other partners, because sometimes their websites, they don't have the ability to take JavaScript, or I don't know, their CMS, they need just an iframe. So we give them iframes, but as iframes are a bit tricky for responsiveness, I have found this technique of creating some CSS rules of media queries. So depending of the size of the device, the iframe is having like a fixed height or another one, and it's working really, really well with them. So this is like real example of the code that they copy paste in their websites. Yeah, so for example, this is a piece in a Italian website, also in a Greek website, which is always my favorite because I love the characters there, how they look beautiful. And yeah, I think that's all from my side. I hope you find it, interesting. And if you have any doubt about any part of the process, I will be super happy to answer it right now. So yeah, you could also write me through Twitter or email. And yeah, thank you all for attending here.
Carmen, wow, just wow. That's all I gotta say. Like, wow. Thank you for the amazing talk. Thank you for walking us through the whole journey, giving us the background, showing how you use Observable. Just wow. How do you feel after watching that now? How do you feel about putting it all together and so forth?
Embarrassed to see myself talking, but
oh, you were great. You were great.
But yeah, with a wine is better. Like, no, I mean, yeah, it's really nice to see the whole process from the very beginning, no, from the first sketches in the notebook to the really end. So I really enjoy traveling through that process of. I think it was like a couple of months or so that it took us for the beginning to the end. And it's always nice to see the whole, look back and see the whole process. Yeah.
Awesome. For the community, any questions you have for Carmen, let us know. Carmen's here to answer any questions in the chat. And but I'll follow up with I've been asking this question throughout the day. It's like after you've created this amazing data visualization, and you went through this process, and you now think about everything you learned. How will you do it differently if you would start today?
I don't know, because I think every project that I made is like an opportunity for learning something new. So I don't know. I like to explore, to take each project as an opportunity for exploring a new technique. Or in this case, I was really like excited about if what I had in my mind was possible with Observable. This idea of having small components and work on them, like from the beginning they were really ugly, but they were working together. So I don't know, I had this, like, I really want to push a bit my own limits with Observable and see if that's possible. And I was also interested in this, creating some static illustrations in Illustrator or similar vectorial software and manipulating after that. So that was my two, and also this sticky avatar idea that I wasn't really optimistic in the beginning, but then I saw that notebook and I was like, this is really what I need.
Yeah.
So I don't know. I think then on a new project I will try to explore different things, and so
Awesome.
always learning.
Yeah, and great. I think that's a theme of insight from going from yesterday to today. Just thinking about how people say just get started, just learn, and continue to just create your visualization. So thanks for sharing that.
Thank you.
Yeah, people just Juan mentions amazing work. Thanks for sharing. I do want to ask this question, because you mentioned you found several notebooks on Observable, to use creating your project, from Mike's to Fabian's. How will you say that it's just a plug for the Observable community, but how would you say that the community has been helpful, will help you find resources to help build your visualization?
The community is amazing. I just encourage people to be part of the community, because I just found people helping like each other all the time and suggesting improvements. And I don't know, I always have so many kind replies and responses and helps. So in this, I will really encourage anyone that is interested in learning and to just go through Observable, because the amount of amazing things that are daily happening there, and the amazing community that is behind, and it's always like there to help you when you are stuck, and it's so easy to share your notebooks when you are in work in progress and really fighting with something. And yeah, it might be someone there that is gonna help you. So in this case, I feel really lucky to be part of the community, because it has been really helpful, like always.
Thank you for sharing that. And we're lucky to have you part of the community as well, inspiring us and giving us feedback and showing us new things we can do with our frame and so forth. In embeds, but thank you as well. Awesome. Well, Carmen, thank you for being an ambassador. Thank you for presenting Observable Insight. I'll see you in Slack, and have a good rest of your evening.
Thank you so much.
Enjoy your wine.
Yeah, I will.
All right, cool. Amazing. Thank you all for the kudos for Carmen, making them feel welcome in the community. Thank you for our team and the entire community for supporting Carmen and others as well. Because of you is why we're here, celebrating and doing this collaboration together at Observable Insight. And we're going to carry on. And we have this theme of education on day 2, and I'm loving it. So next up, we're going to continue to talk about Observable in higher education, and talk about institutional research use cases. So we can bring to the stage Sara. Sara's a senior data analyst at UC Berkeley.
Hello, and welcome to Institutional Research with Observable. My name is Sara Quigley, and I lead the institutional research team at the UC Berkeley's Graduate Division where we collect and analyze graduate student data in support of institutional planning, graduate program review, and external compliance reporting. And we also respond to ad hoc requests that come in from across campus. We use Observable for many things, but today I'm going to describe only 3 of them: data transformation, dashboard development, and ad hoc analysis. While data transformation is generally an integral part of dashboard development and data analysis, it's very foundational to our work, so I wanted to highlight it on its own. Before we jump into data transformation, here's a diagram of our basic data workflow. We often are interacting with FERPA protected data. FERPA is Family Educational Rights and Privacy Act. And so we must protect student privacy. So we make sure to either load our data locally from a shared repository such as Google Workspace, or via a Berkeley instance of AWS to keep the data within our systems. So on the left here, we've got some files that we're loading, and in the area that's contained by the blue line, that's where we're mostly using Observable. We use Observable to load the data, and then we transform it, validate it, and then we export it either into a shared notebook, which we may share with a few individuals within the Berkeley domain. It may be imported into one of our program dashboards, which I'll show you later. Sometimes we have to export to a reporting template, like an Excel template for some external reporting to the Office of the President or to the federal government, et cetera. And then, the ad hoc request may just ask for a data set, which we might share internally in our own data repository. We typically don't have access directly to like a ODBC connection in a database. So otherwise we would be using the Observable feature that's the SQL cell, which looks really cool, but maybe sometime in the future. So instead, we rely heavily on a library called Arcaro, which is wonderful. And it was created by the University of Washington Interactive Data Lab. It was inspired by the dplyr library in R, but personally coming from SQL and JavaScript, I find it very intuitive, and I feel very powerful when I'm using it. Arcaro is a JavaScript library for query processing and transformation of array-backed data tables. It also refers to Goalkeeper, and they recommend that you safeguard your data from analytic own goals. I can relate to this because I recently broke my arm trying to play goalkeeper against my teenage daughter. So I won't be doing that again. So when I'm loading files and needing to transform data, here are some of the most frequently used verbs that I use in Arcaro. I just want to emphasize that this is an extremely small subset of all of the features that are available in Arcaro. I recommend you check it out. But this is a small fraction of what you can do. So you can join data in by a set of keys. So join many files together by student ID, for instance. I often impute missing values, particularly with like time series data. Always deriving new fields from old fields or other variable values. Definitely need to filter my data, folding it into key value pairs or the inverse, pivoting into key values the other way, and then rolling up data, which we often use to display in our dashboard, counting, summing, group by, and using other aggregate functions that are available, such as mean and median, etc. So we have 4 different dashboards that we've built for our 4 different programs that we have here at Berkeley. So we have many programs, but they're generally described in 4 different categories: doctoral programs, programs that end with an academic master's, professional programs such as the MBA, Masters of Business Administration, or the Masters of Public Health, MPH. And then we have a special category, self-supporting program, which is a UC system designated term, which means that it tends to serve more non-traditional students and using non-traditional modes of instruction. So the evening weekend MBA, the executive MBA, and the online only Masters of Public Health would be examples of those programs. And so here I'm illustrating how our dashboards are organized in Observable. In addition to the 4 dashboard notebooks themselves, we have 3 helper notebooks. So on the left here, you can see the data that we're loading into the data helper notebook, which is loaded from AWS. And then we provide that data to the chart helper or the survey chart helper notebooks. That's where the chart helper notebook is where we have some configurable, reusable charts that we create, and then we can call those charts from the dashboard notebooks. And there's a separate survey helper notebook, which we put together an API that's needed for visualizing responses to Likert type survey questions, as such as diverging bar charts, things like that. So let's hop on over to the dashboard itself. Okay, so here we are in the dashboard notebook. This is the doctoral program dashboard. We have some quick links at the top to the different sections that you can quickly jump to. I'll just walk you through it quickly. So we have, like I said, many programs just in our doctoral category, but I'm going to focus on the defense against the dark arts in order to protect student data. And so here we're seeing the admissions data, students who applied to the Defense Against the Dark Arts program. There's a lot of demand here. You can see how many students applied, how many students were admitted, and then how many students accepted. And then on the right, here's a summary of the yield and the admit rate for that program. And then we've got some specific student groups that we're focused on looking at their admission stats. So underrepresented minorities, and then also international admits, and how they fared. If I just expand this cell really quickly, I'll just give you a peek at what's happening underneath. So we've got like a try-catch block here, so that because, certain programs, we don't get a lot of international interest, or we might not have data that's returned to the chart. So we want to gracefully show that data is not available for that section, rather than just showing a notebook cell error. And then here we're calling some of the chart helpers, and which are then working with the data helpers. And we've got some configurable variables that we're passing into plot before it renders. And we're also composing in the chart helper notebook, we're composing the download the data and the download the image as PNG file for our users if they wanted to use the data for their own program purposes. So, we're tracking students who decline, where they end up enrolling. Unfortunately, we lost a few students to Stanford and Harvard. We'll get them next time. So fall enrollment. So Defense Against the Dark Arts program has been pretty steady over the past 10 years. And here we break it down by various ethnicity and other demographic items such as gender. Here we're showing degree completion. So students in Defense Against the Dark Arts, they graduate pretty much a little less than 6 years. And that's pretty comparable to their counterparts in the witchcraft and wizardry division, which would include transfiguration and potions, things like that. Degree completion, we're also comparing against the division and against UC Berkeley doctoral programs as a whole. Here we're looking at retention of the students who entered in a particular cohort, 42 in this case, how many departed with a master's, how many departed without a master's, how many are still enrolled, and how many completed the program, and then comparing ourselves to higher levels across campus. We look at students who graduate, where do they end up? If we look at where students with dark arts degrees tend to end up being tenure track faculty at other institutions. And then we also survey our students, and here's where we're using the survey helper chart, survey chart helper API. So we've got the diverging bar charts, and we can see that for the advising experience kinds of questions, they're asked if they're satisfied with the career support that they receive in their program. So on the left, in the kind of negative direction, we got 13% of students were not satisfied, but 87% were. And if you compare that to UC Berkeley as a whole and to their division, that's pretty good response, but low ends at this point. So we're going to keep collecting that data and aggregating it there. And then finally, doctoral student support. So once you're in the program and you're receiving department awards, all kinds of fellowships, what kind of support are you getting? What kind of earnings are you making as an instructor or a researcher? And then when you take out tuitions and fees, what's left for your living expenses? How much butterbeer can you actually afford? Here we are seeing that we're supporting our students more and more as time goes on. This is the past 5 years. We're looking at all students and then students in different stages of their career. And then we can break that down here by career year number. So 1 through 7, students in their first year over the past 5 years have tended to be funded by department awards. Some multi-year is the blue, green are external awards, and red are block grants. It's not until they get later on in their career that they're receiving fee remissions. That's what this gray area is. And then if we scroll down to look at the earnings profile, you can see that in year 1, hardly any students are receiving any kind of funding from in the form of earnings, but later on they start to do research and instruct. So that's one of the 4 notebooks. And in the future, we're also working on not just notebooks by program, but also topical notebooks. So everything you need to know about enrollment at a high level, which programs are growing the most, which programs are the most diverse, etc. Okay. Then the third topic are ad hoc data analysis. So we respond to lots of questions. We provide a lot of data support to programs. Sometimes they're asking for specific data in support of program grant proposals. Leadership sends on inquiries. We get public records requests. We get all kinds of questions. And here are some tips for the kinds of approaches that we take to our ad hoc data analysis. So number 1, save time. Use a template. Observable's got wonderful fork functionality and all kinds of snippets of code and other libraries that you can import ahead of time. So, preload the template and just fork it, and then off you go. You can protect your data by either loading it locally or from AWS. The observable file input is like the file attachment, but the file is not uploaded to any external servers that aren't owned by you. So the data is only available temporarily in memory. I love that feature. And then you visualize the data to ensure its integrity. You can easily summarize your data once you've transformed it. You can summarize it in a summary table. You can also look at it in plot really quickly. And then finally, for my future self, I always document and use a tool called Mermaid or Plant UML to create diagrams and visual documentation. And you can also use a notebook visualizer, which is really helpful. Sometimes I work frequently with an excellent graduate student researcher in the School of Information. And if I want to understand better, like the approach he's taken to a notebook, I can run it through the notebook visualizer. And that really gives me a great perspective on how all of the cells are working together. So that's it. Thank you very much. And I look forward to taking any questions you might have.
Awesome. Thanks, Sara. Thanks for the presentation. Thanks for all the work you've done in Observable with the dashboards and enlighten everybody. How do you feel? How do you feel?
Good, good. Whenever I see myself presenting, I always am reminded of how slowly I speak. So.
No, you were great. You were great. You were great. Thank you. Thank you. We're going to ask take a couple questions from the chat and community and go from there. I'm going to start off with one while waiting some questions to come in. I'm curious about what was the first kind of reaction when you presented this new way using dashboards on Observable to your teams?
Well, we've starting this past summer, so a couple months ago, we started my boss, the dean of the graduate division, and I started reaching out and meeting with different department heads, so department chairs, head graduate advisors, and other like student advisors, other members of the department, and I'd share the information with them up front. And at first I'd just walk them through getting into Observable, but then that process became more and more smooth. So now when I'm about to meet with a program, I'll just a week ahead of time, I'll send them a link, tell them to log in with Google with their berkeley.edu and then go to this collection. And then they often respond back to me and are like, this is amazing, because in the past, we had collected a bunch of data, but we didn't necessarily share it, or it was shared in PDF files, or not as holistic as it is now. So, but I will also just say that this is like the first iteration. We're just trying to get the data out as quickly as possible and kind of get a setup in place so that we could easily, grab the data when it's refreshed and load it in. So there's a lot of improvement to be made, and a lot more like interesting charts that can be made from this data.
Awesome. We're looking to see what you do in the future with that data. Yeah, and that jumps into the next question that Erica asked, which is connected. You touched on this. Is these dashboards are clean and easy to understand? So great job on that. Are they built to show data in real time? You touched on this some, but you want to elaborate some more?
Thank you, Erica. So generally, this data is based on like data snapshots. There isn't a lot of like real-time data. I often have to wait till the data gets in the data warehouse until I can load it. But so I wait till the data is available, and then I have to write some data warehouse queries, and then I put the data usually in CSV files and then load it into AWS. So a lot of this data is being pulled from AWS.
Got it. Thank you for that. Yeah, Erica, thanks for asking the question as well. So next question, with the current data job market being what it is, how many are going into the alt arts track?
Oh, I think I might have already answered that one, Wayne, because I think it's about the defense against the dark arts, the discipline, and how, with the current political climate, I think we're probably going to be seeing the rejuvenation of the dark arts program itself.
Got it. Yeah. This is the next question. Do you pretty much do all the data cleaning prior to connecting to Observable?
So, a lot of times what I'll do is I'm not using super duper huge data sets. So I love Arcaro for data cleaning. So I often use my ad hoc data analysis flow to prep the data, and then I might export it in an aggregated form put it on AWS, and then put it into and then have it be pulled into a dashboard. So I do a lot of data analysis, data cleaning, data preparation right in Observable using locally loaded files.
Awesome, awesome, great. Well, Sara, I know you connected with our customer success team, Cobus, and connected with Courtney, with community manager for EDU, and we're here to support you as you continue to build these amazing dashboards on Observable. So let us know if you need anything. I know the community is here to support you as well, and just thank you for speaking at Insight today.
Thank you so much, Wayne. I'm so excited. Learning about like the URL parameters and some of the other features that Ian was describing. I'm really excited to keep incorporating all the new features of Observable and continuing to work with you all. So thanks for putting on this conference.
All right, you're welcome. Awesome. See you in Slack.
All right, take care.
All right, awesome. Ooh, all right, let's give Sara a round of applause in the chat. Amazing work and doing a lot of awesome things over at UC Berkeley. And cool. All right, humans. Sara touched on some of this, but we're in the past 3 or 4 years, we've been dealing with some challenging times. And there's been the saying we heard on Twitter, it is what it is, but there's some things we can do as well. We're learning from the data, from what's happening in the world, and make decisions and help create change. And the next speaker is someone who's doing that, and the work is very impressive, and we're excited to have them today. So before we get started, we can take a deep breath. It's coming 3, deep breath. 1, 2, 3. Ground yourself, be present in the moment, and get ready to hear from David Eads. David is the data editor at the Marshall Project. David's going to talk about Show Me Another, how to start investigating criminal justice, and other things. David, welcome to the Insight stage.
Hey, excuse me. Thank you, everybody. Let me try to share my screen here, and so you can see my slides. It's giving me tips on how to do this. 1 second. All right, I guess I'll just have to maximize it. Does everybody see that okay? Wayne, can you tell me if you can see that?
Not yet, David.
What's that?
We got time. Not yet. Can't see.
Not yet.
Yet.
Okay.
Yeah.
Give me a second. What's going on? Let me try again. Tips. Sorry, everybody. This is classic. I promise I am an IT professional.
Okay.
Many years of experience doing this, and I was going to have sort of a long break in mind where we, reset our bodies and all that stuff. So we can do that now. Just what Wayne was saying: be in the moment and put your feet on the ground, take a deep breath, do all those things. And now, can you see my screen? No. Yes. No. I don't know why you can't see my screen. It has lost permission to share my screen. Well, I mean, I guess I could just let's see. It's very hard without being able to see the screen. Let me try to figure out how to fix this, and maybe somebody can tell jokes or something.
Not sure about jokes, David, but I'll be here. So do what you need to do. If you need a refresh and come back, it's okay. The community stick around. We're here. We're excited to see what David has to share. So it's okay. Just let's know what you need. And so, and FYI, when you click the share my screen, choose what to share. Does it come up? Wow. Okay. David's working on that, figuring it out. As we get through the day, I think David's going to come back. I'm curious, so far, day 2 of Observable Insight, what have been some of your, I won't say favorite, not taste, compare to others, but what have been some of your other favorites talks from today? Let us know in the chat. I know, I will share mine. I'm just going down the list. We had a great welcome from Melanie this morning. Kicking things off, and then Mike, if you missed it, Mike had the Observable Can Do That talk with a lot of questions. Okay, I see David's back. Yuri said defense of the dark arts. Toph. Melanie, love seeing the workflows and presentation. Agreed. Awesome. All right, I think David is back. I'm gonna bring David to the stage. Yes. All right.
There we go. And I think you can see my slides now, everybody. Very good. Okay, cool. Thank you. Thank you for your patience. I hope you grounded yourself, put your feet on the ground, all that stuff. I'm David Eads. I am the data editor at the Marshall Project. We're a nonprofit publication that covers the U.S. criminal justice system, and we'll get into what that means in this talk. Internally, we've been developing this philosophy discipline. I don't know what you want to call it, but we're calling it Show Me Another, and it's sort of an orientation towards thinking about how we sort of get into records and start really kind of digging meaning out of, in our case, data that's often coming from the criminal justice system and sources that either have bad data collection processes or use data in certain ways to construct realities that we might want to challenge. It's sort of, in some ways, it's sort of an entry point into some of these bigger themes. So this is my team. I like to show them off. This is usually the point where we put our feet on the ground and we take a deep breath. And it's really exciting to have a team like this, to manage a team like this. And, shout out to Observable. I'm not here to sell anything, but we really use Observable a lot, and I'm going to show you how. Real quick, trigger warning. We are talking about criminal justice. We're going to be talking about it abstractly, but we're going to be talking about some fairly serious subjects and some fairly heavy stuff. Okay, so let's back up a little bit and talk about a project that we've been working on, and then talk a little bit about how we sort of developed some understanding using Observable and a couple other tools, Sara specifically, to sort of give us some access. So this project, it's called testify.news. If you want to pull it up on the web, is looking at the court system in Cleveland, Ohio. Why Cleveland, Ohio? Well, actually, it's really hard to get court data and good court data that, for example, includes an identifier for the defendant that you can track across cases. And this county in Ohio happens to have that. And so we scraped it and we started to develop a really groundbreaking kind of project. Groundbreaking is probably why it's such a pain most of the time. To do anything on this project, but we started by looking at sort of where people are getting convicted, where people are from that are getting convicted of crimes, and then where people are from who are voting for the people convicting them, and we sort of see this sort of inverse relationship. And in the middle, you see we went to the community and we started asking them questions. What do you want to know about the courts? And so we started taking that and turning that into product and journalism and really trying to kind of serve the information needs of the community. And you see that on the far right, where we're creating sort of a place where anybody in Cuyahoga County can come and just ask, how many people in my community have felonies? How many people are walking around with a record like that? That's something people want to know. Things like that. And so just how big is the court system? We're answering those questions through these tools. And if you go to the marshallproject.org, today you'll see the latest installment in this series that we just did. And that installment is about repeat defendants, people who are cycling in and out of the system over and over and over again. There's popular conceptions of who these sorts of people are. You hear a lot, especially in this very kind of overheated political season. You're hearing a lot about career criminals or dangerous people being put back on the street. And we looked at this population, and what we found is that people with 5 prior cases, 10 prior cases, commit violent crimes, or at least in court for violent crimes, at like exactly the same rate as any other slice of the population. It's just really much more about sort of untreated addiction, mental health issues. The most common charges that you see in this population are drug possession, or even other kinds of sort of crimes of poverty, like owning a gun or having a gun without necessarily using it. You might just have it for your protection. So we see all these sort of nonviolent crimes in this population. It's a really important it's a really important thing to be working on and doing. So to sort of develop some insight about this data, we built these little tools in Observable that we call Show Me and Others. We're working on it. We don't do this as much as I don't want to make it sound like we've got this all figured out, but this is something we're doing quite a bit of. And instead of trying to, when we get these data sets from the government or we scrape them, instead of trying to immediately start to quantify something, immediately start to do descriptive stats, we think it's so important, and it sounds so obvious, right? It's so important to just look at records. But what does that mean, right? You can pull up a spreadsheet and you can read something, but something like this court data is complex, right? Like simple rows and columns are not going to describe the history of the bond amount that somebody gets or the bail amount that somebody gets. So we build these little tools. They're very simple, and they sample our data. They write little sentences, and we start to get a feel for the data. Show me another. Okay, show me another. Well, let's look at this first one first. So Cleveland police, 30-year-old black male person from Cleveland. And they pled not guilty, or no, they had a drug possession charge dismissed. This is the first one I pull up. Is this a normal case? Yeah, I can already tell you it's a pretty normal case. 30-something black male person from Hudson. They had 2 prior cases. This is very common. And so okay, here's another case. Whatever, we could keep tapping the button, but we've also pulled out a couple things from the more kind of narrative parts of the case. There's a thing called the docket, which is sort of the timeline of things that happen in the case. And then there's these specific entries in there that are like how the defendant was sentenced in the case. This is such a bear to sort of parse out and understand, but we can show it here and just without even having to parse it, just with our own eyes, we can say the state of Ohio and or Bedford Police Department and or City of Bedford is ordered to return defendant $2,200 in U.S. currency. You can see the parser sort of broke on U.S. currency, but who cares? That's interesting. I'm writing that case number down and trying to find out why Bedford Police Department took $2,200 from somebody in a minor what otherwise appeared to be a minor crime. So okay, we're starting to understand this data a little better. Show me another. Okay, this is interesting. This isn't our person passing bad checks. That's not a case the Marshall Project's interested in, but we start to see some data quality issues. So this person was a nan something from of unknown gender, not specified race. There's some data quality issues. We're going to have to contend with those. So, I'm taking notes. I'm thinking about it a little more. So as I'm going, okay, so now you can see across the top, we have this little button. It says filter, and we can say we want to look at just people with more than 5 prior cases. And now we're going to really start to see these intense patterns, because this group of people isn't just anybody. It is Black men in middle age with drug problems. And you sample it enough times, you don't have to sample it that many times to really start to get a sense that the daily work of this court is really dealing with these kinds of cases. So another 30-something person, they were caught by CMHA. If we're guessing, we might guess, okay, that's a housing authority. Cool. So whoops. Whoa. Okay, so let's show us a lot. So I'm just clicking here, clicking, and we're seeing again these patterns emerging. Black male. Okay, there's a white female. Black male, right? You're really starting to get a sense of what's in this data. This is sort of the point. We'll get into Q&A in a second, then we'll get back into some of the tech stuff and other parts. But this is sort of the part where it's sort of okay, like, why are you talking to us about feelings? Why are you talking about findings? Why are you talking about how we're going to add this up and show the worst thing that ever happened? And aren't findings hard, right? Like, don't you need to be a mathlete? And one of the things that I think is so powerful about tools like Observable, so powerful about modern data journalism, is you can just pull records. You can start looking at them. You can start to develop some intuitions using, the most basic sort of code, 101 code that you could possibly imagine. And maybe this isn't the best crowd to be telling that to, but in my world, a lot, and I think in a lot of your worlds too, probably, a lot of people are afraid of this stuff. They're intimidated by this stuff. And these sorts of things sort of break some of those barriers down, start to create some sort of cultural space or social space in your organization to have deeper and better and better, deeper and better and more nuanced conversations and more effective conversations about data. So I'm going to show you a little bit of what we do and talk about how we sort of, sometimes we have findings, sometimes we don't. Sometimes we use data to reach out rather than just in something that we're publishing and you're passively reading. And I'll talk a little bit about that. But this is also a good point to note that, it's cool to win a Pulitzer and all that stuff, but you don't make more money. And I think a lot of you probably make more money than I do. And so I just want to suggest, go to marshallproject.org/donate. We can't do this work without you. I will stop with that part right now. I might do it again. You never know. Okay, cool. So on the left, so here's a couple examples of sort of showing what we know or using data journalism in these interesting ways. So on the left, we see, and we'll go back to this a little later, we see something from a project we recently did about the American Recovery Plan Act, which is this massive sort of government infusion, federal government infusion, biggest in a generation of money to local governments, as well as the other stuff. But the thing that's very relevant here is that they gave $350 billion to local governments to be spent over the next 2 years, this year and next year. And Department of Treasury publishes a data set, and it's really hard to understand. I mean, it's not designed to be easy, right? Like places can just say, oh, we're spending the money on revenue replacement, and they can hide it for whatever they want to do. They could be like, we're doing revenue replacement for emergency services and police and sanitation workers. And then they give all their money to the police or all their money to the sanitation workers. We've never seen the latter one happen. We've only seen the former one happen. But there's lots of ways that you can hide your data in this. So we can't really give you some big number. But what we can do is pull out the cases. Here's what a place is spending on jails and infrastructure. Here's all the places we found that included body scanners in a proposal. So that's very interesting. On the right, you see another project that sort of has this interesting history, because originally we'd done an analysis of formerly incarcerated people and how often they register to vote in places where they've gotten back the right to vote, like Kentucky. And we found that less than 1 in 5, 1 in 4, depending on the state, actually then after getting the right to vote back, then actually did even register to vote. We didn't look at even if people went to vote, simply if they registered. And so there was this sort of big analysis and this big data story. And then what we got was a tip from Colorado. And what we heard was that the forms in Colorado were wrong, that people are allowed to vote when they're on parole in Colorado. And the form that they give you when you get out of prison says that you can't. And we were like, no way, that's crazy. And we went to the website and we looked it up and we screenshotted it and we put it in our story, because sure enough, it had incorrect information on the form that was literally posted on a government website. And so again, like this interesting way that sort of a data analysis feeds a tip, becomes some visual evidence that we dig up through some internet research. And then on the right, on the left was more of the left panel is sort of more of an investigative piece. And on the right, we turned all of that into a comic book. You can vote if you are on parole in Colorado, and informed people about their rights that way. Here's another kind of cool and interesting example of maybe a little more traditional example of sort of showing what we know. And also an example of the way that and I think this is so relevant to all of us, I think, here at this conference, that my team doesn't just, it's not just, we don't just work with data, we work about data. We have to understand this isn't happening, like data is not happening in some sort of political vacuum necessarily. Like last year, data that we use fell off a cliff. A lot of people fell off a cliff, and that's national crime, FBI crime collection data. And so usually about 90% of law enforcement agencies report this data. And last year, because they went to a new system, about 60% did. You've probably seen the headlines, you've probably seen the news, and I'm really proud that a reporter on my team basically broke that story much earlier this year with this piece. And so you see something more traditional. We're doing charts, we're quantifying data, we're adding things up. But we're actually sort of analyzing the metadata. we're analyzing if the police department even reported their data to the FBI. We're not looking at the stats. We're looking at the stats of the participation stats. And then on the right, you can see something that we really love. This is something I've really refined in Observable, and then we're using in published products. And that is something that sort of looks up where you live. And so if you go to this page, it's a sidebar to the story. It will tell you the reporting situation of law enforcement agencies in your state automatically. And so that's really, really powerful. It's really powerful for engagement. It's really powerful for nuance, right? Because I think we're used to investigative journalism and media that's really depressing, right? Like the sad stories, right? And those are really important stories, but nuance is important too, right? Like it's good to know that you live in a state that doesn't have crappy data reporting to the FBI. And there's so many powerful sort of opportunities to sort of show people in these really tangible ways. The last thing I guess I'll say in this section is we turn it the other way too. So we don't just use data to sort of analyze the world, we use data actually to report. And so we got, for the story I was mentioning about voting in Kentucky, we got a bunch of phone numbers of formerly incarcerated people. And we text messaged them, and we text messaged them a survey that asked if they knew about their rights, but it was also sort of a way of informing them of their rights, which was sort of an interesting thing. To show how much we use Observable, you know, we made our little dashboard to figure out how much money we spent and how many, I didn't show this here, but you know, some of the responses we were getting and the delivery rate and things like that. Of course, you know, just you know, what do? We make a little notebook. So I could talk about building a sampling notebook. I can talk about how we use Observable for data review, but let's just, you know, if anybody's got any questions, we can jump in and then I'll just kind of hop around. And if you don't, I'll just keep rolling. All right, I guess I'll keep rolling. Whoops, see now it's just going like crazy. All right, let me show you real quick how we do the sampling notebooks and how we do data review, because I think those will be interesting and that'll take us up, I think, to a good point for just break for Q&A. Cool. Okay, so, you know, our sort of TLDR for how we do that, show me another, yeah, Visnu, yeah, this is it. See what Visnu's saying, like that is so right on. So what we're doing, so what we're doing is we have an API, like Sara was talking about. We do everything, all our data is hosted on AWS, either just straight up S3 downloads or behind APIs. In this case, we have an API, GraphQL API. You filter based on your criteria, you sample the pool, and then you do HTML Mad Libs. It's really not complicated. So the query looks like this. One of the things we like about this is that, like, you know, this is 60,000 rows, but we're only getting a couple fields. And so it's really not that bad to pull 60,000 rows and then sample just the ones you want. And so, you know, that's sort of this nice thing. You can see that we're doing some GraphQL querying here. We love Hasura. Really powerful tool. It connects, puts a GraphQL API in front of Postgres, and lets you, you know, build these really powerful kind of almost data universes inside of Postgres. We flattened the data out. I'm going to move past that slide because I think people I respect are in the audience, and it's kind of embarrassing code. And last but last but not least, we have sort of a simple thing that you know, we've got a filter. It decides how to filter the case pool, just how to filter the case pool based on that active filter view, and then just returns a sample of one using our Caro. So again, a lot of what Sara was just saying, you know, was just exactly the way we do things. It was an almost perfect kind of setup for us. And then we play HTML Mad Libs and we do CSS. I go into a lot of detail when I talk to the students about this part, but we'll keep moving. One other thing that we really like, and I think you're going to really think, hopefully, I think you all will find kind of interesting, is we do a lot of sensitive work. It has to be reviewed by lawyers. It has to be reviewed by data people. It has to be reviewed by multiple editors, and it will include sentences that assert things from data from work that my team's done. And so we use Observable. I'll switch back and forth between the slides. This is the Google Doc. So in the Google Doc, this is for the story that just came out today. In the Google Doc, we put footnotes with links to code that proves the assertion in that sentence. And then just in the footnote, I can convey just through little conventions, like, oh yeah, like I give this one the thumbs up. I've now reviewed the code, or I've independently. Typically, I'm actually independently recalculating the number. So we've got these little links. We've got the cells in the notebook. We copy the assertion into the notebook, and we see if it matches. And so this is just awesome, right? Like the editors I work with, who are often not necessarily technical, is that they can still sort of read a formula. They can still sort of understand what's going on in a little snippet of code. if you direct them to the exact right thing that they need to be looking at. And so this has been so powerful for us to be able to do that, and just close some of those gaps. And as a journalism organization, we live in Google Docs, and so being able to sort of do this cross-linking has just been an awesome thing for our review. What do we got on time? I'll show you the published product real quick, and then we'll end. So the last thing I wanted to talk about, we've got how the rules are changing. That's for journalists. It's kind of funny. It's more to challenge them. But let's just talk a little bit about going to a published product. You know what I should add? Thank you, Lauren. You know what I should have done for this presentation? I can pull this up later, but we also publish observable notebooks here. Well, I'll show you in a minute. We also publish observable notebooks that share our methodology. I'll pull one of those up in a minute. So just wanted to show you this. This is really cool. I was mentioning the project. We're really sort of having to take this prismatic, what can we find here kind of approach to this. But here's just sort of, I think you'll just kind of find this interesting. So here's sort of a couple things that we've already talked about coming together in a single place in a piece. So what we did is we found one like really head scratching criminal justice related, at least one really head scratching criminal justice related expenditure in this federal program in every state, in all 50 states. And I can't tell you what the internal name for this was. We'll call it a head scratcher. It starts with W and it ends with F. But so these real head scratchers, like, wow, what are they spending their money on? So the first thing it shows you is one from your state based on your IP address. So total, engagement monster right there, right? Like, oh, what's going on in McHenry? I live in Illinois, so interesting. And then we have this show me another button. And it's not actually random at that point. We've actually curated the entire order from kind of the stuff that like we think is really, really interesting. Like the state of Colorado spent $103 million on retention bonuses for a private company staffing their prisons. So that's very interesting. We I just thought this was sort of an interesting example of sort of applying some of these ideas that we're talking about in a published product. And we see this a lot. We'll take ideas from observable notebooks and they'll go into published products. We'll see things elsewhere. We'll try to reproduce them. We do all sorts of interesting stuff. If I do this, can you see the blank tab? Yes, you sure can. I can see that you can see the blank tab. Let me see. Let me find this. There can't be that many things about mass shootings. So, oh man, observable. How do we know mass shootings are increasing? There we go. So to Lauren Steely's point, in terms of credibility and reproducibility, something we really like to do is stuff like this. So we did a story looking at whether or not mass shootings are in fact going up in the US. They are. They're going up and they're becoming more deadly. Sometimes we'll publish a methodology notebook like this with the story. Sometimes we wait to anticipate the sorts of questions we get. Sometimes we're just too busy to do it. In this case, we were too busy to do it right away. But we got a bunch of feedback on Reddit, and a lot of it was sort of like, but what about this? What about that? It's like, man, I'm writing an 800-word story. Like I can't put every nuance in there, but we can in the notebook. We can in the notebook, and so they're like, well, did you count it looking at both the incidents, people killed and people injured? Yeah, man, we did. What about guy? That's exactly what we did. Did you look at different time windows? Yeah, actually, what about that? We sure did. They're going up any way you look at them. And you know, this is really powerful because, like, what about guy? Sometimes what about guy wants to attack you. But sometimes what about guy just wants to know you're listening to what about guy and that you're taking what about guy seriously. And this really, really, really helps with what about guy. You know, we can just really, really show that we worked this out, that we really, really worked this out, that we really thought about this hard. And that we can, you know, and that we can justify the choices that we made and what we did. And this was an interesting one because I had the same question. What about guy did? What about population? And we ran the numbers and we saw it's going up either way. So I thought that was really I thought that was a really cool thing. And a really cool use, you know, really cool thing that we can sort of do with this technology. All right, let me stop. And maybe we can just talk a little more. What questions do folks have?
David, thanks so much for presenting the data and research and the work you're doing at the Marshall Project. I think we have some new phrases from the last part of your talk about how you deal with people. So what about people? What about humans when they question the data? I want to go back a little bit and think about where we are right now with data. You know, trying to, let's say, solve or bring more insight, more awareness to hard conversations, hard topics, versus where we were maybe 5-10 years ago. Was the data, you know, that much hard to collect? Was it just different places? You mentioned that, you know, the FBI and other organizations they switched data systems. You know, was this possible, you know, so far, you know, a long time ago, and how has it evolved to where it is now?
Well, I would say, you know, 10 years ago or so, there was a real kind of like golden moment of civic technology and people opening up, you know, certain kinds of civic data sources. We're sort of in a period of regression right now. For the first time in decades, we don't have national crime stats, other than the National Crime Victimization Survey, which doesn't give you nearly the kind of geographic specificity that you might want. Anecdotally, we're seeing a lot more departments just close the door on us when we may, or government agencies, I should say, generally closing the door on us or acting like they have impunity from Freedom of Information Act requests. So I would say overall, over the last 10, 15 years, things have gotten better, and the tools clearly have gotten better. You know, it's hard to imagine a life without you know, even Observable or much less GitHub, you know. But in terms of my world, in terms of what I look at, the kind of data quality situation is degrading pretty rapidly right now.
Awesome. Thanks for sharing that. Melanie has a question, and would love to hear more about how your approach helped you and/or was challenging working with other collaborators, other journalists.
Yeah, that's an interesting question. It's been a really slow, you know, I see my team's mission and part of my mission as sort of not just sort of turning the crank of data, but really creating kind of deeper awareness and sort of just that healthy data culture. And you know, it can be really, really slow going, but the fundamental shareability, I tell my team this constantly. Now I do sound like an Observable advertisement. But you know, I tell my team, like, you know, like you can use any platform you want, but it has to be on the web and it has to be shareable with your colleagues with zero friction, right? Like they need to be able to click a link and get to the cell and see the thing that you're talking about, even if they're non-technical. And so far, my team has not found a better alternative. Some days we get frustrated, some days we want to, some days we're so happy with it and we love it. But it's so powerful. Like that part of it's so powerful for us because, you know, day after day, year after year, you're exposing people to these ideas. You're getting them to interact more. You're asking them to become more active participants in data inquiry. And I think what I'm seeing to Melody's question is I think it's just deepened our approach. We just have insights we didn't have before, or able to develop insights at least more quickly than we were able to before, for sure.
Yeah. Thanks for sharing that. This is an interesting question from Nikia. I'm curious about your approach to like, when is data visualization an inappropriate substitute for writing?
Oh man, that is an awesome question. Thank you, Nika. I mean, I don't know that I have an exact answer to that. I mean, one thing the part of this idea of creating data culture, right, is like one thing we are painfully aware of it is something we're just very painfully aware of is like people really don't understand margin of error, like in the general population, and so, you know, one very simple answer to that is if the error bars are too big, it wouldn't be you know, there's a lot of things that are too. You know, you can write something is up to about a third, or we know it is at least X, Y, or Z. I think that's a lot of it is conveying certainty when you don't have certainty. A lot of our calculations are sort of like, well, we know the baseline level of sort of like badness or whatever it is X, but it could be, you know, a lot worse. So that's often, you know, that's often the case. Yeah, sometimes it's just an aesthetic choice. It's you know like what's more telling, you know, the detail about somebody's life and their individual case, or sort of the scale that something's happening on, and you know, that's often a case by case thing.
Yeah, agree. It's an interesting question, and I'm gonna follow with another question about something you shared, a dashboard you shared earlier. But the question is about financial transparency. You know, does that help raise funds for independent journalism projects?
Yeah, that's a good question. I don't know. I'm not enough part of that business, that side of the business. I do think that something that we've found that does help raise funds is localization, is bringing people content that's highly relevant to where they live without having to interact further. They just pull up the site, they see how many COVID cases are in their zip code or whatever. Which was by far the most successful project. I did a project about COVID-19 in Illinois, all based on observable embeds, team of 3 people, and we reached, you know, the web analytics were over 1.4 million people, and then we were being screenshotted and running newsletters. We reached so many people, and it was just, you know, just taking a hidden data feed and putting it online and turning it into a thing that told you what the conditions were in your zip code. So,
thanks for sharing that. I do want to ask a question. You showed the dashboard you did around sending text messages to people knowing about their voting rights. I was a little surprised by that because I thought you was doing everything for front facing, you know, storytelling on Observable. But how often do you use Observable for other projects internally that you can share? Is it across the board, or is that like a one-off case?
No, I mean that's the thing. Like we just often across the enterprise have data that we need to share, and it's nice to have one tool to do it. So everybody's got a login. It's very easy. People are familiar with it. So, there's little kinds of internal dashboards. We're also building, I could show you this, but we're building tools that will, in Observable, that will dynamically draw an illustration, an editorial illustration. So like there's illustrations that you saw where it's like body scanner, and it was $350,000 in Coetta County, Georgia. Well, there's 18 other places like that, and so we wrote this little thing using Canvas, and so you pick one of those 18, and it draws the illustration with the it's like visual Mad Libs or like dynamic illustration Mad Libs. So we're going to use that, and then we'll just export those to PNG and put them on Twitter, or in many cases, I think we'll send them to people in those communities.
Oh, that's awesome. Sounds like a cool project too. Yeah. Next question from Erica at Observable. What type of user do you find typically consumes your data via notebooks?
Most of the organization. Most of the editorial part of the organization has to think about or deal with data. So almost everybody has to touch it to some degree. The people who are a little more proactive, I think just are more data curious.
Got it. Interesting. Cool. If when you think about the importance of your work in the Marshall Project, with not just, it can be seen as a debating with people, or as you say, like the what if person, and you think about the people like, no, we have this data right here. How hard do you feel like it is to like get people like, no, look at the data, like don't just look at the headline. A lot of people skim headline articles these days. Like, look at the data. Like, did you know, whether it's a drop down or to change the visualization, like, did you know, how hard do you feel it is to like have a conversation around like, no, let's talk about the data versus talking about how you feel or the headline based on your assumption?
I think what we see that I find is so interesting about this stuff is that there is so much hunger right now in audiences. I mean, I think after saying some kind of depressing things about the state of data quality in the criminal justice world, there's something really interesting in that, like, these data products bring out audiences, like people really, really hungry, not just to hear sad stories, but know how the government's spending money and how just how those priorities are being set and how we has so. I think what we're finding is in some weird way we can't keep up with the demand. We've been working with Axios and their local newsletters. If you're familiar with that, they're starting new newsletters all around the country. And so we'll work with them and work with them in these data sets. And so then they localize the data and write local stories. So that FBI story that I showed you, in addition to the national story that we did, which for us did really, really well, lots of expert attention, but also a lot of attention from sort of everyday folks. We were on NPR with it. So that's cool. But then Axios wrote, I think it was 16 or 18 local stories. One for Columbus, Ohio, two for Texas. One guy in Denver started doing kind of a big investigative story because he found fraud.
Wow.
And so now we're sort of this is another thing that I guess another side of your question is like, I think my field needs to do a better job of meeting people where they are, in their email box, on TikTok. I think we need to do a much better job of meeting them where they are, hearing misinformation as well. So what I find is if you can, like the hunger's there, but you got to figure out how to get it to folks. The challenge is so much these days is distribution, at least for us.
Yeah, no, that's a great response, and agree. Meeting people where they are is very important, because we've gone beyond 3 or 4 platforms to now like multi platforms, in social networks. So thanks for that response. Last question from Clint. Do stories with supporting data viz perform better readership and engagement than ones that only feature stock and static images?
Yeah, generally, yeah.
Yeah,
it depends. You can have a boring chart or a confusing chart that turns people off. But what we find particularly seems to really grab people is I think I showed a slide is when the data viz is really integrated into the text. Like you're just reading, and then it's the maps, and then you're reading again. We don't have big enough sample sizes to really say this. But it does seem that that format is the most kind of like grabby. In traditional journalism, you have a nut graph that's sort of the nut of the story, the thing after 2 or 3 paragraphs that really gets to the heart of the story. And so we sort of joke that we want to take that out and put in a nut graphic. And one of the rules on my team is that you don't write 3 paragraphs you don't go more than 3 paragraphs in a story without some piece of visual evidence drawn from data, drawn from something that you downloaded, drawn from something that you saw on the street, whatever. But we want that visual to grab people. That's really, to Clint's question, that's really the key thing. If you don't have a visual somewhere in that first 3 to 8 paragraphs of a story, more people will leave than if you had one. That is undoubted.
Oh wow, that's a great, like Clint saying in the chat, great rule, and that's also great insight for us in our community as well. Want to say, David, thank you for the work you're doing. Thank you for partnering with Observable and the Martian Project. Thank you for allowing us to help you at the Martian Project.
Thanks for all the support over the years. We really appreciate it.
Awesome. And thanks for speaking at Insight.
All right. Thank you.
All right. Great. I also want to say thanks to Melody, Clint, and Erica for the questions. Appreciate the team with the coming in with the questions, the great questions. So next, we're going to bring to the stage someone who's been behind the scenes months ago and past yesterday and today, helping make Insight happen. Courtney Francis, our community manager for education, to talk about the Student Data Jam. Hi, Courtney. Welcome to the stage.
Hi, Wayne. Thanks for having me. And thank you guys for sticking this out and hanging out through the home stretch of a really, really fantastic couple of days. We can tell, as you can tell from being here, we at Observable are really, really lucky to work with a great community. Everyone is engaged, creative, and prolific. And the education community is no exception. It's active and it's thriving, and I am constantly impressed by the commitment that our education community has to community and to collaboration and to teaching and learning and being vulnerable. I've seen so many innovations from teachers using Observable to teach and learn in the classroom, and most students do learn Observable this way. What I want to introduce today is the results of a program that we've put together recently that is focused on giving students ownership of their Observable experience and their contributions to the platform. So we're going to talk a little bit about the Data Jam that we ran in the month of October, and we have the winning team here to speak to their work. So the goals of the Data Jam program are to share Observable with data practitioners who are learning and refining their craft. We don't consider students of a certain age group necessarily. We want participation from undergraduates, graduates, folks in boot camps, folks with all kinds of experience. We also want them to engage in curious and collaborative data processes as a preparation for the future of data work that we've sort of talked about a few times during this conference. And the last part of the program is that we really wanted people to reflect on their own process, sharing the works in progress, the messy parts, and the struggles, so that others can learn from their work. To that end, we used a data set from USA Facts that's based on higher education data in an effort to make the contest personal and relatable to people of all experience levels who are moving in and out in between education and industry. Now, that's folks who are moving from school to the workforce, so that's folks who are moving from the workforce back to school in an effort for professional development. So we had Ian Johnson, who you saw earlier today, teaching us about dashboards, put together a fantastic data-rich notebook for teams to use as a springboard to remix and update and study for this data jam. We included more than 10 data sets, and we provided resources and references to help folks structure their submission. So Ian and Alison Horst, who you saw yesterday leading the using Observable panel, served as judges for this event, and we're super impressed with this team's entry. The winning team, Koi Pond, excelled in all of the standards for the submission, but they also went above and beyond the requirements by thinking more deeply about this work and including things like additional data sets, explaining their reasoning behind some of their analysis, and taking a look at accessibility. So without further ado, I want to introduce Dylan, Nora, and Naol, who are from UC Irvine. They are Team Koi Pond, and being here today is part of their prize for winning the Data Jam. So we're super happy to have them, and they're here to talk about their work.
Thank you for hosting us.
Thank you.
So I'm Noel. I'm part of Team Koi Pond.
I'm Dylan.
And I'm Nora.
We're all students at the University of California, Irvine.
I'm sharing my screen. Sorry, Dylan, I'm actually having trouble sharing screen. Can you do it?
You good? Let's see. Share screen. Let me just find the right tab. Here it is. There we go.
All right. So we're gonna go through our project through the sections, and I'm just gonna be explaining how each of the sections how we came to use each of the sections and how we developed this model. So for the analysis of the data set, what we actually did was we used Bayes' theorem. We used Bayes' theorem to analyze the data set that was given and to calculate the probability distribution of any individual given their race, ethnicity, and gender. And we calculated the probability of them ending up in either a high school, some college, or a bachelor's degree. Now, to get these calculations, first of all, we had to make some basic assumptions to simplify our models so we actually can make relatively accurate models. These 4 assumptions that we made was that everyone who was eligible to apply to college actually applied straight out of high school, and they applied to 4-year institutions. Everyone who applied to a 4-year institution got a bachelor's degree, which means we didn't account for people who got their AA in 4-year university. And we estimated that race, ethnicity, and gender are all independent and conditionally independent. And the final assumption we made is that everyone who enrolled in their bachelor's degree is only getting their first bachelor's degree. So double majors, second bachelor's, we didn't consider things like that in our model. Now, the way our model's calculation works is this section, the first equation, is the probability of someone enrolling in a college given their race and their gender. We use the letter B to represent gender because G was already taken for graduation rates. And the way the formula works, or like the way you would read this formula, So P is the side on the left side of the slash is enrollment rate given a race or a gender. And from that formula, we follow the next formula, which is the graduation rate of a four-year institution given a race and gender. First half is the probability of you first enrolling in a college, and then the second half is the probability of you graduating once you have gotten in. Now, if you go a little further down, we have our first plot. This plot is a demonstration of your probability of graduating at one of these levels, either high school, some college, or bachelor's degree. These are denoted by the colors. And we can adjust which of these groups you are in the top part. This is the interactive part of our plot. So you can see an Asian man as like, you can see the probability distribution of an Asian man throughout since the last 20 years. And you can see that it has, the relative ratio has stayed relatively consistent, where most Asian men are going to college. Most of them are completing it, and then the smallest number is in the bottom with high school, where they are only getting their high school degree. And you can see how this data changes over time. An interesting aspect of this plot is we actually set the race and ethnicity and the gender section to randomize every time you reload the page, because we didn't want it to have a default race and gender to avoid any biases. Additionally, we also chose a color palette for the graph that is very optimized for people with prosopagnosia and dysautonomia, which I actually have dysautonomia. So these graphs are very friendly to colorblind people. Now, given these assumptions, if you scroll a little further down, you can see an income distribution. We assumed a normal distribution for each of the incomes. And so there's actually 3 normal distributions in here. They kind of blend in together for some college and high school, and then there's a big gap here in the middle because college graduates make that much more money on average than non-college graduates. This graph is specifically just for the year of 2019, and you can change the output of this graph by going back up and changing the race and gender of the person. All right.
Yeah, so one of the investigations that we did was kind of into this assumption 3, which I'll remind you is the assumption that your race, ethnicity, and gender are both independent and conditionally independent. In general, they are independent as a demographic, but they may not be conditionally independent, which what that means is basically if you have a race and gender, the probability that you're a race and a gender given that you were enrolled in college, if they are independent, will be equal to the probability that you're that race given that you're enrolled times the probability that you were that gender given that you're enrolled. In an ideal world, this is a valid assumption, but in the real world, it's probably not. You can imagine that there are some societal forces that would dampen a specific gender for a specific race from graduating from college or enrolling in college that would make this distribution not independent. We don't have the data set exactly to quantify this interdependence between the two. So just as kind of an exploration into what this would do to these rates, we created this kind of interactive plot where we encode this dependence as just a constant C. And when C is equal to 1, then the race, ethnicity, and gender are fully conditionally independent. And obviously, as you vary 1, that changes the dependence of the two. And you can kind of play around with these sliders, and you can see how if you change the dependence in your enrollment, how it may decrease the amount of people who end up applying to college or increase in the other direction. And then same for the graduation rate, how it increases the number of people who get bachelor's degrees versus who come out with just some college. And so both of these sliders prevent you from going below 0 or above 1, which is why you may notice that these two sliders are different lengths. And so then also just one last note is that this data is the same as your choice up here. So if you change this, you'll notice that this plot also changes. And you can fiddle around with this.
Yeah, so the conclusions or how we came to our conclusions is that we had to do a little bit of tweaking here and there just because it was a very more simplistic model just for the given data sets that we had. And so we added an additional data set from the Department of Labor that would break down the median annual earnings by both gender and race, despite treating it, the demographics individually, just so that, you know, sociologically speaking, we understand that there is interdependence and also intersectionality when it comes to race, ethnicity, socioeconomic status, and so on. So we wanted to make sure that we stated our assumptions and also were able to provide a little bit more clarity when it came to the data. So we compared the data to a baseline of the demographics in terms of a ratio. And historically speaking, we set it to white men just to have just a standard baseline. And you can use the interactive part to see how is it that you would compare in terms to the baseline. So hypothetically, if you had a Black man or a Hispanic woman, you would see how it would change to the set white man baseline. And it is easy to make a sort of conclusion if we didn't state the assumptions, because again, the model is a very simplistic view of data in general. And we anticipated that, you know, women who are just on the baseline of education make more than men. Even though that this doesn't exactly correspond to real life data, we didn't take into account gender wage gap or any sort of implicit biases when it comes to the hiring process. This is just mere on education level and also on the codependence when it comes to your ethnicity and your race. Because if we were just to see it from our data, Asian women would be making the most money just solely on education level. So there are still a lot of biases that we aren't able to tabulate yet, but we can sort of see or make some sort of simplistic conclusions based on the data sets.
Right, that's all we had. Thank you for seeing us. And this is a little chart we added at the end of our like logic train. These are like the equations we wrote on the whiteboard, and then it kind of looks like a fish, and our team is koi pond, so we thought that's cute. And this is our mascot.
Here's what the whole whiteboard looked like if there were people curious as to the process that went into making this notebook.
Wow. But thank you all, and congratulations again. I want to say that whiteboard shot is epic. Epic. Yeah. I'm glad you got a picture of it. It's epic. And again, congrats and thanks for participating in the Student Data Jam contest. And hope you participate in more when we have them down the road.
Yeah, thank you very much.
All right. Okay, humans. I'm going to pass it to Observable's co-founder and CEO, Melody Meckfessel, to close us out for Observable Insight. Melody, welcome to the stage.
Thanks so much, Wayne. And congrats to Team Koi Pond. Seeing that whiteboard was incredible. Oh, that's great to see. So it's really been an amazing couple of days. I just want to take a couple minutes to close out the conference. Our first community Observable Insight. We had over 1,400 people registered to attend and averaged about 300 attendees throughout the last couple of days. So folks were coming in and out as they were interested, and that's just great to see that interest. We had some new interested ambassadors to engage around the community and had over 120 folks join the community Slack, which we're going to continue to support and share information on that Slack. I just wanted to share that we've been trying to share materials real time. There's a lot of video footage we're going to go through, so we expect most of the materials will be ready and published in the next week. We hope over the last couple of days that you learned some best practices and tips from all the community talks that you heard. We hope that you saw data in action to be able to create and build an observable, dashboards, visualization, perform data analysis, and use Observable to teach various techniques. We hope you heard some of the interesting customer stories about how organizations are using Observable. These are stories that don't often make it out to the public, and we hope that they offered you that kind of behind the scenes, backstage pass to see that part of Observable's community. We also hope that you learned some new features, some new techniques from all the demos that you saw. There was one this morning that Mike Bostock presented. We're going to be excited to reshare that so that you all can see that after the conference. We also hope that along the way, you were inspired. Maybe you got some new ideas that you're going to explore. We hope that you met some new folks and you were able to connect with other people in the community. And we hope that through all of that, you learned more about what's possible on Observable. If you're new to Observable and you're just getting started, we hope that you will join the community. You can check out tutorials on the site. You can start to create your first notebooks. We have quick start guides to explore, in fact, some of the data sets that you saw over the last couple of days. You can connect with the community on Slack and in the forum and ask questions. And you can collaborate on shared interests in Observable. So every Thursday at Observable, the Observable team does a stand-up that's just devoted to gratitude and kudos. It's really some of us the most favorite time of the week. We just say thank you because life is short and gratitude is important. How we say thank you to folks that help us, like the small things and the big things. So I want to end by just saying thank you to everyone here. I'm so grateful for the ability to kind of see all the different workflows about how people are creating data viz and dashboards, data analysis techniques. It's incredible what we were able to learn and see today. So thank you for that. I want to say thank you to the community team, specifically Courtney, Hannah, and Wayne for all of the organization and work they put into the last 2 days. And I also want to say thank you to the Observable team for being ready to support and answer questions and be available. I want to say thank you to you, the entire community, who are committed to making Observable a better place, to sharing what you know, to your generosity of sharing your work and your ideas with the world. And thank you for collaborating with data. I think we really believe at Observable that the way we learn and share is to do it together. And so thank you for that. And I, of course, want to say thank you to all of the speakers who shared their work, their ideas, their passions, their knowledge on such a diverse set of topics. Thank you for inspiring us. Thank you for being here. At Observable, we will strive to make Observable the platform, the community, the place, the best place to use data to gain insights from data and across many different industries, as I hope you got a little bit of a taste of over the last 2 days. Educational institutions, companies like Stitch Fix, the Marshall Project, UC Berkeley, so much diversity of what we were able to see. As a community, we believe we are building this together, a place to explore, analyze, and communicate with data. And Observable's here to help everyone make sense of the world with data together. Thank you so much, everyone, for being here. We can't wait for the next Observable Insight conference. We hope to connect with you on Observable, in Slack, and out in the world. Thanks again. Thanks for being here, and I wish you all the best. Back to you, Wayne.
Thanks, Melody. And plus one to everything you said. And I did want to say one more thing for a wrap up of Observable Insight. Someone has a special birthday tomorrow. It is Melody Meckfessel. So in the chat, if everyone can wish Melody a happy birthday, as he has a pre-happy birthday, and we close out the session. Thank you all. See you online.